Are you ready to level up your Spring Boot skills and dive into the world of Kotlin? In this course, you'll learn how to build a real web app using Spring Boot and the Kotlin programming language, two skills that are in high demand in today's job market. These are the skills that I use every day as a professional software developer, and by the end of this course, they'll be your skills too. We're going to build a fully functional bookstore web application. We're going to focus on the back end, and I'm going to provide the front end code for you. You're ready for this course if you already have a foundational knowledge of using Spring Boot with Java. That's the sort of thing that you'd learn on the Spring Boot for Beginners course, or if you're short on time, the Spring Boot Crash course, two courses that I have here on YouTube for free. Building on this foundation, we're going to learn how Kotlin can make your code more expressive, concise, and null safe. We'll integrate with a real PostgreSQL database. We'll implement REST APIs and cover the best practices for building a web app for production. As for the approach, I'll be playing the part of the senior developer on your team. I'm going to guide you through each of the steps, explaining my thought process, and try to preempt any questions you may have. If you have further questions, or perhaps get a little stuck, or maybe just want to read through the lesson materials rather than watch them, then you can find all of this and more on the DTO community site. This standalone, no-holds-barred course packs everything that you need to know within 6 intense hours. By the end of this course, you'll have a Kotlin web app to showcase in your portfolio. And for those hungry for more, there is an advanced premium section of the course with even more in-depth content. You'll find all the details in the description below. So, are you ready to transform your coding skills and build something real? Let's get into it. Okay, so what are we going to build in this course? It's better to show you than it is to explain it to you. So check this out. So here we have our very own bookstore application. The idea behind this is it will be a website that you could go to and potentially purchase books and learn a little bit more about their authors. If we were to say click on Margaret here, we can see a picture of Margaret, we can see a little description, and then we can see the books that Margaret has written, which in this case is Beyond the Abyss, A Fisherman's Tale. It goes without saying, but all of the authors and books in this application are completely fictional. So as for the books page, fairly similar. We've got a picture of the book here, we've got a little description, and then we've got some features like add to basket, add to wish list, although we'll not be using that feature in this course. These aren't implemented, but pretty much everything else in the application is working as you would expect a bookstore to work. So you've seen the home page, we've seen the details pages, we've also got the list pages, so the authors list and the books list. So you can see all of the authors in the application here, and then there's all of the books in the application here as well. In addition to this, we're obviously going to need some way of managing all this data. So there is an admin panel right here where we can go ahead and edit and add and delete authors and books. For example, here is the details for Margaret Garcia. Very similar on the book side. If we go over, we can see that we've got a book here called Mundane Dolphins. If we were to go in, we can then edit that description, title, author, ISBN, etc., etc. So it's worth noting the free version of this course will get you as far as this app. We'll build this together, you'll have it locally, and you'll be able to run it and interact with it. The premium version of this course will take the application, we're going to secure it with some pretty advanced Spring security, we're going to integrate it with a third-party user management system. We're then going to package it up, deploy it to the cloud, to production, and then we'll have it there where we can interact with it, and we're going to be able to monitor it as well. This is everything you typically do if you are running an app for yourself, or if you are running an app as a part of being employed by a business. You're going to need a few things for this course. They're all completely free and they can be downloaded from the internet. You're going to need the Java Development Kit, or JDK, in order to write Kotlin for the JVM, but more on that in a moment. I'm going to be using JDK version 21, which is the latest long-term support release at the time of filming. You'll also need an IDE, or integrated development environment, and this is the tool that we'll use to write and run our code. Now I'm going to be using IntelliJ IDEA, the community version, so the free version that you can download from the JetBrains website. You'll also need Docker installed on your machine. We're going to use this to run some of the dependencies for our application, such as the PostgreSQL database. Finally, in order to run the front end, you'll need Node installed. Now I'm going to be running Node version 20, which is the latest long-term support release at the time of filming. I'm going to leave a link to the installation instructions in the description below. But if you'd rather see the installation lessons, then you can check these out on the DTO community site. All right, so let's get everything installed and then let's get started. Okay, in this lesson, we're going to answer the question, what is Kotlin? And the short answer is that it's a programming language that you can use to build apps for web, for the desktop, for various different platforms. The Kotlin programming language works almost seamlessly with the Java programming language, and they really do have a lot in common. But to fully appreciate this, we're going to have to consider what the world looked like before Java. So let's pretend way back then you were a software developer, and software developers write code. That much hasn't changed. So most of the software that we wrote back then was tied to a platform, which is a specific blend of the hardware and the software that ran on that hardware. So things like the operating system. So we said the software we write is tied to a platform. So what happens when, say, that operating system changes or there's a new version released? We're going to have to build some new software to account for that. We actually need to change the code that we write to account for that new version of the software. And of course, the same can be said for hardware. When we're writing our code, we need to account for the different hardware, maybe the different ways of saving a file, for example. So the code that we write is really influenced by the hardware and the software, the operating system that our code runs against. Now, as you can imagine, that was a lot of work. Then along came Java and solved this problem with something called the Java Virtual Machine, or JVM. Now, the JVM was a big deal because it abstracted away all of the platform-specific stuff. You see, all of the platform-specific stuff, well, that was handled by the different implementations of the JVM for those different platforms, which was great for developers because you only had to write the code once, and then it would work on all of these different platforms. We don't need to account for it in our code. So the way that Java did this is that the Java code was actually compiled to something called bytecode. And it's this bytecode that's the actual instructions to the JVM. This is the code that the JVM runs. And regardless of the machine that the Java code was compiled on, that bytecode can then move to any different machine with a JVM and run there absolutely fine. Up until then, that was something that was a complete fantasy. And with that, Java introduced the write once, run anywhere software. But fast forward to today, and as it turns out, Java isn't the only programming language that can compile down into bytecode and run on a JVM. Kotlin is another such programming language. Now, Kotlin certainly wasn't the first language to do this. You've got languages like Scala and Groovy, which did it before Kotlin, but Kotlin has done an extraordinary job, as you'll find out during this course. So this begs the question, why write Kotlin at all and not some other programming language? Well, if you're taking this course, can imagine that you're probably already interested in Kotlin, but there's a couple of key benefits. First up is that Kotlin is a super expressive syntax, which, despite being super expressive, is also fairly obvious. If you come from Java or a different programming language, you should be able to look at some Kotlin and sort of work out what's going on without knowing anything about the programming language. Obviously, your mileage may vary. The second one, and perhaps the biggest one, is Kotlin's built-in safety features. In Java, any object can be a null, and you don't really know if it's a null right up until the point that you check that object, you go to do something with it. Kotlin, on the other hand, makes it super obvious when an object could be null or will never ever be null, and you'll find out more about those features later on in the course. And then you got other things like the data classes, a type inference, loads of things that makes it easier to write your code and ship it to production faster. And of course, because it runs on the JVM, you write that Kotlin code once and it can run on any platform that has that JVM installed. And dare I say it, it's pretty fun to write too. In this lesson, I'm going to teach you how to run the React frontend that we provide on a Windows machine. So I'm going to assume a few things for this one. One, that you've already cloned down the project and you have it somewhere on your machine locally. And secondly, that you've installed Node and have that working locally as well. So here I've opened up a command prompt and I've navigated to where I've stored the React frontend locally. The first thing I'm going to do is say npm install, and that's going to install all of the dependencies that frontend needs. With the dependencies installed, we're now going to type npm run start, and this is going to start the application running. We'll click allow, and there we go. We have the Bookstore React front end running in our browser here. It's worth noting the backend isn't running for this, so at the moment we have messages like unable to get books and unable to get authors. As we implement our backend, these features will become available to the front end. So let's get to coding. Here I have the Spring Initialzr open up in a Chrome browser. So that start.spring.io will give you this tool. And this is a tool that we're going to use to generate for ourselves a skeleton Spring Boot project using the Kotlin programming language. Technically, you could create all of the files yourself locally, but we're not going to do that because it takes quite a bit of time. It's quite error prone, and this tool is just going to do it for us. So once we've gone to start.spring.io, we'll see this, and we're going to select a few things. First, we're going to select Maven as our build tool. You can absolutely use Gradle, but we're going to be using Maven for this course. And now we're going to select the version of Spring Boot. We're going to use 3.2.5 here, which is the latest general release version at the time of filming. Spring Boot versions are released fairly regularly, so chances are you may see a different number from what you're seeing here. If that is the case, then what you'll need to do is take a look at the versions here, disregard anything with an RC or snapshot next to it. RC stands for Release Candidate and Snapshot is the latest development build. Both of these will have more features than your general release version, but they will be less stable, so I do recommend going for the general release version. And now we'll fill in some project metadata. So this is really just to identify a project. I'm going to use the group of com.dev.tiro. The convention is usually to go the opposite way of whatever your business website is. devtiro.com, com.dev.tiro. You may use something different. It really doesn't matter too much for this project. The artifact, I'm going to call this the bookstore, because that's the application that we're building. You can see that already pre-populates the name there. And now a description. So we're going to say a Kotlin course bookstore. Again, you can add whatever you like in here. And the package name is going to be com.dev.tiro bookstore. I'm more than happy with that. That's absolutely fine. And now we'll select our packaging, either a jar or a WAR. Select jar. The difference being is that a WAR file needs to be deployed to a running application container, something like Tomcat that's already running. You take your WAR file and deploy it to that Tomcat. Now, this is the traditional way of doing things, but it's really fallen out of favor, and that's because there's a much easier option, and that's to use jar. When you use jar, Tomcat is already bundled inside of that jar. So rather than have to deploy your WAR file to a separate Tomcat, Tomcat is already bundled inside of that jar. You just run your jar and everything just works. So in summary, WAR needs a running Tomcat that's separate from your application and takes management, etc., etc. A jar file has everything you need. You just run the jar and your application runs. Use jar. And now select our Java version, and we're going to go for 21. So 17 was the last long-term support release. 21 will of course have more features than 17 and is also a long-term support release. 22 will have more features than 21, but it isn't a long-term support release. The long-term support releases, they're out for the longest, they're supported the longest, so they're the ones that we want to go with really. So we're going to go with 21 here. And now we'll select some dependencies. We will add more dependencies as our course progresses, but these are the ones that we're going to need to start with. So first we're going to need a database. So we're going to go with the H2 database. So this is an in-memory database, which means it runs when our app runs and it will run in memory. This will get us going quick because we don't need to install and configure everything in order to run with a separate database. We will be using PostgreSQL a little bit later, but for the moment we'll use H2. Now we need a way of interacting with that database. So I'm going to select Spring Data JPA is our next dependency. That will give us an abstraction layer, which will allow us to interact with the database using Kotlin objects. We won't have to write any SQL. And finally, because our bookstore front end is going to interact with the back end using a REST API, we need some way of implementing that REST API. So we could go with Spring Web or we could go with Spring Reactive Web. Now, feature-wise, they're fairly comparable. Spring Web is the more traditional route and uses Apache Tomcat and the servlet spec. And then Spring Reactive Web is perhaps the newer way of doing things, and that uses Webflux and Netty. Now we're going to go with Spring Web because arguably it's simpler to code and we're not going to be streaming a large amount of data here, so Spring Web should do us nicely. So with these three dependencies, we have a database, we have a way of interacting with our database, and we have a way of building a REST API, and we're going to do the business logic. So this is everything that we'll need. Let's go ahead and click on generate, and this will download our project. Great, so that's downloaded. We just need to open this up in our IDE now, and we should be ready to go. So here we have our project opened up in our IDE. So you'll get several prompts when you open this project up. The first one is whether or not you trust the project. Obviously, this has security connotations. I trusted the project and I have it open up here, your choice. If you're on Mac OS or Linux, that's all you'll need to do. If you're on Windows, you may get prompted to say that Windows Defender may need to be configured in order for IntelliJ to work efficiently. Again, I've decided that that's absolutely fine. Again, your choice if you're on Windows. And just like that, we're ready to go. So let's take a look through this project and see what we've got. Okay, so let's go on a quick tour of this project then. Let's start with the pom.xml file here. So this is where all of our project dependencies are declared, including our Spring Boot dependencies. If we take a look through here, we can see we've got Spring Boot Starter Data JPA, Spring Boot Starter Web. Those are the ones that we selected when we're in the Spring Boot Initialzr. Now, what's not immediately obvious is things like the Spring Boot Starter Data JPA, the Spring Boot Starter Web. These are actually written in Java. Yes, we're using the same dependencies, regardless of whether or not we're using Kotlin or Java. You do get some extra bits with Kotlin, but they're basically the same dependencies. And that's perhaps our first bit of proof that Kotlin is interoperable. It works with Java. Now, what about those Kotlin dependencies? If we do a search for Kotlin, we can see we've got a few dependencies here. We've got the standard library. So this is where the majority of all of our Kotlin stuff is stored. All of our Kotlin dependencies, everything we're going to need in order to write Kotlin. At least the vast majority. That's all going to be contained for us within Kotlin standard lib. Now, Jackson module Kotlin, traditionally, that's the tool that we would use in order to take a Java object, convert it into JSON, and then convert JSON into a Java object. Of course, Jackson was written for Java. Kotlin has some additional features. So in order to make sure that everything works nicely in Kotlin, we include this Jackson module Kotlin. And with that, we can take Kotlin objects, convert it into JSON, and convert JSON into Kotlin objects. And then we have the Kotlin reflect dependency. Now, reflection, at least in Java, was when Java code could ask questions about itself at runtime. And that was used by libraries such as Jackson in order to do some pretty clever stuff. Now, we're not going to be using reflection, at least not directly in this course, but in order to bridge the gap between Java reflection and Kotlin reflection, we'd need this Kotlin reflect dependency. Yep, there's our H2 database, and there we've got some test dependencies. But let's take a look at our plugins here. So here we have the Spring Boot Maven plugin, which makes Maven work with Spring Boot. So you can do things like compile a Spring Boot project, or you can run a Spring Boot project from the command line from Maven. But this has some additional configuration because we have a Kotlin project. And perhaps the most notable is right here, we have the Kotlin Maven plugin, and that's going to allow us to compile our Kotlin code into bytecode that runs on the JVM. So this is configured with several configurations here, including some compiler plugins, one for Spring and one for JPA. So we're using Spring, obviously, and we're also using Spring Data JPA, so we're using the JPA specification. These compiler plugins make it so something that was written for Java, in this case Spring and Spring Data JPA, can work with Kotlin. And then we have some additional dependencies here, including the Kotlin Maven All Open and the Kotlin Maven No Arg dependencies. Now, I'm not going to go into specifically what each of these dependencies do because I feel it might confuse matters a little bit. However, what's worth noting is that Java and Kotlin compiles down to bytecode, but by default, the bytecode is ever so slightly different depending on the approaches of those programming languages. Now, because Spring and its ecosystem was originally written for Java, we're going to be writing Kotlin. These dependencies are needed in order to bridge that gap so everything works nicely, seamlessly, and interoperably. So I think that's it for the pom.xml file. Let's take a look at our project. And the first thing that I think should be obvious is if we take a look here, we've got source main Kotlin, not source main Java. I think that one's pretty self-explanatory because we're writing Kotlin code, right? Now, if we take a look at the bookstore application.kt being the file extension for a Kotlin file and not .java, which of course is going to be a Java file, we have ourselves here our first bit of Kotlin code. So anybody familiar with Spring Boot will be familiar with this @Spring Boot application annotation. So this marks our application as a Spring Boot app and also marks the entry point to the application. So where the flow starts for the application. Now, what's perhaps quite weird here is that it's on top of a class, but the class is declared with the class keyword and the class name, but nothing else. So the concept of a class in Kotlin is very similar to the concept of a class in Java. However, when the class doesn't have anything in it in Kotlin, it's completely okay to omit the braces that would go after the class declaration here. You can see here the IDE actually grays them out. So it's completely valid to have a class declaration within a single line. And then we have our main function, which looks pretty weird when you're used to Java. So the first weird thing that I noticed about this is that it's not within a class. It's actually just within the file, at the top level within the file, which is something that you can do in Kotlin, and in the case of the main function, something you need to do. So the main method in Java takes arguments, and we can see here this also takes arguments, but the way that we declare them is backwards. So we're actually saying the name of the argument first and then the type of the argument. So it's still an array of strings, but in this case, we say the argument name first and then the type. We can also see the way of declaring an array type here in Kotlin is different from Java. Here we're using the array keyword, but in Java, we would use those square brackets. Within the function though, looks quite similar. We're using run application, which is what we would use in a Java Spring Boot application here, passing our arguments to it. And we have our type here of bookstore application. So this references this class right up here. If you continue to look at this main function, you'll notice there's even weirder things about it. For example, there's no public keyword. In Kotlin, as it turns out, the default access modifier, or as we say in Kotlin, the visibility modifier is public. So if we miss off the accessibility modifier, the visibility modifier, by default, it would be public. So this is actually a public function main. You also notice when we compare it to Java, there's no static keyword here. Static, well, there's actually no static keyword in Kotlin. And you might think that's a problem, but you'll learn as the course goes on that it's just not actually needed in Kotlin. A hint is that we have our main function at the top level in the file. It's not within a class. And Kotlin sees that as the equivalent to the static modifier in Java. Okay, so that's enough of our production code. Let's take a look at our resources here. So we have our application.properties, just like we would do in any Spring Boot application, and it's completely the same as what it would be in Java. Let's skip over to our tests now. So we can see here we have our default test, and that's called bookstore application tests for our bookstore application. So this looks fairly similar to how a test class would look in Java. We have a class here with a single test, and all that test does is make sure that the Spring context loads, and that's possible because we're running it with inside of the @Spring Boot test annotation, which is going to start up a test Spring app, including that Spring context for us. While we're here, let's just run these tests and make sure that everything runs absolutely fine. Looking good, we've got a green tick there. And if we wanted to go ahead and run that application, let's click the green tick next to the main function. Okay, that's our app started up. We open it up in our browser now. And if we hit our application, which is going to be running on localhost 8080, we can see that the application currently does nothing at all. So let's change that and let's get started by implementing our domain. In object-oriented programming, we model real-world objects in our software, and we need a way of representing the objects that we care about in this application. So that's what we're going to explore in this lesson. So there are two main objects in this application that we care about. The first one is the author. Authors write books. And the second object is the book. So the book that the authors have written. So the relationship that we have set up here is that an author can write many books, but a book can only have one author. So we can model this domain in a number of different ways. If you take a look here, we have ourselves an entity relationship diagram, an ERD, or if you prefer, an ERD. So if we take a look at this diagram, we can see all of the different properties that these different objects have. So in the case of the author here, we have the ID, which is numeric, 1, 2, 3, etc. We have the name property, which is text. So this is just going to be the name of the author, John Doe, for example. We have the age property, which is just the age of the author in years. That's a number, so that could be 24, 48, for example. And then we have the description, which again is text, and this is just going to be a short description about the author. We saw that earlier when we were taking a look at the application in our browser. And then we have the image property, which is text. So this is just going to store a reference to the author's image that we can then use to display in the browser in the front-end application. On the book side, we have some differences here. So the ID in this case is the ISBN. So this is a convention that's used to identify books, and each one is completely unique. We will represent ISBNs as text, whereas we've represented the ID for the author as a number. So the title property is the title of the book, and we're storing that as text. So that is just the title of the book, exactly what you would see on the front cover. The description is text again, and that's just a short description of the book summary. You can sometimes find these on the back of the book. And again, we have the image property, which is text. So this just stores a reference to the book's image that we can then use on the front end to display that image. And this is enough domain to get us started. So let's head over to the IDE, write some Kotlin and implement our domain. So let's write some domain classes using Kotlin. So the first thing I'm going to do here is go up to the ComDev Tiro bookstore. I'm going to create a new package. I'm going to call this package domain. Now this is where we're going to store, believe it or not, our domain. Now inside of our domain package, we're going to create a new class, but not the Java class here. We're going to go to Kotlin class/file. Clicking on this, we'll make sure that class is selected here, and I'm going to create the author to begin with. So capital A, author. The naming conventions for a Kotlin class are identical to the Java naming conventions. So capital A, author. So now we have a choice to make. I can either talk you through creating a class step by step, or I can create an initial class. We can explore that and then we can build on top of it. Now I'm going to choose to do the latter because in creating classes, there's quite a few differences between Kotlin and Java, and it's worth just getting over that initial hurdle before we then start to build out our application. So there we go. So here we have the initial class declaration for our author, and here we have the initial class declaration for our book. So if we start with the author, we can see we use the class keyword in order to declare a class in Kotlin, much the same way that we do so in Java. However, what's different from Java is if we take a look after the class name here, we can see a set of parentheses. And inside those parentheses, we can see ID, name, age, description, image, which are the properties that we had back on our ERD. We can see that we're using this keyword var here. What's that all about? We can see that we have the name of the variable first and the type second. Yeah, we've already seen that before. What's with this question mark? And these are all good questions. So let's start with what these parentheses are next to the class name. So in Kotlin, this is called the primary constructor. So in Kotlin, you can have one primary constructor and multiple secondary constructors. The primary constructor is always declared in the class header there right after the class name. So the primary constructor declares the class's properties, which for the moment we can think of as Java instance variables, but we'll learn a little bit more about the distinctions in future. It's also where the types of each of those properties are declared. So ID, long, name, string, and it creates for us a constructor with all of these properties, sometimes called an all arguments constructor. So we can create a brand new author object by passing all of these properties in, and then we get our author object. Unlike Java, the primary constructor can't contain any runnable code, but as you'll soon learn, that's not strictly needed in Kotlin. There are ways of dealing with that. So a moment ago, I said the word property, and I said we'd learn a little bit more about the distinction between that and an instance variable. So let's dig into that a little bit. In Java, you might declare an instance variable inside of a class. And then you may also declare a getter method and a setter method in order to get the value and set the value on that instance variable. In Kotlin, you just have a property. It abstracts all of that away for you. So you would create a property, which you can see that we've done here in our primary constructor, and then you get a getter function and a setter function for free, and it's named the same thing as the property. So if we wanted to get the name of our author, we would call .name on our author, and the getter would return the value for our name property. The same, of course, can be set for setting. We would just call .name, passing in a value, and it would set that value. But there is a nuance here, and that has to do with the var keyword, and we'll learn about that in a little bit. So let's do a quick summary of what we have here. So on the author side, we have ourselves an author class with a primary constructor, and we have ourselves the properties of ID, name, age, description, and image. On the book side of things, we have ourselves a book class with a primary constructor, and we have the ISBN, title, description, image, and author properties. We can see here that we've got an author property referencing the author class. So I mentioned a little bit earlier, there's a bit of a nuance when it comes to the var keyword. It's not the only way of declaring for ourselves a property or a variable. Val would work just as well. So what's the difference? Well, that all comes down to mutability. So broadly speaking, mutability refers to being able to change something's state after it's been initialized. In Java and Kotlin, there's quite a lot of nuance here because we use the word mutable to refer to both the variables and the values that go into those variables. If that seems a bit confusing, don't worry, let's explore an example. So let's start with Java. How would we declare a variable in Java? Well, it might look something a little bit like this. So here we have the variable called SomeString that can store values of type string. So we can go ahead and do things like assign a value of pen, the string pen, to the variable SomeString, and that's completely valid. we could also reassign the value to that variable. So here we reassign the value pineapple, the string pineapple, to the variable SomeString. And again, that's completely valid. We say that the variable SomeString is mutable because we can reassign different values to it. We can change its state. And that's true right up until we start using the final keyword in Java. So if we were to declare some other string using the final keyword here, the Java compiler will actually force us to declare a state of value for that when we declare it. So here we declare a variable with the name SomeOtherString that can have values of type string, and we assign the value of the string pen to the variable SomeOtherString. And we're using that final keyword. So we now have an immutable variable. So if we try to do the same thing and assign a new string to the variable SomeOtherString, because it's immutable, it wouldn't work. The Java compiler wouldn't allow us to do this. So this is an example of a variable in Java being mutable and then immutable when we use the final keyword. So far in this conversation, we've been concerned with the variables, but I did mention that the values in those variables have their own mutable, immutable status, separate from that of the variable. So consider this line of Java code right here. So we have the string pineapple, and we're calling the method substring on there with the value of 4, which is going to give us the string apple. So what do you think happens here? Do you think the string pineapple is changed and that string returned? Or is a new string returned? The string pineapple remains unchanged and a new string apple is created and returned by the substring method. Well, the answer is the latter. Strings are immutable in Java and by extension, Kotlin. So what that means is once a string is created, its value can never ever change. In this case, the substring method creates a brand new string, apple, and returns it. It does not change the pineapple string. So whether or not an object is mutable or immutable in Java, and by extension Kotlin, depends on its type. For example, we've already mentioned that the string type is immutable. It cannot be changed once it's initialized. However, the string builder type is mutable and can be changed after it's initialized. For the details on which objects are mutable and which are immutable, you can always check out the docs. But the takeaway for this one is that Kotlin does things in the same way as Java, at least behind the scenes. We have the concept of immutable and mutable variables, and also mutable and immutable values. The big difference though is how Kotlin approaches this, and that's by using the val and var keywords. So let's explore the val and var keywords in Kotlin. So in Java, we mentioned already that you can declare an immutable variable by using the final keyword. So you can see here that we're declaring the variable SomeString, assigning the value pineapple. And what that means is if we try and reassign the value of SomeString, in this case to pen, it's not valid. The Java compiler will prevent us from doing that. So how do we use an immutable variable in Kotlin? Well, in that case, you would use the val keyword. You can see that we're declaring the variable SomeString again, in Kotlin this time, assigning the value pineapple, and when we try and reassign the value of SomeString to pen in Kotlin, the Kotlin compiler is going to prevent us from doing that. It's not valid. So that's immutable variables in Kotlin. Remember that the values still follow the same conventions as Java. A variable can be mutable or immutable, and a value can be immutable or mutable. It depends on that type of value. So that's an immutable variable in Kotlin, the val keyword. What about the var keyword? Well, you may have guessed it. In Java, we can declare a mutable variable by not using the final keyword. In this case, we declare a variable SomeString, assign a value pineapple to it, the string pineapple, and we can reassign that, in this case, using the string pen. That's completely valid in Java. The Java compiler thinks that's fine. But how would we do that in Kotlin? Well, we would use the var keyword. So if we take a look here, we have the variable sum string. We're assigning the value pineapple of type string to the variable sum string. Of course, that's absolutely fine. And then we're able to reassign the value pen to sum string. And because we've used that var keyword, the variable sum string is mutable, and that's completely okay in Kotlin. So like Java, Kotlin has the concept of both immutable and mutable variables. So which one do you use? Well, as a general rule, you should always use the val keyword, always default to immutability where you can, and only use the var keyword, mutability, when you absolutely need it. And this is a convention that's documented in the Kotlin docs. With all of that sorted, let's move on and explore type declarations a little bit more in Kotlin. So let's take another look at how you would declare a variable in Kotlin and declare its type. So if we take a look here, we have ourselves an immutable variable called name, which stores the string Aaron. So the string Aaron is assigned to the immutable variable name. But if you take a look at this, do we really need that type declaration? Because it should be obvious that the value that's being stored in name is of type string, because there it is right there, the string Aaron. Well, Kotlin agrees with that opinion too, so it's completely valid to miss off the type declaration and simply assign the string Aaron to the val of name. Kotlin is able to work out that the variable name stores type string. There are times like this when you can miss off the type declaration. It's optional, whereas there are other times when it's absolutely needed. One such example of that is the primary constructor, because Kotlin has no way of knowing the type that's going to be stored in each of those variables. Now, the good news is that if you're using an IDE such as IntelliJ, it's going to point out for you when a type is required and when it's optional. It will give you an error when you haven't declared the type and it's needed, and it will grey out the type if you provided it and it's optional. Of course, the Kotlin compiler will also tell you when you come to compile. So let's go back to our IDE and review what we know. So we know here that we have a class of author with a primary constructor. We know that we've got several properties: ID, name, age, description, and image there. We also know that because this is a primary constructor, the type declarations are required: long, string, int, string, string. We can also see that we're using the var keyword, and we said that we want to use the val keyword by default because we want to default to immutability. So let's go ahead and change that now. And that's looking pretty good, but what about our book class? Well, over here things are looking pretty consistent. So we have a class declaration of book, we have our properties in there, we have the types declared. We are using vars, so let's change those to vals. And that's looking pretty good to me now. But you notice we skipped over one detail. If we go back to the author here, we have this question mark next to the type of long. So what's with that question mark? Well, let's discuss that in the next lesson. But what's with the question mark? Well, that's Kotlin's way of declaring a nullable type. You see, Kotlin has a very different approach to Java in how it handles nulls, remembering that null is the absence of a value. So in Java, any object can be null, and you don't necessarily know if that object is null or not, right up until the point that you try and check the object or call a method on that object, and you may get the dreaded null pointer exception. In Kotlin, you have to declare when an object can be null. The default is that it will never be null. You declare that an object could be null by placing a question mark after the type declaration. The Kotlin compiler will then use this information and give you errors when you're not handling null cases. And this is one of Kotlin's big safety features. So let's take a look at an example here. So here we have the variable name and it's mutable, so we can reassign its value. We're initially assigning the string value Aaron to the variable name. Now, if we try to assign null to the variable name, the Kotlin compiler would prevent us from doing so. It's not valid. However, if we declared the variable name with a question mark after the string type, we can see here we're doing the same thing. We're assigning the string value Aaron to name in the first instance. If we try to assign null to name in this case, it would be completely valid and the Kotlin compiler would allow us to do so. And it's all because we've declared that variable with type string and a question mark. It's a nullable type. So why go through all of this effort? Well, the Java null pointer exception, which is the result of trying to do something with an object that's actually a null, has cost a lot of money and caused a lot of problems. So we want that handled explicitly. And that's why we use these nullable types, to reduce those chances of a null pointer exception. So how do we handle these nullable types? Well, there are a number of different ways and it all depends on what you're trying to achieve. So we're going to explore each of the different ways as we build up our application. So if we take a look at our IDE once more, have we covered everything? Well, almost. We're familiar with a long from Java and a string from Java. However, we're not familiar with an int. We know what an integer is, but what's an int? Well, let's explore that in the next lesson. So Kotlin offers interoperability with Java, but as a language all its own, there are going to be some gotchas. For example, a Java developer might want to use the integer, which is the object equivalent to the primitive of int. Now, both are used for storing numeric values, but if you use integer, you can null it out when you need to, and you can store it in collections, something you can't do with primitives, such as int. Now, if you try to use integer in Kotlin, you'll see that it imports from Java lang integer, which is different when you use something like a string, which is in the Kotlin standard library. So in Kotlin, you would use an int, that's a capital I, rather than an integer. But is that a primitive or is that an object? So in Kotlin, you can't declare primitives, at least not in the Java sense. Instead, you would use objects such as string and int, capital I. And this is where the magic happens, because when your Kotlin code is compiled into bytecode, the Kotlin compiler will decide whether or not to use a primitive or an object. As a reminder, primitives have less overhead and are usually more efficient to use. However, objects have additional functionality, such as being able to be null and also being able to be stored in collections. So this all happens behind the scenes and you don't have to worry about it. But what usually happens is when you use a straightforward int, capital I, the Kotlin compiler may convert that into a primitive int, such as what we use in Java. However, if you declare an int with a question mark after it, use a nullable type for example, chances are the Kotlin compiler is going to use the integer class, such as we'd use in Java. So does our book class and our author class do everything that we need them to? Well, let's put that to the test in the next lesson. So now that we know how to write a class in Kotlin, let's see if it gives us everything that we need to write the rest of our application. So for comparison, let's take a look at our author domain object as if it was a Java class. So there is a lot going on here. So first we have a set of instance variables. These are all private, so the instance variable name and its type. We also have a no-ars constructor, so we can construct the class without providing any arguments here. We also have an all arguments constructor, so we provide all of the arguments and then they are initialized on the class's instance variables here. We get a new instance of author. And then we have getters and setters for each of our instance variables: get ID, set ID, name, age, description, image. So we have the equals method, which is used for comparing one instance of author to another. Is this author the same as that author? And then we have the hash code method, which is used to generate a hash from this author. This is used in various different ways, but in Java, you might have used the hash map, for example. Well, hash code is used as a part of hash map's implementation. Of course, there are a multitude of different ways that this method is used, which is why it's so important. And then we have the toString method, which converts our author object into a hopefully helpful string. In this case, we get a description of what each of the variables' values contains. So do our Kotlin classes have all of these things just in a single line? Well, let's check that out. And let's start with getters and setters. So we know that our domain objects have state, that's their properties. We also know that they have behavior, that's their functions. Conventional Java wisdom says that you shouldn't access your domain object state directly. Instead, you should use a getter function or method in order to get the value, and a setter function or method in order to mutate or change the value. So why go through all this hassle? Well, one big reason is to hide the internal workings of your class. So let's consider the name John Doe, which is a string. So let's say we wanted to set this name on an object. Let's say it's our author object, for example. What we could do is we could call the setter for name, providing John Doe. At this point, we don't know, and perhaps we don't care, how the class is actually going to store this data internally. What it could do is it could split up the given name and the family name and actually set them on different instance variables privately. And then when we call the getter on name, it could then return the full name. Why is the class doing it in this way? Well, I don't know, but this is the point. We're hiding the internal working. So if the class needed to do something like this for whatever reason, it could, and everything outside of the class doesn't need to know about it. If you were accessing the state directly, you couldn't do this and you couldn't benefit from it at all. That said, this sort of thing, at least in my experience, isn't very common at all, but it's always nice to have the option to do so. As a side note, in Java, this is why developers tend to use things like Project Lombok in order to automatically generate their getters and setters, because this really is the minority case. And the majority case is simply getting from the variable and setting to the variable. So all of this had a bit of a Java spin, but what about Kotlin? Well, Kotlin generates your getters and setters for you. That's all part of declaring a property. It even lets you override those getters and setters if you need to, but that's completely optional. Again, there's a bit of nuance here. When you declare a var in Kotlin, you get both a getter and a setter because a var is mutable. But when you declare a val, you only get a getter because a val is immutable. So what do getters and setters actually look like in Kotlin? Well, they look a little bit like this. So here we create a new instance of author. Note that we're not using the new keyword like we would in Java. We're simply calling author with a set of parentheses next to it, passing in all of the values that would then be used in that all arguments constructor. On the next line, we are calling author.id. This is actually calling the getter for ID on the author object. This isn't accessing the state directly. So if we were to print that out, we would get a 5 because we've set the author ID at 5 there. And for the setter, we can see that we're calling it in a very similar way. Author.id equals setting a new ID, in this case 123. And then when we do a println on that, we get 123 back. So you can see that the Java convention of get name of thing, set name of thing isn't used in Kotlin. We're simply using the name of the property. I did mention that you can create your own getters and setters in Kotlin. You can override them, but as that's not the 80% case, let's focus on the practical stuff for the moment. It's just enough to know right now that you can do that. So we've got getters and setters covered, but what about the other stuff? What about the equals, the hash code, the toString? Well, let's take a look at those in the next lesson. We've got a few extra things that we need to make sure our domain objects can do before we can move on to implementing the rest of our application. So let's start with toString. So here we are back in our IDE, and I'm going to use a feature here which will allow us to interrogate our objects in Kotlin and see what they do. So we're going to do that by going up to this bar up here. We'll go to Tools, we'll go to Kotlin, and we're going to go Kotlin REPL. So the Kotlin REPL is going to allow us to write some Kotlin code, execute it, and see what it does. It's also going to allow us to interact with the code that we have in our project. At the time of filming, this is an experimental feature, but it works well enough that I can demonstrate this. So the first thing I'm going to do is import the author object. So I'm going to copy this package up here. It's worth noting that the import mechanism in Kotlin works almost the same way as in Java. So we're going to say import, name of the package, dot author. And now we can use our author class. So let's create a val, call it author, and we'll create a new instance of author. Note that we're not using the new keyword like we would do in Java. We're simply using the class name followed by parentheses, and now we'll pass in the arguments to our primary constructor. There we go. So there is our author created. So let's call toString on it and see what it gives us. So I'm going to use println. Println is going to allow me to print to the system out. Note that it's just println in Kotlin and not like in Java where you would have to write system.out.println. It does the same thing though. So I'm going to say author.toString. Note that we're able to call the function on author in the same way that we would do a method in Java. And now I'm going to click the play button and see what this gives us. Okay, this is our result right here. So that doesn't look like a helpful toString to me. So I'm going to put that on the to-do list. So let's move on to equals. So let's create a second author here. Let's call it another author. And I'm simply going to copy this line here and paste it. So in theory, this author should be identical. Now in Kotlin, we could call author.equals another author, but there is a shortcut. So we can say author equals another author. So the double equals is a shortcut for that equals function. It checks if these two objects are structurally equivalent, which put simply is going to check that each of the variables have the same value in both objects. Now, on the rare occasion that you wanted to check that the object references exactly the same one in the same place in memory in the JVM, then you would use a triple equals. But we don't want that. We want to check to see if the variables' values are the same. So we're going to use a double equals here. So we expect this to return true because both of the authors have exactly the same values for their variables. Let's see what it gives us. Okay, so it's returned false. So we don't have a properly implemented equals in there. Let's put that on the to-do list. What about hash code? I imagine this is probably just going to give us the default. So let's call hash code on this and see what it gives us. All right, it looks like a valid hash code output. So we'll tick that one off. We'll say that one's okay. Now we could implement all of these functions by hand, but luckily there is a shortcut to do this in Kotlin. And that's with the data class. The data class is meant for classes that hold data, believe it or not, such as our author and our book. Data classes give you all sorts of functionality for free, such as a helpful toString and proper equality checking, and some additional functionality like the copy function, which you'll see a little bit later on. Now we can't use a data class in all circumstances, but as we have a primary constructor with vals and vars for our book and our author, we can in this case. So let's set up our author and our book as data classes. So let's minimize this. Now to declare both the author and the book as a data class, it's really straightforward. We'll simply use the data keyword in front of class. So data class author, primary constructor, and then we must use either val or var for each of those. And the same for the book. Let's go over here and we'll say data class. And then we've got our primary constructor there and it's got vals or vars. So was it really as easy as all that? Well, let's get a new instance of our REPL open so we can make use of our latest code. So let's start with our toString experiment. So we'll import that author, we'll create a new instance like we did before, and then we're going to do a println on the toString. Let's see what this gives us. Okay, that is a much more helpful toString output. So we've got the author there and we can see the values of each of the variables. That is absolutely perfect. So let's do our equality check now. So we'll create a new instance of author, assign it to another author. This author is structurally equivalent to that author, so we should expect true to be returned when we use our structural equality check, our double equals. So let's play this. Looking good. So it looks like our equals function is now working as expected. And while we're here, let's just check out the hash code as well. So let's say another author dot hash code, play this. Okay, so that's looking near enough the same as it was before, but that's absolutely fine. That's a valid output for hash code. Perfect. So it looks like our data class has everything that it needs now. So let's use it to interact with the database. Every good persistence layer connects to a persistence technology, like a database. So let's set up that database connection. So first up, let's take a look at our dependency. So let's go over to pom.xml here. So now we're going to do a quick check to make sure we have the things that we need. So the first one is this dependency, the Spring Boot starter data JPA. This is what we selected when we were setting up our project in the Spring Initialzr. So while we were there, we also chose to use the H2 in-memory database. And I mentioned at the time that was just to get us up and running. So here's what we're going to do now. We're going to use the H2 database still, but only in our tests. For our main code or our production code, we're going to use PostgreSQL, a real database. So what I'm going to do now is change the scope from runtime to test, which means that the H2 database is only used in tests. And now I'm going to include the PostgreSQL dependency there. And this is going to allow us to connect to a PostgreSQL database. So there's a few things to note here. And the first one is that we don't declare a version. And that's because the PostgreSQL driver, this dependency right here, is already declared in our dependency tree somewhere by Spring with the version declared for us. So we don't need to provide that node. And another thing is that PostgreSQL here, it's red. So we need to refresh our POM in order for that dependency to become available. There we go. So that's changed color. And now we have that dependency available to us. If we want to connect to a PostgreSQL database, we're going to need a running PostgreSQL database. And we're going to use Docker for that. So we'll do a quick check to make sure we actually have Docker installed. So I'm going to open up a terminal here. So this is on a Windows machine. The terminal will look ever so slightly different if you're on Mac OS or Linux, but the command will be the same. And that's Docker -- version. Now, if you see something printed out like we have here, it means that we have Docker installed, it's ready to use. If you don't, you want to go ahead and install Docker. If you're on YouTube, take a look in the description below for installation instructions. If you're on the premium version, then take a look at the Docker installation lesson. Looking good, but how are we going to start up our PostgreSQL database? Well, for that, we're going to use Docker Compose. So Docker Compose is an amazing feature. It allows us to define an environment of Docker containers running on our machine. That could be one Docker container, that can be many. And one of the big benefits of this is we can define our environment using YAML configuration, which allows us to create a file in our project to represent our environment and then check it into source control. So let's create that file. So I'm going to minimize this and then create a file in the root of the directory, straightforward file, and I'm going to call that docker-compose.yaml. And we'll populate the file with this content here. I'll put a link in the description below for this. It's commented up, but let's go through it quickly. So we are defining a set of services, and we're defining a service called DB, which is our database, which is PostgreSQL. We know that because we're defining the name of the Docker container here using the latest version of Postgres. Now, Postgres runs by default on port 5432. So what we're doing here is mapping the Docker containers port 5432 to our host port of 5432. So what that means is we can access a database as if it was running locally outside of Docker on port 5432. A minor thing, but if the Docker container accidentally stops, we want it restarted. And now our environment variable. Now this is something you should not do in production, but as we have a local environment that we're using for a tutorial, this is okay and the easiest way forward. We pass in this environment variable here, Postgres password, in order to tell the Postgres Docker container what the password should be for the default user, Postgres. As a general rule, you don't want to represent passwords in plain text and you don't want to check them into source control. This should only ever be used for local development. When we come on to deploy it to production, you'll see that we use more secure mechanisms in order to keep that password secure. Oh, and yeah, we're not using this password in production. We use a new one, a secure one. But for local development, the risk is minimal. So this is okay. So we have Docker installed. We have our environment specified here with our PostgreSQL container. How do we start it up? Well, we're going to open up our terminal once more, and we're going to type docker-compose and up. So this is going to pull down the image, the Postgres image that we need in order to run our container. I'm going to allow that to run. Now, if you got an error when you run Docker Compose up and you definitely have Docker installed, just make sure that Docker is running. You can do that by running the Docker desktop application. We can see here that the engine is definitely running, Docker is running, and we can see here our application, DB, and there's Postgres running as well. And just like that, we have a running instance of Postgres. Let's now connect to it from our app. There are several ways to configure a Spring Boot application. For the moment, we're going to use the configuration file. So here we are back in our IDE. We're going to go source, main, resources, and then we're going to open up application.properties. So the first thing that we want to do is tell Spring that we want to connect to a PostgreSQL database, and we do so with this line right here. So what we're saying is that driver that we included in our pom.xml file earlier, the PostgreSQL driver, that's the one that we want to use to connect to our data source, the database. Next, we want to tell Spring where the database is so it can go ahead and connect to it. And we do that with a URL that looks a little bit like this. Now let's break this URL down. So this URL has several distinct parts. The first part is JDBC and then a colon. So this says this is a JDBC URL. JDBC, or Java Database Connectivity, is a low-level mechanism that we can use in Java and by extension Kotlin to connect to the database and interact with it using SQL. Of course, we're using a layer above that, which is Spring Data JPA, which means we don't have to deal with any SQL directly. We only deal with Kotlin objects. All of the SQL generation going to and from the database, well, that's handled by Spring Data JPA for us. So the next part of the URL is PostgreSQL and another colon. So this is saying that the protocol is PostgreSQL. We're connecting to a PostgreSQL database. And the next part of the URL is localhost, and that is saying where the database is running. In this case, on localhost, on this machine right here, not remotely, but locally. Next, we have 5432, which, as we know from earlier, is the port that PostgreSQL runs on by default. And then we have Postgres. So PostgreSQL has the concept of a database. So within of PostgreSQL, there can be many databases, and you choose which one that you want to connect to. The default one is called Postgres, which is the one that we're going to connect to. And now we need to specify the credentials to use in order to connect to our PostgreSQL database. And they look a little bit like this. So we can see here we're specifying the username to use to connect to the database. By default, a Postgres Docker container will use the user Postgres, so we'll use that one. And this is the password that we specified in the Docker container configuration in our docker compose.yaml configuration from earlier. So that's the password that we're going to use here. So this is all the configuration that we need in order to connect to our PostgreSQL database. So let's try it out. Let's run our application by clicking on this green tick up here. If you don't have a green tick up here from running the application from earlier, then what you can do is go to source, main Kotlin, and then go to bookstore application, and then you'll find another green tick next to the main function. So let's take a look at the output from our application. So let's scroll over here. We can see the application starts up absolutely fine. The key part that we're looking for is this line here. You can see that it's added a connection to PostgreSQL. And that is exactly what we want to see. That is enough for the moment. So we have a running instance of PostgreSQL, and it looks like we're connecting to it successfully from our application. That's great. Now, wouldn't it be nice to see what's going on in the database when we're making changes, be able to actually see them visually? Well, let's look into that in the next lesson. Wouldn't it be nice to see our databases, tables, rows, and columns visually so we can see what we're doing? Of course it would. So let's set this up now. Now, the way we're going to see what's going on in our database visually is by using a piece of software called AdMiner. We're going to run this in a Docker container alongside our database, and then we'll be able to see what's going on by hitting AdMiner through our browser. So here we are back in our IDE in our docker compose.yaml file, and we have some services, and we have one service at the moment, which is DB, which is our Postgres database. So let's add another one, and it will look a little bit like this. We'll aptly name this one AdMiner, and we can see we're using the latest version of AdMiner here. We've got that restart if the database stops for whatever reason. And then we are port forwarding 8080 to 8888. Now our Spring Boot application runs on port 8080 by default, so we need to choose a different port in order to hit AdMiner on. And 8888 seems good enough to me. So with this added, we're going to go back to our terminal here. We're going to stop Docker Compose. To keep things nice and clean, I'm going to say Docker Compose down. You can see here that it's removed the container for DB1 and it's removed the network as well. And now we're going to say Docker-Compose up. You can see it's pulling the AdMiner Docker image there. Great. And we can see that DB1, so PostgreSQL, is up and running. And if we scroll up a little bit, we can see a log line from AdMiner saying it started on port 8080, which of course we're port forwarding to 8888. So let's hit AdMiner in our browser and see what we get. So here we are in our browser, and I've hit localhost 8888, and we've got AdMiner, and we've got a login window here. So we're going to select PostgreSQL. The server is DB. Now this is something to note. So if we go back to our Docker Compose file here, so because AdMiner is running in Docker Compose, it's able to access other services running in Docker Compose, other Docker containers, by using these names here. So AdMiner can connect to Postgres by using the DB name. So we'll select DB as our server. The username we'll use is Postgres. And now we'll specify the password, which we'll copy from here. And the database that we want to connect to is called Postgres. That's the same one that we specified in our database connection URL in our application. Of course, it's the default Postgres database also. And now we'll click on login. Looking good, we're all logged in, and it says that we have no tables. And that makes complete sense because we haven't created any yet. So now that we can see what's going on, let's go ahead and put some stuff in the database. So let's upgrade our domain classes in order to be fully fledged Spring Data JPA entities. So we have the author and the book domain classes. We've already created those. Now, what we don't have, because we've just seen it in AdMiner, is any database tables in order to represent them. We would expect them to look a little bit like this. And then comes the question, how do we connect one to the other? Well, the answer to that is JPA, or the Java Persistence API. And despite the J in its name, we can use JPA in Kotlin in much the same way as in Java. But JPA doesn't work with just any old class. We need to take our plain old Kotlin object, or POCO, I suppose, which is what we have at the moment, our domain objects, and we need to add some Java Persistence API annotations. Specifically, these annotations. We need to put the @entity annotation on top of each of the classes, and that declares to Spring that this is an entity to be used with Spring Data JPA. We also need to place the @ID annotation on the property that represents that object's unique identifier. So in the case of the author, that is the ID property. And in the case of the book, this is the ISBN property. Now, these are the bare minimum annotations that we'd want to get things to work, but there are some additional ones. And then you have the @table annotation, which you would put on the entity class, and that allows you to specify the name of the table that you want that entity to map to in the database. And then you have the @column annotation, which you'd place on a property, and that allows you to specify the name of the column in the database that you want that property to map to. Now, both of these annotations are optional because Hibernate, which is the piece of technology that actually does the work behind the scenes, well, that's going to guess the name of the table and guess the name of the column, depending on what your properties and what your class is called. You see, Hibernate will guess the name of the table as being exactly the same name as your class, and it would guess the name of the columns being exactly the same name as your properties. So we could miss these annotations off, or we could be explicit and include them. Remember from earlier when we said that an author can write many books, but a book will only have one author? That's the way we're going to set up our domain. Well, we'll be able to specify this all within our entity configuration. This is a little bit more involved, so I'm going to break it down once we get there. So let's flip over to our IDE and create our entities. Okay, let's start with author. So the first thing that we need to do is add the @entity annotation on the top there. And now we need to specify our ID. So let's do that. And that's the bare minimum configuration that we would need in order to declare an entity. But while we're here, we might as well be explicit. So let's add some additional annotations in order to say what the name of the table is and what the name of the column should be. So we're going to specify the @table annotation on the top there. Let's import that again from Jakarta Persistence. And we're going to say the name of the table is going to be authors. And let's also put the column annotations on each of these properties. Column again coming from Jakarta Persistence. We'll say name equals ID, and we'll do the same for the rest now. Okay, the author's looking good. Let's go over to our book. So let's do the same thing here. We'll add the @entity annotation to the top of the book class there. We'll add the ID annotation to the ISBN field. We'll add the @table annotation in order to specify the name of the table. And we'll add the @column annotation on each of the properties in order to specify the name of the columns in the database that they should map to. But wait, we don't have a straightforward column here. We have ISBN, title, description, and image, but here we have an author. Well, this is the time to configure the relationship between book and author. So in this particular relationship, we say that the book owns the relationship because we have a reference to author within the book class here. So if we look at things from the book's perspective, it's one author to many books to one author. So the annotation that we're to use here is actually many to one. So what this will mean is every time that we query the database and get a book back, we're also going to get the author to which that book relates. So now we have a decision to make. When we get that book back and we get that author back to which it relates, do we want changes made to that author to be persisted in the database in the same way that they would be if we made changes to the book? Well, we'd configure this with the Cascade configuration, and it looks a little bit like this. And within this array here, we would specify the Cascade type of one of the following. All, meaning that all changes made to the author should be persisted. Detach, which means that no changes to the author should be persisted. And then we have some more specific cases here with remove, merge, persist, and refresh. For the time being, we're going to say detach. So when we get this author back, if we do make any changes to this author, we don't want them persisted in the database. We have a dedicated endpoint for the author, so we want to make sure that all changes go through there. Another step when you set up a many-to-one relationship like this is you need to specify the name of the join column. So that will be a column within the books table that we use in order to store the ID for the author, because we need to have that link represented somehow, right? And in a many-to-one relationship, it's just as simple as within the entity that owns a relationship, in this case, the book. It just needs to store a reference to the entity to which it relates, the ID to the entity of which it relates, which in this case is going to be the author. So we'll say @join column, name, and we'll simply call it author ID. So within the books table, there will be a column called author ID, which contains the ID of the author to which that book relates to. Or put another way, contains the ID to the author that wrote that book. So that's the entity book configuration looking pretty good to me. But while we're here, let's think a little bit more about the IDs. So in the case of the ISBN, I'm making a design decision now that the caller should always specify the ISBN. So in this case, our front end will provide the ISBN every time it creates a new book. But in the case of the author, it's using a numeric ID. So I think it would make sense for our Kotlin Spring Boot application here, our backend, to just generate an ID, which could just be the next ID in the sequence, 4, 5, 6, etc. As it turns out, there's a very simple way of doing this when you're using Spring Data JPA, and that's just with another annotation. So we're going to add the annotation generated value, and we need to provide a bit of configuration to this annotation. The first is going to be the strategy. So this is just going to be, give me the next number in the sequence. We start at 1, 2, 3, 4, 5, etc. Just give me the next one that's available. So that is the generation type of a sequence. And now we specify a generator. A sequence is actually a concept that exists within the PostgreSQL database. It's something that you can create, configure, and delete in much the same way that you would do a table. So this next bit of configuration that we need to add is simply the name of that sequence in the database, in much the same way that we specify the name of the table using the table annotation or the name of the column with a column annotation. So let's call this one author ID SEQ for sequence. So in summary then, we have an entity for both our author and our book. We have a relationship set up, a many-to-one relationship between our book and our author. And we've also gone the extra mile and we've set up the ID on the author here to use a sequence. So we don't have to worry about specifying this. But on the book side of things, we're saying that the caller should always specify the ISBN whenever they create a new book. But with everything set up here, this still isn't going to create anything in our database. There needs to be some mechanism which creates this in the database. Well, as it turns out, there's also an easy way of doing that. So if we go over to our application properties here, we can add an additional line. And it looks a little bit like this. So this is using a feature of Hibernate, which, as we mentioned earlier, is the piece of software that does a lot of the work behind Spring Data JPA. And we're going to use the DDL auto feature. So what this means is we're asking Hibernate to take a look at the entities that we've declared and configure the database in such a way to reflect those entities. If you remember, we've already specified the name of the table and the name of the columns, and it should be able to work out what the type should be. So it does have enough information to do this. And by specifying update here, it means whenever we make an update, whenever we change the entity's configuration and restart the application, we want Hibernate to update the database schema. There's some pros and cons to that, which we'll come on to a little bit later, but let's see what we get in our database when we restart our application. Okay, that's our application restarted. Let's go over to AdMiner and take a look at our database. Okay, and if we refresh this, wonderful. So it looks like we have two tables. We have an authors table and we have a books table. Let's take a look at the authors first. Great, we have an ID, we have an age, we have a description, an image, and a name. And it looks like it's inferred the types here. So we've got a big int for the ID, an integer for the age, and we have a varying character 255. So it's specified a max limit of 255 characters for description, image, and name. We'll likely want to do something about that in a moment. And then if we take a look at books, we've got ISBN, description, image, title, and there's our author ID field that we're going to use in order to store the reference between the book and the author. Again, Hibernate's been able to infer the different types. So we've got a varying character, a varchar for ISBN, description, image, and title, all at 255. And then the big int for the author ID, which matches the big int type of the ID on the authors table. So we actually have some tables in our database now. This is fantastic. So the next step is setting something up that we can use to interact with these tables using our entities. So let's create some repositories. So we're going to set up some repositories. You see, Spring Data JPA repositories allow us to interact with the database using entities. We don't have to write any SQL. We simply interact with our entities and our repositories, and all of the SQL is handled for us. The way that we create a repository is we simply need to declare an interface, make sure it extends the right Spring Data JPA repository, and then specify some types. We don't even need to provide the implementation for this interface. Spring Data JPA is going to do it for us. So this is going to be a pretty quick one. So let's go over to our IDE here, and I'm going to create a new package, and I'm going to call that one repositories. And this is where we're going to store our repositories. So let's create one for our author. Create a Kotlin class, let's specify interface, and we're going to call it author repository. So this is the first time that we've come across an interface in Kotlin. For the time being, we'll say that an interface in Kotlin works in the same way that it does in Java. Now, that's not strictly true because unlike an interface in Java, in Kotlin, you can actually provide implementations inside of your interface. But we're not going to need that right now. So a useful shortcut is just to think that Kotlin interfaces work in the same way as in Java, but with some extra features. The concept remains the same, which is that we declare our contracts in our interface, and then we implement our interface using concrete classes. Or in this case, Spring Data JPA is going to provide that implementation for us. All we need to do is extend the right interface. Now, there's no extend keyword in Kotlin. The way that we do that is with this colon. Now, you might remember this colon from when we specified the types. And if you think about it, it kind of makes sense because we're saying our author repository actually is whatever we declare this type to be, which in this case is going to be the JPA repository. Our author repository is a JPA repository. Author repository extends JPA repository. Now, I did mention we needed to specify some types, and there's two types that we need to specify here. The first one is the entity type that this repository deals with. This is the author repository, so it deals with our author type there. And the second type is the type of the ID of the entity. So we go to author here, we can see it's a nullable long. So that's what we'll specify in our repository. And let's remove these parentheses because we're not going to declare anything. And we'll add the @repository annotation on top, which declares to Spring that author repository is a repository and should be placed within the Spring context for auto wiring for injection throughout our application. I told you it was going to be a quick one. That is the entire implementation of our author repository. We've done it in 2 lines, and that will give us all sorts of functionality. Primarily, we're able to create, read, update and delete our author, so CRUD behavior. But if we were to take a look in the JPA repository here, we can see all of the different behaviors that we get for free. And as it turns out, this extends a whole bunch of other repositories, each with their own behavior that we all get for free. So that's the author repository. Let's go ahead and create a book repository now. So we say interface, book repository. This extends or is a JPA repository. We're using the book entity. Make sure that we get that from the correct package. And we're using the ISBN as the ID, and that's a string type. So that is what we will declare as our second type parameter. And let's not forget the @repository annotation on top. And there we go. We now have our book repository. And that was pretty easy, perhaps too easy. At the moment, we've got some entities, we've got some repositories, which is used to interact with the database. And our database is actually already set up automatically for us. But before we carry on implementing the rest of the application, I think now's the time to lock down our database schema. The last thing that we want is for any data to go missing. So let's deal with that in the next lesson. So why do we need to bother locking down our database? Well, because otherwise we'd be building on sand. Hibernate Auto DDL does an amazing job of using our domain in order to automatically create and manage our database schema. However, this approach does run the risk of making non-revertible changes to our database schema that we wouldn't know about until it's too late. And not because there's anything wrong with the technology, but rather it makes changes implicitly as a part of a second order consequence, which as humans, it can be pretty hard to reason about. My suggested solution is to make those changes explicit, which we can do with the init.sql and data.sql files that Spring Boot will run against our database. But this approach has its limitations. Instead, we're going to use what Spring refers to as a higher level tool. We're going to use Flyway to implement database migrations. Right, so we're back in our IDE. Let's go ahead and stop Docker Compose from running. So we'll do that with Docker Compose down. Of course, that's going to stop Postgres and Adminer from running and give us the opportunity to change things up. Now we're going to go over to our configuration here, application.properties, and we're going to remove this line right here. In doing so, we're going to disable Auto DDL from running. The default is without this configuration, it will not run. Now we need to get hold of the Flyway dependency. So we'll go over to our pom.xml file here. We will find a place to put it. I'll put it before the test dependency. And we'll put the dependency configuration right here. I'll link to this in the description below. So with that there, we'll go ahead and refresh our Maven in IntelliJ. That's going to pull down that dependency for us and make it available. Great, so we can now use Flyway in our project. So Flyway works on the concept of database migrations, which are a series of SQL scripts which are run one after the other sequentially. So we'll need to create our first SQL script to set up our database, and Flyway does this in a very specific way. So we'll head over to our resources directory and we'll create a new directory called DB. And within that new DB directory, we'll create another directory, and we're going to call this one migration. This is the convention that Spring Boot uses in order to work with Flyway. And it's in this directory that we're going to put our first SQL file. Now, the naming convention for these Flyway SQL files is very particular. So we'll create a new file here, and we're going to call it V1 double underscore. The double underscore is very important. Now we can give a description of this file. This can be whatever you like, really. So we're going to call this one init underscore DB for initialized database. And then we'll give it the .SQL suffix. And it's in this file that we'll put our SQL in order to initialize our database schema. So I did mention we're not going to write any SQL in this project, and I'll keep that promise. So I'm going to link to this SQL in the description below, but we will go through it so we understand what it's doing. So the first two lines here, we are dropping the author ID sequence if it exists, and we are creating it afresh here. We're incrementing by 50 and starting at 1. So this creates the sequence that we can then use within our domain in order to auto-generate the IDs for our authors. So starting at 1, that makes a lot of sense, but you might be wondering why we're incrementing by 50. Well, we'll do this because that block of 50 will then be given to Spring Boot, and Spring Boot can go ahead and generate IDs from that block of 50 without going back to the sequence in the database. So really, this is all about efficiency. By giving a block of 50 rather than 1 each time, we reduce calls to the database, which naturally is more efficient. So the first two lines is all to do with the sequence for our author ID. The second block here is all to do with creating the table for authors. So we'll drop it if it exists, and then we'll create a brand new one here. So we've got our ID field, which is a big int, which is the same type as what AutoDDL inferred. Then we have age. We're going to use a small int for that one, because naturally age has a limited range as to what it could be. So using a small int here is safe. And then we have our description field. We're going to choose to cap this out at 512 characters. So the maximum length of a description is going to be 512 characters, which makes sense depending on how much we can actually display in our front end. Then we have the image field where we store a reference to the image that we want to display against that author. And again, we're capping this out at 512 characters. Then we have the name field, the name of the author. And again, we're capping this out at 512 characters. And then we have a constraint on the primary key, which of course is going to be our ID field here. The next block is to do with the books table. So we're dropping the books table if it exists, and then we're creating it afresh here. So first we have the ISBN field here. Now ISBNs are 19 characters or less. So we're going to set a limit of 19 characters on this varchar field here, varying characters. So you can think of this like a text or a string. Then for the description of the book, we're choosing a longer description for the book. So we're going with 2048 characters here. Again, this is going to be text, varchar. Then we have the image field, again, the same as what we have up here on the author, limited to 512 characters, varchar. And then we have the title of the book, which again is limited to 512 characters. So naturally, we want to link our book to our author, and we're going to do it with this field right here. This is our join column. So the author ID field is a big int because that's going to store a reference to the ID in the author's table, the author of the book. And then we have a constraint on the ISBN being the primary key there. Now we could go ahead and add additional constraints and maybe some indexes for efficiency, but we're going to keep it bare bones for the sake of this course. So this should give us everything that we need in order to get everything set up, at least that first step anyway. So with our Flyway dependency in place and our first database migration script in place also, we're in a position to start up the database afresh and apply the database migration. So we'll go docker compose and up to start everything up once more. Great, so the database system is ready to accept connections. Let's go ahead and start our application up, and we should see Flyway apply our migration. Okay, so our application has started up. Let's take a little look at the output here. So what do we have? Well, we're connecting to the database. We can see here that we've got an output from Flyway. So we can see that the Flyway schema history table does not exist. This is where Flyway is going to store all of the metadata to know which migrations it's applied to our database. And if we go down a little bit, we can see the author ID sequence doesn't exist, authors does not exist, and books does not exist. So this is the drop if exists for each of the sequence there, the authors table and the books table. And then we can see that we've successfully applied one migration to schema public. So it says that this SQL script has been run absolutely fine as our first database migration by Flyway. But there's only one way of testing that out. Let's go over to add miner and take a look at our database. So here we are in AdMiner taking a look at our database schema. So we can see the Flyway schema history table is being created here. Let's take a look at some of the data in there. So we can see we've got one migration, version 1, called initdb. So that was the name that we put in the Flyway file name. Using that script there, v1 initdb, that was installed on this date here. It looks like that ran absolutely fine. That's in that metadata table. We can also see we have the authors table created here, ID, age, description, image, name. And we also have the books table created here, ISBN description, image, title, and then that author ID as well. So there we are. That's really the bare minimum that we need in our database in order to get going, writing our business logic and our presentation layer, our REST API. So we're going to be building on this database schema as the course progresses and learning a little bit more about Flyway as well. But for now, let's get on and start building our authors REST API. So now that we have a solid persistence layer, we get to build a REST API, and that means working in that services layer and also in that presentation layer. So let's start with the authors create endpoint, which will allow us to create authors in our database, and we can then use those authors when we get on to building our books REST API. Before we write the code, let's just do a brief recap on what a REST API is so we're all on the same page. So REST is an architectural style, and that allows different web components to communicate. So RESTful servers are built around the concept of a web resource, which is something particular that we care about. In our case, we have the author and the book. In REST API lingo, the author and the book are web resources. So RESTful web servers make use of the HTTP verbs in order to achieve certain things in relation to our web resources. So we can see here we have the HTTP verb get, and that's all about reading either a single web resource or multiple web resources in a single request. The HTTP verb post is all about creating web resources or sending data to the server in order to be processed. The HTTP verb put, that's all about a full update. So you would send a representation of the web resource using the HTTP verb put, and it would replace whatever's in the database. This can be used for both a full update and also creating web resources. The HTTP verb patch, that's a partial update. So you would send a partial representation of your web resource, maybe only a couple of properties, to the backend, and it will be those properties that are updated on that existing web resource. And then we have the HTTP verb delete, and that deletes the web resource. That one's pretty straightforward. Just like use of the HTTP verbs, there are some conventions around the URL structures that represent each of the web resources. In this case, we'll have two URLs, two endpoints, one for authors and one for books. And we would usually structure the base URLs in this way. A word in order to represent the web resource, author, book, that makes sense. But we would usually go with the plural. So it would be /authors for everything to do with our author and /books for everything to do with our book. So a typical interaction with a REST API would look like this. We have a caller, and that caller would send a request to the REST API. A request is typically a combination of a HTTP verb, a URL structured in a very certain way. In addition to this, you can also have query parameters, which provide additional key value pairs, additional information in our URL. And you can also provide a body. So this could be a representation of a web resource, for example, and it's typically in JSON format. But again, query parameters and request bodies, they're optional and not on every single request. So once our REST API has received that request, it will do something with it, and then it will send a response. Now, a response will typically have a HTTP status code, and we'll get onto the use of those in a moment. It may also have a response body, very similar to a request body. That usually represents a web resource, typically in JSON format. So in this case, it's an author represented in JSON. So on the subject of HTTP status codes, this is typically how I picture it. So anything from 200 right the way up to 400, they're usually okay. So 200 is a typical success response code. 201 is a success of something being created, so on and so forth. Not all REST APIs make use of the full breadth of all of the response codes. Some only use a small subset. But typically anything from 200 to 400, that's a success response code. Something has gone well. 400 to 500, that's typically the caller has not provided the right information or has made an incorrect call. So that's a problem on the caller's side. And then 500 is that something's gone wrong on the server side within the REST API, within that application. That could be because of a bug in the code or because some dependency of that REST API has stopped functioning correctly. But in summary, 200 to 400 good, 400 to 500, the caller has done something wrong, and 500, there's something wrong with the REST API application itself. So what does our endpoint look like for creating an author? Well, it would look a little bit like this. We're going to use the HTTP verb post. We're using post because that's typically what's used for creation. We could also use a HTTP put. The difference being is that the caller is not going to specify the ID of the web resource that needs to be created. It will be the server in this case. And that's because we've set up that ID sequence for our author. We're going to automatically generate the IDs for our author. That was a design decision that we made. So we're going to go with the HTTP post verb for creation of authors. And now for the URL structure. Now you'll notice we've got this v1 prefix, and that's a version. This is another convention, and you'll find that not all REST APIs do this, but I find it to be very useful. For example, we're about to write the create endpoint for authors. And it may be that certain callers will then depend on that particular endpoint. Now, it might be for whatever reason in future that endpoint changes. Because we have some callers already depending on the v1 version of the endpoint, rather than change the endpoint in its entirety, we can simply introduce a v2 version of the endpoint and have both the v1 and v2 create author endpoints running simultaneously. And that allows for backwards compatibility. We would then deprecate the v1 version and give the caller some time to move from v1 to v2, which is a much nicer experience for the caller rather than just changing the way that a certain endpoint works and then breaking their stuff. And you can see here we're using /authors because we're representing our author web resource. So with the theory covered, let's get on and write our create authors REST API endpoint. So we're now going to code our create authors REST API endpoint. So here we are back in our IDE. So what I'm going to do now is I'm going to create a new package, and I'm going to call this one controllers. And this is where we're going to store our REST API controllers. It's a controller that represents a particular endpoint for a REST API. So we'll have one for authors and we'll have one for books. We're going to start with the authors one. So I'm going to create a new Kotlin class /file. It's going to be a class, and I'm going to call it authors controller. So the first thing we want to do with any controller is tell Spring that this is a controller class. And we do that by putting an annotation on the top of the class, which is REST controller. So this annotation does a few things. The first thing is it tells Spring this is a REST controller class, which will tell Spring how to expose certain endpoints, etc. It also makes our authors controller a candidate for injection for auto wiring. So throughout our application, if we wanted an instance of authors controller, well, Spring would be able to find it because it has this REST controller annotation on there and then make it available wherever we've asked for it. And in addition to that, if our authors controller class here declares that it needs any dependencies injected, auto wired, then that annotation at REST controller tells Spring to do that as well. So what we've just mentioned there is one of the core features of Spring, so that's dependency injection. If that's new to you or slightly confusing, then I'll put a link in the description below for the Spring Boot crash course, which goes through that in a lot more detail. So we're now going to implement our create author endpoint. So we'll need a function for this. So we're going to use that fun keyword, and we'll call our function create author. The name of the function tends not to matter too much, but it should be descriptive as to what it's actually doing. On top of this function, we're going to put another annotation, and that's going to be post mapping. That tells Spring that this endpoint maps to the post HTTP verb. Within this annotation, we can then provide some additional information, such as the particular path that this endpoint maps to. So we need to put this one in an array, and we'll call this one v1 authors, which is what we discussed it would be in our theory section. So within this annotation, we're saying this function is an endpoint which maps to the HTTP verb post and the endpoint v1 authors. In order to create an author, we'll need the author information, right? And we'll need to provide that. The caller will need to provide that in the request body of the request. So we'll tell Spring about that one by using the @request body annotation here. And then we would need to put that on an argument to this function, which will represent the author. And we've declared the type as the author entity there. And that looks okay, right? Well, not quite. We're using the author entity here, which is a concept from the persistence layer and the service layer. Because we're in the presentation layer, we're going to want to use a slightly different concept. We're going to want to use a data transfer object, or a DTO. So let's discuss the reasons that we want to do that in the next lesson. We don't want our presentation layer exposing our persistence layer concepts directly, and that includes our entities. And that's why we're going to use data transfer objects, or DTOs. So data transfer objects are a pattern that's used to decouple layers of an application. In our case, DTOs are going to decouple the presentation layer from the rest of the application. So the presentation layer from the service and persistence layers. So the pattern is used pretty haphazardly in the wild, but I feel it has enough of a benefit, enough value for us to include here. So in OOP, we're building software in order to model real world objects, right? But one of the big benefits to DTOs is we can change how we represent those objects in different layers of the application. So for example, we have an author entity on the left here and an author DTO on the right. I've added some additional metadata properties to our author entity here. You can see we've got a created date time and an updated date time. And this is useful to know when our author entity has been created and updated in our database. However, this might not be information that our caller wants to know when they call our REST API. So we want to represent the author differently in our database from what the caller sees when they call our REST API. And DTOs allow us to do this. You see on the right here, the author DTO has a subset of the properties of the author entity. We're representing our author differently in our DTO from what we are in our author entity. Or put another way, the way that we represent our author in our database can change independently from how we represent it to callers of our REST API. So another big benefit is that we can aggregate data in our DTOs. So take a look here. On our left, we've got the author entity and the book entity. So these are the ones that we store in our database. On the right, we have our DTO, which is our authored book. When using the DTO pattern, there is nothing to stop us from combining the author and the book entity into a new DTO, authored book, and then returning that to the caller of our REST API. Of course, this all depends on design decisions. We're cutting down on calls to the REST API here by combining the author and the book into an authored book. Just going to point out, this is all theory. It doesn't mean we're going to follow this approach when we implement our API, but we will have the option to by following the DTO pattern. So how do we go from our DTO to our entities and our entities to DTOs? Well, we typically use something called a mapper. Now you might be asking, well, where do we do these mappings? And this is where different developers have different opinions. I recommend that you call your mappers from your presentation layer, and here's why. Now, one of the questions I get asked a lot when I suggest this is, well, isn't the purpose of a DTO to separate certain layers? So our persistence layer is naturally going to use entities, and our service layer is going to work with those entities. So if we call our service layer from our presentation layer and return entities, well, isn't our presentation layer dealing with entities? Aren't those persistence layer concepts leaking into the presentation layer? And this is a fantastic question. But we have to consider the caller in this case. You see, the caller doesn't care about the different layers in our application. The caller only cares about the request that they send and the response that they get back. The different layers of our application, well, that's a implementation detail that's abstracted away from the caller. They simply don't care about it. So by using mappers in our presentation layer, our caller never gets to see those entities. They only get to see the DTOs we have fine-tuned for them. They deal entirely in DTOs. They are decoupled from the entities. The next question that follows is, well, why not do the mappings in the service layer and simply just return DTOs from the service layer? And you can, and I've done this in the past and it works, but it does have a major drawback. It's not unheard of an application to expose a presentation layer in the form of a REST API and another in the form of a GraphQL API, perhaps another in the form of a gRPC API. These are all different presentation layers. Now, it's likely the case that each of these different presentation layers need to return slightly different structures of data. They need different DTOs. If we were doing our mappings in our service layer, we'd have a problem because we're only returning one type of DTO. Wouldn't it be easier to return all the information from the service layer, return the entity, and then have each presentation layer do its own DTO mapping for its own needs? Which is why I suggest doing the mappings in your presentation layer. Return all the info from your service layer, and then have the presentation layer decide how it wants to present that information. So with that in mind then, we don't want to return our author entity from our create author endpoint. We want to return a DTO. So we need to create a DTO and a mapper to go from our author DTO to our author entity and back again. So let's get going with that in our next lesson. So let's start implementing some DTOs for our author. So here we are back in our IDE here. First thing I'm going to do is go to our domain here and I'm going to rename our author to be author entity. We'll select all there. What this will do is throughout the application, wherever we've said author, it's going to rename it to be author entity. Click OK. And we can see there, author entity type, author entity variable name. Let's rename the book to be book entity while we're here. Perfect. So over in our domain package, I'm going to create a new sub package and I'm going to call that one DTO. I'm going to leave that empty for the time being and we'll create a new one and I'm going to call that entities. I'm going to take the author entity and the book entity and then drag that into the entities package, clicking on refactor. That will update all references for the new location. And now we'll create our author DTO in here. So a new Kotlin class. We'll call this one author DTO. This will be a Kotlin class. In fact, it will be a Kotlin data class. Now, to begin with, at the very least, our author DTO will be identical to our author entity. Just because they can be different doesn't mean that they're different right now. The fact they can be different is where the value lies. So what we'll do is go to our author entity here, and I'm going to copy the properties over to the author DTO, but I'm going to remove all of the Spring Data JPA annotations because this is going to be a plain old Kotlin object. So here we have our author DTO. Let's do the same for the book while we're here. So we're going to go new Kotlin class, book DTO, data class, and we'll populate this data class in the same way. Now our book entity references the author entity here. We want our book DTO to reference our author DTO. So I'm going to rename that to be author, and I'm going to use the type author DTO here. There we go, and there is our book DTO. Now we'll need a way of mapping from our DTOs to our entities and our entities to our DTOs. Now there's a few different approaches that we can follow here, but because we want to focus on Kotlin, I'm going to show you a way of doing it using Kotlin extensions. Now Kotlin extensions allow you to add additional functions or properties to a class without subclassing it. So this includes the code that we write ourselves, but also third-party libraries. So Kotlin extensions don't modify the classes that they extend, even though it may look that way when we're coding them. Instead, the Kotlin compiler works everything out when it compiles down to bytecode. In terms of the specific language, when we create an extension function, we typically say that the class it extends is the receiver. And we can reference the receiver using the this keyword when we code up our extension. Although this is typically omitted when it's not needed. Now, different programming languages have different preferences, ways that they like to do things. It's the preference in Kotlin to use extensions, where you can. So I'm going to create for us a new file. This one is just going to be a file, not a class, because we're going to put our extensions at the top level in that file, not wrap them in a class. And we're going to call this one extensions. So extensions are a function, so we're going to use the fun keyword here. And now we need to declare the receiver, the class that the extension extends. In this case, it's going to be the author entity. And then the name of the function, the name of the extension. So I'm going to say to author DTO, set of parentheses there. And then I'm going to declare the return type, which is going to be author DTO. And now we'll open a set of curly braces and we'll implement our extension function. So we're going to return an author DTO. And now we'll need to populate the author DTO with the information that we have from our author entity. To make things nice and explicit, nice and obvious, I'm going to declare the names of the arguments here, something that you can do in Kotlin. So the ID is going to be this.id. The name is going to be this.name. And I'll do the same for the remaining properties. So what we have here, ID equals, name equals, age equals, in Kotlin, these are called named properties. And one of the big benefits that I see with them is it makes it really obvious to which property we're assigning that value. Of course, we can rearrange these and have them in a different order because everything is named. And now we can call the function toAuthorDTO on an author entity whenever we have one in our application. But before we move on to doing the opposite mapping, let's make this look a little bit more Kotlin. So what I'm going to do is remove the type declaration. I'm going to remove the braces. I'm going to remove the return keyword. And I'm simply going to assign the expression of author DTO construction to our author entity.authorDTO extension declaration. Because our function implementation is essentially a single line here, we're able to skip all that boilerplate code and simply assign it using equals. Now going the opposite way, going from an author DTO to an author entity is going to be a fairly similar implementation. Because our DTO and our entities are identical at this point in time, You can see here that all we've really done is inverse the type. So we go author DTO as a receiver, returning an author entity, and we've called the extension function to author entity. We're now able to call this on any author DTO throughout the application. So you might be wondering, well, what's the big benefit in this? Can't I just put these functions onto the classes? Can I not just put a toAuthor DTO function on the author entity class? Absolutely, yes, you can. But it would then mean that our author entity knows about our author DTO. And the same is true for the inverse. If we put our toAuthor entity function on our author DTO now knows about our author entity. And in doing so, we couple our author entity and our author DTO. By using extensions, we essentially put this functionality in a third location, not on the author DTO, not on the author entity, but somewhere completely separate. And that third location is specific to this application. So if we did want to reuse the author DTO and author entities in other applications, for example, they are completely decoupled. They don't know about each other at all. And that's a really nice benefit to using extensions. So we've written our extensions, they're ready to use. Let's go on and do that in the next lesson. So let's finish implementing our create author endpoint. So let's go back to our author's controller here. We'll swap out the author entity to be an author DTO. And we'll also declare that an author DTO is to be returned from this endpoint. Now we just need to implement this function. So we know that we have an author repository, and that can be used for creating an author in a database and retrieving it. However, that lives in our persistence layer. We don't want to access our persistence layer directly from our presentation layer because that skips over the service layer in the middle. So we're going to need an author service. So let's create a new package and we'll call this one services. And in our services package, we'll create a new Kotlin class /file. And this is going to be a Kotlin interface. And we're going to call this one author service. So we intend to use the author service interface like a typical interface in computer science and in Java, as it turns out. We're going to declare in here the functionality that we want our author service to expose. So we want to write the contract that any author service implementation must fulfill. So we're going to declare a function and we'll simply call this function save. The save function is going to expect an author entity of type author entity, and it will return an author entity. So now we're going to create a new sub package in our services package, and I'm going to call this one IMPL, which is short for implementation. This is a convention that you'll see quite a lot, and it's a way of separating the interfaces from their implementations. So within that impl package, I'm going to create a new Kotlin class or file, and I'm going to call this one author service IMPL. This is just going to be the default implementation of our author service. And this will be a Kotlin class. And this is where we'll implement our author service. This might seem like a lot of hard work. Why don't we just create an author service and put the implementation in there? But we do this in order to fulfill the principle of coding to interfaces, never concrete classes. If there came a time that we wanted to completely change our author service implementation, then providing it still met the interface, we would just create a new implementation and have Spring inject that throughout the application rather than the original one. So we're going to declare that our author service implementation extends the author service interface there, which of course gives us a red squiggle because we haven't implemented that save function. If we click on implement members there, click on OK, that's going to give us a stub that we can then implement ourselves. So we'll now need to implement our save function. And in order to do that, we'll need to get a reference to our author repository. And the way we'll do that is through the author service impl class's primary constructor. So we're going to create one by placing parentheses there. We'll declare a val of author repository of type author repository. And we now have a reference to author repository that we can use in our save function. But we are missing something. We need to place on this class the @service annotation. This tells Spring that this class is a service. So when the app starts up, any dependencies that are declared, in this case our author repository, will be injected when this class is created. It's also the case that our instance of author service impl that's created is then available to inject to AutoWire throughout our Spring application. So this is dependency injection, that core Spring functionality. So let's implement this save function now, and we can do that by calling author repository.save, passing in our author entity. And then we'll place the return keyword to return the saved author entity. Now the save function is inherited. It's inherited from CRUD repository, which is a parent to JPA repository that our author repository extends here. So we get all of this functionality for free by using Spring Data JPA. The same's true in Java, the same's true in Kotlin. And then we have our author service import class implemented, and this will work. But there is something additional that we should do in order to adhere to best practices, and that's add a visibility modifier. So we go up here to author repository, we've got our val, but what I'm going to do is add the private keyword in front of that. Now, visibility modifiers are very similar to the Java concept of accessibility modifiers. In Kotlin, there are 4 visibility modifiers, and they are private, protected, internal, and public. We can place these visibility modifiers on classes, objects, constructors, interfaces, functions, and properties throughout the application. And the visibility modifiers control where these certain things are visible from throughout the application. For example, the private visibility modifier can only be seen within the file in which it was declared. The protected visibility modifier is the same as private, but it can also be seen in subclasses. The internal visibility modifier means that the member is visible inside of the module in which it was declared. And by default, if you miss off the visibility modifier, everything is public, which means it can be seen from anywhere in the application. So we now have an implemented save function in our service. Let's go ahead and use it in our controller. Let's go back to our controller here. And now we'll just need to implement our create author endpoint here. So we're going to need reference to our author's service. So we're going to do that in the same way that we did in the author's service through the primary constructor. So we'll declare some parentheses here, and I'm going to say private val author service. And now we have reference to our author service. If we say author service.save, it requires an author entity, which despite the name, this should in fact be author DTO. So if we try passing in our author DTO, we can see we get a red squiggle because the types don't match. However, we did that extension function from earlier. So if we call .toAuthorEntity, you can see that that works absolutely fine because we converted our author DTO to an author entity. If we now try and return, you can see that we get another red squiggle because we have an author entity here, but we need an author DTO. So we'll just call our extension function toAuthorDTO. And like that, everything compiles fine. Let's just reformat that to make it easier to read. So you can see here we're using our extension functions and they have been imported. So up here, we've got toAuthorEntity, and then there we've got toAuthorDTO. So these extension functions are imported, but they appear as if they are functions on the author DTO and author entity. You can see though that IntelliJ has highlighted them in blue in order to identify that they are extensions and not actual functions of those objects. And with that, we have our initial implementation of our create author endpoint. Now I'd like to see if this works or not. So let's do that in our next lesson. So let's see if our create author endpoint actually works. So we can see here Docker Compose is running, there's adminer, and there's our database. They're both running absolutely fine. Here we are in our IDE. I'm going to restart the application to ensure that we're running the latest version of our code. Okay, that's restarted absolutely fine. And we have our front end code running as well. So let's go to our browser and take a look at our front end application. So here we are in our browser and we're running on localhost 3000. This is our React front end. You can see here we've got messages like unable to get books and unable to get authors. And that's because we haven't implemented those endpoints yet. We have implemented the create author endpoint, however. And this raises a good point. If we haven't implemented any read endpoints on our REST API, how do we prove that we've actually created this author? Well, I think we'll need to go directly to the database. So let's open up adminer. We can see here the authors and the books table. Let's go to the authors table. Let's click on select data and let's click on select here. So you can see that no rows exist in the authors table at the moment. It's our job to populate that with a new row. So let's go back to our front end. So let's click on the admin panel here and let's make sure we're on the authors tab and we'll click on add author. So this is the form that we're going to use in order to create a new author, but I would also like to see the requests and responses that are being sent. So I'm going to right click, go to inspect, and this will open up our dev tools and we're going to go to network. And all of our network requests and responses are going to be displayed here. So let's go ahead and populate this form. A name for our test author, let's say John Doe. Age, let's go 30. Description, a very good author. And now for image, let's say John Doe.jpg. So we actually have a selection of images baked into the front end already, and this is where you would put the value in order to reference those images. You'll see that later when we load in some test data. For the minute, any value in there will be absolutely fine. So we have John Doe, age of 30, a very good author, and then we have a value for image. So if we go ahead and click on create author, we expect a request to be sent to the backend, hopefully a HTTP 200 and an author created in our database. Let's see what we get. Okay, let's expand the networks panel a little bit more. Here is the request that was sent. Great. So we can see a post request sent to V1 authors and a HTTP 200 OK response. That's very good. So we take a look at the body that was sent in the request, which we can do with this payload tab. We can see the information we put into our form. Age of 30, description, a very good author, image, John Doe JPG, and then the name, John Doe. If we take a look at the response, we can see the JSON response that's come from our REST API. John Doe, age 30, description, an image, and we also have an ID of 1. So this is an ID that our backend has generated for us using that sequence in the database. So it looks like everything's gone okay and we've got our author created. In case you are wondering, these requests here, these are 405 method not allowed. So these are failed requests, a get request to authors, and for books, these are requests that would look to get the updated list of books and authors. But because we haven't implemented those endpoints yet, they will fail. So let's go ahead and take a look in our database and see if we've got an author created there. If I click on select, I should expect no rows to be replaced with a new row in the database representing our new author, John Doe. Let's see what we get. Very good. ID of 1, age of 30, a description, a very good author, image, johndoe.jpg, and the name, John Doe. So it looks like we have a success here. Our author has been created absolutely fine. Now, before we move on, I'd like to draw your attention to a quirk of the way that the front end and the back end interacts. So we go back to our front end here. You'll notice that requests are being sent to HTTP localhost 3000, which is the same URL that the front end is running on, the React app, and not the back end. Because we happen to know that our backend application runs on port 8080. So how are requests going to localhost 3000 getting to localhost 8080? Because they clearly are, because everything was working absolutely fine. Well, this is because we've configured the front end in this way. There's something called the same origin policy, which is a security mechanism built into your browser. What it generally means is requests sent to the same origin, that's the combination of protocol, host, and port, are considered secure. But sent to anything other, a different host, a different protocol, a different origin, they're seen as less than secure and require additional configuration in order to make them work. We don't want to get into the weeds with all that security, so we've proxied front-end request to the back-end. I'll show you how I did that. So if we go to the front-end code here, we're taking a look at the package.json file, and we can see this node in the package.json file, which is proxy. So what that means is requests that aren't matched to any front-end resource are proxied to this address here, which you can see is the back-end REST API. If the way that we're proxying requests from the front end to the back end seems a bit confusing, don't worry at all. You don't need to understand it for this course. I simply want to make it explicit and call it out and show you that it's there. So it looks like our create author endpoint is working absolutely fine, but we should write some tests for this and prove it. So let's get everything ready and start writing some tests. So our project setup is actually incomplete. We're missing some crucial configuration that's required in order to write tests, especially those with the @Spring Boot test annotation. So the ones that start up a test version of our Spring Boot app. This is for a very simple reason. In our application.properties file, we configured our application to connect to a PostgreSQL database. Our tests are going to try to use the same configuration when they run. So the last thing that we want is for our test to run against a production database. So we should go ahead and fix this. So before we add the configuration, let me show you the error. So I'm going to go to the terminal here and stop our PostgreSQL database from running. I'll do that with Control-C. So at this point in time, no PostgreSQL database is running. What I'll also do is stop our app from running. Now I'm going to go down to our test directory, click on Bookstore Application Tests, and then I'm going to attempt to run our Bookstore Application Tests. This has a single test in there, which simply just tests that the Spring context loads, but it is annotated with this Spring Boot test annotation. So that means it's going to start up a test version of our application. Let's see what it does. Okay, the test has failed. So let's see why. It looks like connection to localhost 5432 is refused. Localhost 5432 is the default port that PostgreSQL runs on. If we take a look at the application.properties, this line confirms it. So the solution for this is we'll set up our test to run against the H2 in-memory database. So if we take a look at our pom.xml file here, you'll see that we already have the H2 database dependency, and that's from when we set our project up in the Spring Initialzr. It's also scoped to test, which means it's available for tests, but not for our production code. So the missing piece of the puzzle is we need to add configuration to tell our Spring Boot test to use this H2 in-memory database and not the PostgreSQL one. And we can do that by adding an application.properties file just for our tests. So if we take a look in our test directory here, we have test Kotlin and then some Kotlin code. We don't have a resources directory like we do in our production code. So let's add one. So I'm going to right click on test here, go new, I'm going to go directory, and you can see here, it's already recommended for it to be resources. So let's click that, click on return. And we now have a test resources directory. In here, I'm going to create a new file and call it application.properties. Now, because this application.properties file exists in test resources, this will be the configuration that Spring Boot will prefer when running tests. I think a useful exercise would be to compare the two types of configuration. So what I'm going to do is open up the application.properties for our production code. I'm going to right click on this tab and I'm going to say split down. And then I'm going to open up the application.properties from the test code here. So you can see here on the bottom is our production code and on the top is going to be our test code. So the first thing that we're going to do is add the URL for our test database, and it looks a little bit like this. So you'll notice that this URL looks a little bit different from the PostgreSQL one. So let's break it down. So JDBC means it's a JDBC URL. It has that in common with the production code. H2 says it's going to use a H2 database and not a PostgreSQL one. That makes sense. Mem means in memory. So a H2 database can actually save files on disk and operate from those, but we're going to run it completely in memory. We're then going to declare the name of the database that we want to create, in this case testDB, and then we have some additional configuration here. So each database has its own quirks. PostgreSQL has its own quirks, MySQL has its own quirks, etc. The H2 database can pretend to be a certain database by implementing those quirks. So what we've done here is tell the H2 database to run in PostgreSQL mode, essentially pretend to be a PostgreSQL database. And all of the configuration after this is basically additional configuration in order to make the H2 database operate more like a PostgreSQL database. So why would we bother to do that? Well, our production code runs against a PostgreSQL database. We want our test to run against something that's as close to production as possible. Because if we do that, then there's a higher chance that any bugs or oddities will be raised for us when we run our tests. So why can't our tests start up a PostgreSQL database just like a H2 one? Because then we'll be using the actual database that we use in production. Well, with technologies like Docker and test containers, we can actually do that, but it tends to run a lot slower than an in-memory H2 database. So for the moment, H2 wins out. And that's the one we're going to use. So we've got our URL in there. Let's now add the remainder of the configuration and go through that. So we should be able to work out what the remainder of this configuration does. We've got the username, which is SA, and the password, which is password. These are the default username and password for the H2 database, and they're very insecure, but because this database only runs in our tests, it's absolutely fine. And then we specify the driver, which in this case is the org H2 driver, which of course is different from the driver that we're using in production, because we're using PostgreSQL in production. So with that, Spring should have enough configuration in order to run our test against our H2 database. So if we go ahead and rerun this test down here, we can see it passes absolutely fine because it's connecting to our H2 database and not a PostgreSQL database. So now that it's safe to do so, let's write some tests. So let's start by writing some tests for our presentation layer. So the first thing that I'm going to do is mirror the package structure that we have in our production code to our test code. So we can see we have a controllers package and an authors controller class. We go down to our test code. I'm going to create a controllers package. And in there, I'm going to create a new Kotlin class / file. I'm going to call this one authors controller test. And it's going to be a Kotlin class. With this class created, we're now going to add the annotation at Spring Boot test. So Spring Boot test is going to start up a test version of our application so we get access to things like the Spring context inside of our tests here. A test with the at Spring Boot test annotation is more of an integration test than it is a unit test in the strict sense. And as a result, will take a little bit longer to run than a pure unit test. But sometimes you just need access to that Spring context. Now, the particular style of test that we're going to use is going to use mock MVC. So mock MVC allows us to make fake REST API calls to our test application. We'll be able to do things like specify the HTTP method, the path, and send objects in the request body and then assert on the response that's given. So in order to get hold of mock MVC, there's a shortcut annotation which is auto-configure mock MVC. And that will place an instance of mock MVC into our Spring context that we can then auto-wire into our tests. So far we've been using the primary constructor to auto-wire things in Kotlin. So let's do that again. Let's open up a set of parentheses. We'll do a val and we'll say mock MVC and the type is mock MVC. So will this same approach work in our tests? Hold that thought. So now we'll create our test function. So we'll start with the annotation at test. This is straightforward JUnit, which we can also use in Kotlin. And then we'll declare a function with fun. And now comes something pretty cool. Now it's best practice to make your test function name as descriptive as possible for what it's testing. In Java, you would typically have a long camel case method name because that's how you do things there. In Kotlin, we have another option, and that's to use backticks. So if we name a function using backticks like this, we can put whatever we like in the backticks, including spaces in just writing plain English. So we might write something like test that create author returns a HTTP 201 status on a successful create, which you can see is a lot easier to read than doing it in camel case. It's worth noting you should only use this style of function name in your tests, nowhere else in your code. So before we implement this test, let me show you something. If we say assert that, we're going to use assert J for those fluid assertions, and we were to assert that true equals true, we would expect this test to pass, right? Well, let's see. Okay, we have ourselves a failed test, and it says that no parameter registered for parameter. Scroll right a little bit here. We can see that we can't find mock MVC. So as it turns out, just using the primary constructor in order to auto-wire things doesn't work in tests in the same way that it does in our production code. So this has nothing to do with Kotlin, this is actually a Spring Boot thing. So prior to Spring Framework 4.3, you had to put the @auto-wired annotation everywhere that you wanted to auto-wire something. So in Java, you might put the auto-wired annotation on constructors, for example. But after Spring Framework 4.3, you no longer had to do this in your production code, but we still have to do it in our test code. So how do we add an annotation to a primary constructor in Kotlin? Is it as simple as just adding auto-wired in front of the primary constructor like that? I think the red squiggles give it away, but this isn't the way to do it. In order to understand why this doesn't work, we need to learn a little bit more about Kotlin first. So let's get into that in the next lesson. What if I told you that all this time we were writing the shorthand version of the Kotlin primary constructor? We've done this because right up until now, we haven't needed to add any annotations to the primary constructor. As soon as we do, we need to use the full version. So if we go back to our author's controller test and remove the auto-wired, we can see that everything compiles fine. To do the full version of the primary constructor, we would need to add the constructor keyword before the parentheses. And you can see it still compiles fine, but IntelliJ has grayed out that constructor keyword. However, if we go ahead and add the auto-wired annotation now, we can see that the constructor keyword is no longer grayed out. So if we go ahead and run our test for this class now, we can see it passes absolutely fine. So we now have an instance of mock MVC we can actually use. So let's go ahead and use it. And now for mock MVC. In Java, mock MVC is a little verbose and it's quite tricky to remember just how to use it. But through the power of Kotlin extensions, we have a much simpler DSL, or domain-specific language, to work with. So DSLs are a little like a programming language, but they're for a very specific task, which in this case is using mock MVC. So first up, let's do some tidying. So let's remove that dummy assert. And while we're here, let's put a private visibility modifier on that val. Okay, we're ready to go. So let's use mock MVC. And the first step is we're going to declare the HTTP verb to use, which in this case is going to be post. And now we'll declare the path, which we know to be /v1 authors. So far, we're doing the same thing as we would do in Java, but it's at this point that things get a little bit different. So the next step is we need to open a set of braces. And these braces represent a function literal, which makes our post function here a higher order function. So I like to think of functions as a machine. You put in some inputs, it processes them in some way, and then it returns a result. And in Kotlin, functions are first class, which means you can store them in variables and in data structures just like any other value. And get this, functions can even be passed as arguments to other functions and be returned by functions as a result. Any function which accepts a function as an argument or returns a function is called a higher order function. So what about function literals? Well, we've already come across normal functions in Kotlin. They're the ones that are declared with the fun keyword, they're giving a descriptive name and an implementation. In Kotlin, function literals are functions that aren't declared with the fun keyword, but instead passed immediately to something else, like as an argument to a higher order function. So there's two flavors of function literal in Kotlin. You have the lambda and you have the anonymous function. The difference being that you can't declare a return type of a lambda, but you can do with an anonymous function. In most cases, the Kotlin compiler just works out the return type of the lambda, which is what we're going to use in our case here. So what have we learned here? Functions are first class in Kotlin. They can be passed as arguments to other functions, and that's called a higher order function. And that's how the mock MVC DSL works. So why on earth have we opened a set of braces after the parentheses here? Essentially declaring a lambda outside of where arguments should go. So this is a weird Kotlin thing. Essentially, if the last argument to your function is a lambda, you can declare it outside of the parentheses. Why would you want to do this? Apparently it's more concise and readable. I'll let you be the judge of that. So we know these braces represent a lambda, and this lambda is actually an argument that we're passing into our post function. So what do we put inside of this lambda? Well, first I'm going to declare the content type. And we know the content type of this request is JSON. And that's because we want to send a JSON object in the request body. We'll also declare the accept header while we're here, which again is going to be of type JSON. So basically what we've done here is said, I'm sending JSON and I expect JSON to be returned, which is something any typical caller to a REST API would do by setting the appropriate headers. So here's another weird thing. How are we able to assign properties inside of a lambda? Well, if we click through to post here and scroll right, we can see that the lambda is actually an extension function on the mock HTTP servlet request DSL. Clicking on this, we can see there are a whole bunch of properties which are vars, and because they're vars, it means we can assign new values to them. This might all seem a little bit complicated, but it allows you to create this rather nice DSL. Because what we're essentially able to do here is declare post, declare the URL, and then inside of these braces, declare all sorts of information like the content type and the accept type. We won't dig any further into how to build a DSL in Kotlin. This basic knowledge should be enough for the minute. But if you're used to Java, this might look a little bit weird. Now, just like how the front end did, we want to send an object in the request body. And we can do that by saying content, and then we would assign a value to content. The easiest way to do that is with the Jackson object mapper. So up here, I'm going to declare a val called object mapper and assign a new instance of object mapper to it, just like that. Now there are nicer ways to do this, but this should give us what we need for the minute. So we can use this object mapper to convert a Kotlin object into a JSON string with the function here, write value as string, which requires us to pass a Kotlin object to it. Now we know that our create author endpoint requires an author DTO in the body. So let's create one right here. Let's import that and then declare some values for this. So here we've just populated the author DTO with some test information here. We're not providing an ID because we don't for our create endpoint. And then we have an example name, age, image, and description. And that's about it for the request. We now get to do some assertions on the response. And we'll do that by calling the and expect function, which again takes a function literal. So this test is there to assert on the HTTP status code. So we can do that by using status and then declaring what the status should be, which we can do with is created. And this will assert that the response has a HTTP 201. And you can see this DSL is again made up of a combination of functions and function literals. So what do we get when we run this test? Let's see. Well, it looks like we've got a failure. Let's understand why. And if we scroll down here, we can see that there's an assertion failure because as it turns out, HTTP 200 is returned instead of 201. So in order to fix that, we would need to return a different HTTP status code from our controller. So we go back to our controller here, author's controller. The way that we would control our response type is by using the response entity. So rather than return an author DTO, we're going to return a response entity of type author DTO. So rather than return our author DTO, let's assign it to a val and we'll call it created author. And then we'll return, create a new response entity. And within the response entity, we'll pass in our created author. And then we'll return the HTTP status code of created, HTTP 201. So by wrapping our author DTO response in a response entity, we can then control additional things such as the response code. So this will now return HTTP 201 in theory. Let's rerun our test. Great, and we can see it's passing absolutely fine. So we now have our first test for our presentation layer, which uses the Spring Boot test and the new Kotlin DSL for the mock MVC. So let's take a different approach to testing in our next lesson. So our first test simply tested the HTTP response code. It didn't go as far as testing the interaction with the service layer or that the author was actually saved. So let's test that now. We'll achieve this by using mocking, which is when objects pretend to be certain components in our system. Say, the author service, but we can tell them to respond in a very certain way or to return something specific, or even ask questions of it on how it was called. In this way, we're able to test certain parts of our system, say the author's controller, in isolation by checking how it interacts with our mocks. Okay, isolation is a bit of a fluid concept anytime that you use a Spring Boot test, but we're going to try and isolate the presentation layer as much as possible by mocking out the service layer. I'll give you the heads up now, setting up mocking with Spring Boot and Kotlin takes a bit of effort, but trust me, it is worth it. So when attempting to mock out a service in a Spring Boot test, we would typically use the mock bean annotation, at least in Java. The mock bean annotation uses the Mockito library to create a mock instance of our bean, such as our author's service. It then places that mock bean into the Spring context, so it's injected every time that we have declared that we need a bean of that type. So every time our test code injects a bean of that type, instead of getting the real implementation, it gets the mock. And that's pretty convenient. There's a few differences between Kotlin and Java, which make Mockito, originally written for Java, really tricky to use in Kotlin. Let me show you. So here we are back in our author's controller test. Now I want to isolate the presentation layer testing from the rest of the application as much as possible. And I'm going to do that by attempting to mock out the service layer, which specifically in this case is our author's service. So how we would typically do this is in our primary constructor, we're going to say at mock bean, noting that that imports from Mockito. We're then going to declare a val of author service of type author service. Now let's create a new test. And I'm going to call this one test that create author saves the author. So in this test, we're going to make the same request that we did down here. So I'm just going to borrow this mock MVC request. And now I'm going to say what we would expect the service to be called with, which of course is an author entity. So I'm going to say expected equals author entity. And the value is going to be pretty much the same as our author DTO. So let's assign that like so. And now we're going to do our assertion, which is going to be a verify. And we're going to verify that the author service save function was called with a value that equals the expected. Now in Java, this would be a really good test, but see what happens when we run it in Kotlin. So we get a failure here. Let's take a look at why. So there's our test app starting up. And now we have a servlet exception which says null pointer exception, parameter specified as non-null is null, to author DTO. For this particular setup, Mockito just doesn't get it, but luckily that's what mock k is for. So mock k is the mocking library for Kotlin. It offers an expressive DSL just like Mockito, but more importantly, it just works. So let's get our project set up to use mock k. Let's start at the pom.xml file. So the first thing that we're going to do is exclude the Mockito dependencies, because when we include mock k, it would be a little bit awkward if we still have Mockito around. Plus we don't want them to conflict because a lot of the annotations are similar. So we're going to track down the Spring Boot starter test, which is here. So this is the starter that brings in the Mockito dependencies. And we're going to add some exclusions, which look a little bit like this. So what we're saying is we do want everything that's in Spring Boot starter test except for Mockito, which is broken up into Mockito core and then Mockito JUnit Jupyter. So if we refresh our project in IntelliJ now, there we go. We no longer have Mockito. So let's add the mock k dependency. I'll add this just after, I think. So the mock K dependency looks a little bit like this, and we're just going to refresh this to bring it down. Great, so we now have the mock K dependency available to use. So let's go back to our authors controller test. And what I'm going to do is remove the mock bean annotation here. And I'm going to replace it with Makito's one, which is mock one additional K bean. Mock bean. So mock K's approach is very similar to Makito's approach. This is going to create a mock bean of type author service and make it available to be auto-wired. Now, if we scroll up, we can see that we've got some Makito imports that just don't work because we no longer have the Makito dependency. So let's remove those. And if we go down to our test here, we'll update this to work with mock K. So rather than parentheses, we're going to use a set of braces here. It's a trailing lambda. I'm going to import verify from mock K. And the save function is going to be inside of the trailing lambda this time. And we don't need that EQ. We can remove that. And that looks a lot more Kotlin. So let's see what happens when we run our test now. So we have a failing test, but this is actually a good thing. This is mock K saying save was called, but nobody told me about it. So I'm going to throw an error. So we need to set up an expectation. We need to tell mock K that this save function is going to be called. And the way that we would do that is with this syntax here. So we say every, which is sort of like every time. So every author service, which remember is a mock K mock, dot save. And we don't really mind what the argument is. So we're going to say any. So anytime author service dot save is called, we'll say it answers with whatever the argument was that was passed in first arg. So if you think of this from the save function's perspective, we pass in an author entity, it then saves it into the database and then returns that saved author entity. Arguably, it does also have an ID when it's returned, but for the sake of this test, this should do absolutely fine. So if we now run the test once more, we can see it passes absolutely fine. Now, I always like to see a test failing for the right reasons first. So I'm going to remove the H from John, which will not match our expected value. So let's rerun our test and see what the error would be. Okay, great. We've got a failing test. Let's see if it's failing for the right reason. Yep, it looks like we have a failed test because of verification failed. We've got here John Doe without a H, looking to match John Doe with a H. So if we put that H back in, it looks like this is a completely valid passing test. So let's make sure all is in order. Let's run all of the tests in this class. Okay, it looks like the one we were just working on passes, but the other one fails. And it fails because no answer was found for save. Of course, a save would also be called for that function too. So what we could do is copy and paste this over to the other test as well. I think it would be cleaner if we move this out to a central place. So I'm going to do a before each. So I'll use the before each annotation, and this function is going to run before each of the tests. And it's going to set up the expectation that whenever author saved is called, we want it to return the first argument. So if we now run our entire test class, great, and we can see it's passing absolutely fine. But we're not done yet. We haven't checked to make sure that the author service is actually saving the entity to the database. Let's do that now. So we're starting to see some duplication, and we want dry code, as in don't repeat yourself. Because non-dry code with duplicates all over the place is much harder to maintain. So let's tidy things up. So I'm going to go to the root of the test directory here, and I'm going to create a new Kotlin file, and I'm going to call this one test data util. That's going to be a Kotlin file rather than a Kotlin class. Within here, I'm going to create a function, and I'm going to call it test author DTO A. And because the ID will likely change quite a bit, we'll specify that as an argument here. And the ID, of course, is type long, but we'll make that optional, I think. And then we'll provide a default value, which is actually going to be null. So when calling test author DTO, we can actually miss out the ID argument because it will default to null, but we could also provide it and make it available to the function here. And now this function is going to return an author DTO. The ID will be the ID that's passed in. The name, well, let's call that one John Doe. Age 30. Description, we'll say some description. And the image will be author image.jpg. Oh, let's treat ourselves. Let's make that a JPEG. There we go. And of course, we'll need to declare the return type of author DTO. In fact, instead of doing that, what we'll do is we'll say equals remove that return, and simply return the author DTO like so. So in practice then, if we want an author DTO to use in our test, we can simply import and call this function. If we want to be specific what the ID should be, we can provide it as an argument. But because the argument has a default of null, we simply can miss it off. We don't have to provide it at all. So let's get to using this function. Let's go back to our authors controller test. And every time that we are constructing an author DTO like this, I'm simply going to use that function instead. Let's import that. Perfect. And we have another one down here. Let's import that function. Very good. And you can see that we don't have to provide any arguments, but if we provided an argument like that, for example, then it would be 6 that uses our ID. And without it, null will be used as our ID. So let's run all of the tests in our project. Okay, we've got a failure here. Why is that? We have a slightly different value. So let's fix that. Try once more. Perfect. It looks like all of the tests are passing absolutely fine. So let's get on to writing some tests for our service layer. So let's write some integration tests for our service layer and our persistence layer. So the first thing we're going to need is a package for our services here. So let's create a package in our test directory called services. And that matches what we have in our production code. To completely reflect it, we're also going to create another sub-package in there called impl. And inside of that impl directory, I'm going to create a new Kotlin class called author service impl test. So we want a test version of our app spun up for this. We want to use that H2 database. So I'm going to put the @Spring Boot test annotation on top of that class. We don't need mock MVC here because we're going to be calling the services functions directly. So we're going to need a reference to our author service. So let's create our primary constructor here. We are going to need auto wired. So we do need that constructor keyword. And let's declare a private val calling it, let's call this one under test. And it's of type author service impl. We've called it under test because that's just a convention in order to pick out the thing that's under test. Go figure. And we're using the particular type, the implementation type, author service impl, rather than the author service interface here, because we're specifically testing the author service impl in this class. So let's create a test. First, we'll declare our test annotation, importing that from JUnit Jupyter. And now we'll declare a function and we'll name this test with backticks and we'll call it test that save persists the author in the database. So this test is going to do 3 things. We're first going to call the save function on our author service impl. That should hopefully save our author in the database. We're then going to use the author repository directly in order to get the author from the database and make sure it's what we expect it to be. So save using our service, retrieve using our repository, assert to make sure that that author is what we expect it to be. We're using the repository because we want to retrieve from the database separate from the service. If we use the service to retrieve from the database, it wouldn't be a very good test because we are testing the thing by using the thing. We'll use the repository. So first we're going to call underTest.save. Now we're going to need an author entity. Now in our test data util, we created a test author DTO, but we didn't do an author entity. So let's do that now. So rather than return an author DTO, this is going to return an author entity, and we'll call the function test author entity A. And by convention, we'll use exactly the same values as our author DTO. So test author DTO A matches test author entity A. I think that will be a nice organized way of doing things. So let's go back to our test here and we'll save a test author entity A and we'll not specify an ID. And that's going to return for us the saved author. And remember, this is an integration test, so it's actually going to save this in our H2 in-memory database. Now, we're going to use the repository to retrieve from the database, so we need a reference to the author repository. So let's declare a private val author repository of type author repository. So in order to retrieve the author from the database, we're going to need to use its ID. So I'm going to do an assertion here, and I'm going to assert that saved author.id. Let's make sure that we import assert that from assert.j. And we're going to assert that the ID is not null because we need that ID in order to retrieve the author from the database. If it's null, we should just fail the test there. So now we're going to recall the author from the database using the repository. So I'm going to say val recalled author, and I'm going to use the author repository dot find by ID passing in the ID from our saved author here. Now there's a couple of oddities with this line. In theory, it should just get the author by its ID, but we have a red squiggle underneath saved author by ID. And the reason for that is because the author entity ID type is a nullable type. If we go there, we can see that it's a long with a question mark next to it. So the Kotlin compiler is forcing us to deal with the case. In fact, you can see it there. There's a type mismatch. There's a couple of different ways of dealing with this. I'm going to show you perhaps the quickest and dirtiest way because we are in a test right now. So we're going to do a double exclamation mark next to save author.id. Now this approach is very similar to calling .get on a Java optional. If the value is there, then it's going to return it. If the value is not there, then it's going to throw a null pointer exception. Now bear in mind the whole point of nullable types in Kotlin is to try and avoid those null pointer exceptions. So using this in your actual production code does not provide any value for you. But this is safe in this instance for two reasons. One, we're asserting that the ID is not null up here in our test. And two, we're in a test. So if we do find that a null pointer exception is thrown in our test, that will result in a failed test. But there's more than one oddity with this line. Let's take a look at the type of recalled author. We can see that it's a Java optional, which is sort of like a Java equivalent to Kotlin's nullable type. A Java optional can either be present, have a value, or it could be null, it could be empty. But we're in Kotlin. Wouldn't it be better if we had a nullable type instead of a Java optional? Well, the thing is that Spring Data JPA was originally written in Java, for Java. So find by ID is going to default to the Java way of doing things. But there is an alternative, and that's by using a Kotlin extension named find by ID or null. You can see that the IDE has highlighted this as blue, identifying it as a Kotlin extension. So this is really cool. Essentially, Spring have been able to take Spring Data JPA, that library, and without changing it, use a Kotlin extension in order to provide some Kotlin specific behavior here, which is returning a Kotlin nullable instead of a Java optional. So if we take a look at recalled author now, we can see that it's an author entity with a question mark next to it. It's a Kotlin nullable type. So let's do some assertions. We're going to assert that recalled author is not null. So find by ID or null can return null. So we want to make sure that the value returned is not null, that it's actually found a value in the database and it's returned it. So we've asserted that a value is returned. Now let's make sure that it's the right value. So we're going to assert that, the recalled author, and we're going to use bang bang again to convert it from a nullable type into a non-nullable type. And we're going to say is equal to, and then we're going to pass in what we expect it to be. And what do we expect it to be? Well, it's going to be test author entity A with the ID of saved author.id. So essentially, we want it to be exactly the same as this, but with whatever the ID is that the database has provided. In order to get a failing test though, I'm going to change this to be a number it's very unlikely to be. So we're going to go with a bunch of 9s. There we go. So this is the three things this test is doing. We're saving an author entity into the database by using the author service. We're then recalling the author from the database using the ID that the author service has returned. We're making sure then that what's returned is exactly what we expect it to be here. However, in this case, we're changing the ID because we want to see a failing test before we see a green test. Otherwise, we run the risk of that test passing for the wrong reasons. So let's run this test and see what we get. Okay, we've got a failing test. Let's see why. So it looks like there's a difference between what's expected and what's returned. The image seems to match, the description seems to match, age matches, name matches, the ID doesn't. So let's fix that in our test there and run it once more. The test passes absolutely fine. So it looks like we have a valid passing test here. At this point, typically we'd add some additional tests and maybe some negative tests. But I think there's more value in pushing forward and moving on to our read author endpoint. Now that we have a feel for implementing and testing an endpoint end-to-end, let's get going with our author read many endpoint. This endpoint will list all of the authors that we've saved in the database and will be our first look at Kotlin collections. The HTTP method that we're using for our authors read many endpoint is going to be get. The URL that we're using is going to be exactly the same as the create author endpoint. The difference being is that we don't need to provide anything in the request body for this one. So let's go back to our IDE here and head over to our authors controller. So there's our create author endpoint. We're going to need to create a new one now. So first up, rather than the post mapping annotation, this one is going to use the get mapping annotation because it's using that HTTP get verb. Let's import that. So we said the URL is going to be exactly the same as it is for the create author method. Now we could copy the string, but that would give us duplication. So a better way of doing it is to put that string in one place. So on top of the controller itself, we're going to add a new annotation, and that's the request mapping annotation. So if we import this, open a set of parentheses, and you'll see that we're able to provide a path in here. So if we take the path from the create author function and place it in our new request mapping annotation, we no longer need to provide the path for the post mapping annotation, and we no longer need to provide it for the get mapping annotation. This will now be the base path that's used for all endpoints on this controller. So with that done, let's now declare a function, and we'll call this one read many authors. Because we're not expecting a request body or any request params, query params for this, we don't need to provide any arguments in our parentheses, but we do need to provide a return type. And this is going to be a list of author DTOs. And we would declare that in Kotlin like so. So you can see that the way that we declare a list type in Kotlin is fairly similar to Java, except for Kotlin lists come in two different versions. The first is mutable, and they inherit from mutable list. This is the most like Java because you can add and remove elements from the list by using the functions declared in its interface. You can always tell if your list is mutable because it will inherit from an interface that has that mutable prefix, such as mutable list. The second version are the read-only collections, and these are just referred to by their name, such as list, set, and map. These interfaces don't allow for adding or removing elements from the collections. As a result, there is no add or remove functions in those interfaces. The read-only versions of collections are the default in Kotlin. Note that read-only isn't the same as immutable. Technically, there are ways to mutate a read-only collection in Kotlin, but you really shouldn't. When things don't change, there's generally less complexity, but when they really do need to change, you can then use the mutable collections. We could declare the return type as a mutable list, a little bit like this. But as we're Kotlin developers now, we're going to take the language's lead and we're going to use the read-only version, so we're just going to declare the list return type, which if we take a look through the interface here, we can see doesn't have any add or remove functions available. So let's go about actually getting a list of authors. So let's head over to our author service interface here, and let's declare a new function. And we're going to call this one list. Doesn't take any arguments, but it will return for us a list of author entity. Now, if we go to the implementation of our author service interface, let's implement those members, which is list. There's our stub, so let's remove that. So we simply want to get a list of all of the authors in the database. We can just pass through to our author repository for that. So let's say return author repository dot find all. Now here's something to point out. If you take a look at the return type of find all, it's actually a mutable list of author entity. But if we select this, you can see that everything compiles absolutely fine. And the reason for this, if we go into find all here, so this is obviously written in Java, so it returns a Java util list. So Kotlin sees that as a mutable list. So let me say that again. If your code is Java code and it returns a Java list, then Kotlin will see that as a mutable list. So why does everything compile absolutely fine here when our find all function returns a mutable list and we've declared that our list function returns a read-only list? Well, the reason for that is that the mutable list interface in Kotlin actually implements the list interface in Kotlin. To put that a different way, everything that's implemented in list is also implemented in mutable list. And because Kotlin has its roots in Java, and we can use a subclass anywhere that we've declared a superclass, it means that we can return a mutable list where we've declared a read-only list. So now that we have our list function implemented in our service, let's get back to our controller here. So we already have a reference to our author service that's already injected into our class, so we can use it inside of our read many author function. So we'll say author service dot list, and that will return a list of author entity, which of course is different from the return type of list of author DTO. So if I were to put a return keyword in here, we would see we get that red squiggle, which tells us just that. So we need to convert a list of author entity to a list of author DTO. The way that we're going to do that is with the map function. We can call the map function on our list, and that accepts a lambda. The map function then applies a lambda to every single element in that list, and once it's done, it just returns the list. The map function in Kotlin works very similar to how it works in Java streams and other languages like JavaScript. A little quirk of the Kotlin map function is that we can refer to the element that the lambda is being applied to with the it keyword, and you'll see that used in a moment. A side note to the map function in Kotlin is that the list that's returned from the map function has elements in exactly the same order as the list it's called on. It will be a new list with the elements transformed with the lambda that we pass in, but in the same order. So we'll call the map function onList, and that's going to give us that trailing lambda. We'll now use the it keyword in order to refer to the element that the lambda is being applied to, and we're going to call on there toAuthor DTO. So we have here a list of author entities, therefore it is going to be an author entity. We have our Kotlin extension which converts an author entity into an author DTO. So we'll simply call that on our author entity, which is referred to with the it keyword. So now we have a list of author DTO. It's worth noting that the it keyword, that convention where we can refer to the element that the lambda is being applied to, well, that's actually a lambda thing and not to do specifically with the map function. We can use that it keyword whenever the lambda refers to a single element. If there's multiple, then we can't use the it keyword. But there are ways of dealing with those, and you can assign names to the multiple elements. So this should be enough to have a working read many authors, a list authors, endpoint. So if we restart our backend application now, we should see this working in our front end. So let's give that a go. Looking good, that started up fine. So let's open up our front end in our browser. So here's our front end application. I've opened up the network tab on our dev tools. I haven't refreshed the page yet, so let's do that now and see what we get. Okay, we have something a little bit different. Okay, let's take a look at our network panel to begin with. And let's put on the fetch XHR filter just to see the request to the backend. Okay, and we can see that we've got a request to our list authors endpoint, our read many authors endpoint, and it's got a 200 OK status. Let's look at the response body, and we can see a single author return. So that's John Doe, age 30, a very good author, johndoe.jpg. So this is the author that we created when we were testing out our create author endpoint. So it's worth noting that we do get a card returned here for John Doe, but we're not seeing an image. We are seeing the information that we supplied when we created our author here, but it's not very representative of what we want the application to look like. The reason for that is because johndoe.jpg, it doesn't exist. That image doesn't exist. Now we do have a set of images and they link up to our test data. So in order to get a good test case on the go, I feel like now is a good time to load in some test data. So let's do that in the next lesson. Let's load some test data into our database. This way, when we test our new endpoints in our browser, we can see a representative view of if they work or not. So let's start off by opening up a browser and logging into Adminer, so localhost 8888. So we can see here we've got our authors, books, and our Flyway schema. If we take a look at the authors table there and select data, we can see we have John Doe, a very good author, ID of 1. Unfortunately, it's time to say goodbye to John Doe because we'll need to clear out the database in order to load in this test data. But once the test data is in there, we will be able to create new records. The way we're going to do this is by resetting our Docker Compose environment. So if we go back to our IDE, open up our terminal, this is where we were running Docker Compose. So I'm going to cancel out of this, Control C, and Docker Compose RM to make sure everything's deleted. So we've now stopped and deleted everything from the previous environment. We're now going to go docker-compose up, and this will start up a fresh environment for us. Okay, so that's up and running. Let's go back to Adminer, refresh the page, log back in. We can see that we don't have any tables, so we'll restart our application. Okay, that's the application restarted, back to Adminer, refresh the page. So we now have our Flyway schema history, books and authors. Flyway's created our tables for us, and we look in authors, select the data, we can see that we don't have any rows. So let's load in our test data. We need to go to SQL command in Adminer, and then we'll get this box here. So now to paste in the test data SQL. I'll link to this SQL down below so you can copy it and paste it in as well. Once that's pasted in, we'll simply click on execute, and that will load the SQL into our database. So when we now go back to our tables, take a look in authors, select the data, we can see that we have some test data in there. So if we now go back to our front end running in our browser, refresh the page here, we can see that we have some representative test data for our read many authors endpoint. We can see the full list of authors by going to the authors tab here. This of course uses the read many authors as well, and we can see the full list of authors in our application. So now that we've got some test data in our database and we can see if our endpoints work representatively, it looks like our read many authors endpoint is working fine. But let's prove that by writing some tests for it. So let's test our author read many endpoint, and let's start with our controller test. So let's go down to our test directory and go to authors controller test. So let's start with the case when there are no authors in the database, where we expect a HTTP 200 and just an empty list to be provided. So let's declare a new test, and we'll call this one test that list returns an empty list and HTTP 200 when no authors in the database. We'll need to set up our mock for our database, but let's set up mock MVC first. In this case, we're going to say mock MVC, and we're using the HTTP get method. So we'll call the get function on our mock MVC. So now we'll need to specify our URL, and our URL is going to be exactly the same as what we've used up here in our test for create authors. Now, rather than duplicate the string, which I believe we've already done over here, let's extract that string out, and let's extract it out to a constant. And let's call this one authors base URL. And now we can use this throughout our class. It's already been swapped out there, and we can place it in there as well. So we can see here that the constant's been placed outside of our class, and it's been declared with the const keyword in addition to the val here. It's private in its visibility, meaning it's only accessible inside of this file. But as this string will never ever change, a constant feels like a good fit here. So now that we've specified the URL, let's specify the headers of our request. We're going to have an application JSON content type, and we're going to accept application JSON, just like our post request. So we'll declare that inside of our trailing lambda. And now for our expectations. So an expect the HTTP status code. Well, we want that to be not is created, but is okay. HTTP 200 and the content. So the response body, that's going to be JSON, so we can use the JSON function there, and then we can declare the JSON that we expect. Now this should be an empty list, so this should be an empty JSON array. We like to see a failing test before we see a passing test, so I'm going to make it an empty JSON object. We won't be expecting a JSON object. This will cause a failing test for us. So if we run our test, let's see what we get. Okay, here's our red test. Let's see why it's failing. See if it's failing for the right reason. Of course, we need to set up the mock expectation. I did mention that. We didn't do it. So let's go ahead and set up the mock expectation for this. So as it's mock K, we'll start with every, and it will be every time the author service dot list. We want it to answer with an empty list. Now in Kotlin, there is this shortcut to declare an empty list, and it's simply the function empty list. So that should set up the expectation for mock K. So if we rerun our test, we can see it's failing. Let's see if it's failing for the right reason. Yes, it's to do with the JSON object that we have specified in our expectation, but we're getting a JSON array. So as it turns out, a JSON array is just what we expect. So let's change it there and rerun our test. Looking good, so that's now passing. So let's now write the test case when our service layer does actually return some authors. So we'll do a new test, and we'll call this one test that list returns authors and HTTP 200 when authors in the database. Great. So our test is going to be fairly similar. So let's use the content from the previous one as a starting point. So rather than return an empty list, we want to return a list of author entities. Now we can declare a list using the Kotlin list of, and then pass in our elements. In this case, we can use our test data, test author entity A, and let's provide an ID of 1 in this case, because it's already been saved in the database, it would have an ID. So we now have an author returned from our author service list function. The mock MVC get request would be the same, but the expectation would be quite different. So in order to see our failing test, let's go ahead and run this. Okay, there's our failing test. Let's see why it's failing. Okay, so it expected an empty list, but it got a value. This is good. So what we're going to do now is move from using the JSON function here to using JSON path. And this will allow us to assert on the various attributes inside of that JSON object, the first element returned. So let's change our function here to be JSON path. And JSON path is written like so. Starts with $. Now we want to say for the first element in the list, we do that with some square brackets and a 0. So it's 0 index, so the first element in that JSON array. And then ID. So we're now referencing the ID attribute on that JSON object. And now we want to say it's equal to the number 1, because that's the ID that we set up here. Now we need to import equal to. Now this comes from the hamcrest matches library. The hamcrest matches library allows us to check if one object matches another. Truthfully, hamcrest is a lot more advanced than that, and you can combine different matches in order to test for some pretty advanced use cases. We're just going to use the basic ones for now. So we're checking that our ID is equal to 1. Now, if we do scroll up here a little bit, we can see the object that's returned, which is the representation of the author that we've saved in the database. This, of course, is our author DTO. So let's now write some assertions for the other attributes in our object. So let's open our test author entity A, and let's do a split screen and put that on the bottom there. ID is going to be equal to 1. The name, well, we want that to be equal to John Doe, which is the same as here. The age, well, that's 30. The description, well, that's some description. And the image is author image.jpeg. So these assertions will check that the first object in that JSON array has these attributes. So if we go ahead and run our test now, we can see it passes absolutely fine. So that's to say that we get a HTTP 200, a list of authors, with our expected author as the first element in that list. Let's now write some tests in our service layer. So let's go over to our author service import test, and let's create a new test in here. So we're going to start with the case when there are no authors returned. So we'll call this one test that list returns empty list when no authors in the database. This one is going to be fairly straightforward. So we'll just declare a val and we'll call this one result. And then we'll say under test, which is the name of the author service in this class, under test.list. And because we haven't loaded anything into the database, we expect this to be empty. So let's now do an assertion. We'll use assert.j for this. Assert that result. Now we're expecting an empty list, and I always like to see a failing test before we see a passing test. So we're going to say is not empty. So in theory, this should be a failing test because, well, we expect it to be empty. So let's run this test. Great. Okay, we've got a failing test here. Expecting actual to not be empty. So if we now change this to is empty and run our test, we see we get a valid passing test. So now let's do a test case when authors do exist in a database. So we'll call this one test that list returns authors when authors present in the database. So first we need to save some authors in the database. So we'll do that by using the author repository that we have up here. So we're going to say author repository.save, and then we'll need to pass in our author entity. Just so happens we can get one easily by using test author entity A. We're not going to specify an ID because this test uses the in-memory H2 database, and it's possible to generate an ID for us using a sequence. So let's also assign this to the variable saved author, and we'll do that with the val keyword. So we would expect the list to return a list with just our saved author in. So our expected is going to be a list of just including our saved author. So let's actually call our author service and see if that's the case. So we'll go under test.list. And we'll assign that to the val of result. And now for our assertion, we'll assert that result is equal to expected. And again, we always like to see a failing test before we see a passing test. So I'm going to comment this out, / there to comment, and I'm going to say empty list. And it's going to be an empty list of author entity. So there's a couple of things here. The comments work exactly the same way as in Java. And because Kotlin wasn't able to work out the type of the entities in this list, we're having to specify it here. Note how the IDE automatically populated those corner brackets in order for me to tell it the type. So this should give us a failing test. Let's run it and see. Great. Let's see if we've got a failing test for the right reasons. Yep, we're getting an author entity returned, but we're expecting that empty list. This is for the right reason that it's failing. So let's put that back to be a list of saved author. Run once more. Great. Okay, we have a valid passing test. So we've got a test for the empty case and when authors are returned using our list function. So let's run all of the tests in this class and just make sure that they pass. Looking good. So before we move on, let's run all of the tests in our application and make sure that they pass. Great stuff. So that wraps it up for the read many authors endpoint. Let's move on to the read one author endpoint. Now for the read one author endpoint. Now this is quite similar to the read many authors endpoint in the sense that authors are returned from the backend. However, there are a couple of differences. In this case, of course, we're only expecting a single author and not many. And we specify that particular author by passing their ID within the URL. If an author exists in the database that matches that ID, then we get that author returned in the response body with a HTTP 200 status. However, if that author does not exist in the database, then we get an empty response body and a HTTP 404 not found. So let's implement it. Let's head over to our author's controller and let's now declare another get mapping. This URL is slightly different to the one that's used for read many authors. We need to specify the ID in this URL. Because we've specified the base URL on the entire controller of v1 authors, we only need to specify the end bit, the bit that specifies the ID for our read one author endpoint. And we can do that by passing the path param in here, and then we'll say /, and we need to specify the ID in a very particular way. And we do that by saying path equals square brackets, and within here, / braces ID. We specify the ID in the URL in this very particular way because then we can access it later as an argument to our function. Let's call this function read one author, and it will return a response entity of author DTO. We use a response entity in this case because it will allow us to return either a HTTP 200 or a HTTP 404 not found. So how do we access that ID? Well, it's done with this annotation, path variable. And inside of the parentheses to this annotation, we'll specify the name that we've used in our path here, which in this case is ID. And now we can assign this to a variable, and we're going to assign it to the variable called ID, and this is going to be of type long. So what will happen when the application is running, requests sent to this endpoint, Spring will pick out the ID, but only IDs that are a number, and make it available in this variable here for use inside of our function. And this only works for numeric IDs. If we tried an ID with some letters in there, it wouldn't match this endpoint. So now let's implement our service function. So we're going to head over to the author service here, and we'll declare a new function on our interface. And let's call this function get, as in get an author. And this will need an ID. So let's specify an argument of ID of type long. And for the return type, we'll say it returns an author entity with a question mark after it. So this is a nullable type. It may return an author entity or it may return null. If we pass in an ID and that author doesn't exist in the database, we get a null. However, if we pass in an ID and it does exist in the database, we get ourselves an author entity. So let's go down to the implementation and implement our function. Let's implement members. So let's remove this to do and let's return author repository dot. So we want to return a nullable type in this case. And we've already seen that there are some extensions which return a nullable type from our repositories. And we have one called find by ID or null. So if we pass in the ID, this should be enough to implement our function. When an author exists in the database that matches the ID, we get ourselves an author entity returned. So if there isn't an author in the database that matches the ID, we get ourselves a null. So if we go back to our author's controller now, and now we'll call our author service dot get, passing in the ID, and let's assign this to a val, and let's call this one found author. So we take a look at the type. I can do this by holding down the control key. We can see here that we have an author entity with a question mark after it, a nullable author entity type. Of course, we want to return an author DTO. So let's start by converting our nullable author entity into a nullable author DTO. And we can do this with the safe call operator. And that looks like a question mark. And then we can go dot to author DTO, which is our Kotlin extension function, which will convert an author entity into a DTO. So this question mark says when there is an author entity, as in when it's not null, then we call to author DTO on the author entity. However, in the case that it is null, then to author DTO is not called. And this is our safe call operator. So if we now take a look at found authors type again, we can see it's a nullable type of author DTO. If we missed off that question mark, we can see that only safe or non-null asserted calls are allowed in this case, because the Kotlin compiler is forcing us to deal with the case where we could encounter a null. So let's put that question mark back in. So we now have a nullable author DTO type. How do we deal with it? Well, we want to do one of two things. If the author exists, then we want to return it in the response body with a HTTP 200. However, when it doesn't exist, we simply want to return a HTTP status code 404 with an empty response body. In Kotlin, there's a nice and concise way of dealing with this. So we're going to say found author, And because this is a nullable type, we're going to use our safe call operator. On this, we're now going to call let. Let is an example of a Kotlin scope function. The let function allows us to execute some code, so execute a lambda in the context of that object. So what this means in practice is within that lambda, we can refer to the object using the it keyword. So found author is nullable. In the case that it is not null, run this lambda against it. In the case that it is null, don't run this lambda against it. So in theory, this makes our code more concise and easier to read. So in the case that it does exist, we want to return a HTTP 200. So we're going to say new response entity, and we'll pass in the body, which is it, so the author DTO, and we're going to specify the HTTP status code of OK, which is a HTTP 200. And let's put in a return here. But this return is completely optional because the last line in a lambda is returned by default without a return keyword. And that's Kotlin allowing our code to be a bit more concise. We now have the case dealt with where our found author exists. What about the null case? Well, Kotlin has us covered again, and we can use the Elvis operator. So the Elvis operator is named after Elvis because if you kind of turn your head sideways and squint a little bit, it looks like Elvis's hair. In practical terms, what it means is it deals with the case where the nullable type is null. In this case, we simply want to return a response entity of HTTP status code not found. Now, because this is a normal function and not a lambda, we do actually need that return keyword. And just like that, we have our read one author endpoint implemented. Let's do a brief recap of this one because there's a few new concepts in here. The first thing that we do is declare this path with this particular notation, which allows us to extract the ID out to this argument by using the path variable annotation. So we now have the ID of the author that we want to get from the database. So we pass that to our author services get function, which returns for us a nullable author entity. We're then able, using this safe call operator, to convert that to a nullable author DTO by using our Kotlin extension function there. So now that we have a nullable author DTO, we want to do one of two things. When it's present, we want to return HTTP 200 and the author DTO as the body. In the case that it's null, we simply want to return a HTTP 404. And we can do that with a combination of the safe call, let's function, and Elvis operator. In the case the author exists, we get a response entity, author DTO as the body, HTTP 200. And in the case that the author doesn't exist, we get ourselves a response entity with a HTTP 404 not found and an empty response body. So let's see if our new endpoint works. Before we restart our backend application, let's go over to our browser and take a look at our front end application. So here we are on our list authors page, which is this one here. And I'm just going to click on the first author that we have here, which is Margaret. And we can see that we get a 404 not found. So if we look at the network tab here, we can see that we have our call to v1 authors passing in the ID of 1, and we're getting ourselves a 404 not found simply because that endpoint hasn't been implemented yet. So we go back to the list authors page here, flip back to our backend application. Let's restart it, go back to our front end application. Now, if we click on Margaret, we can see that the call returns a HTTP 200. And if we take a look at the response body, we have Margaret's information looked up from the database there. You can see there we've got Margaret's image, the description of Margaret. We haven't yet implemented the books endpoint, so this looks like to be working absolutely fine. If we go back to the list authors page again, maybe we'll click on Penelope here. We can see again, a different ID passed in this time. And the response, of course, is for Penelope here, Penelope's description and an image of Penelope. So it looks like our find one author endpoint is working absolutely fine, but you know the drill by now. Let's prove it by writing some tests for it. So there's two obvious test cases for the read one author endpoint. There's a case when the author exists, the HTTP 200 one, and the case when the author doesn't exist, the HTTP 404 one. So let's start with the test case for the HTTP 404. So here we are in our IDE. Let's go over to the author's controller test here. We're going to need a new test. We'll say test that get returns HTTP 404 when author not found in database. So let's start with our mock MVC configuration. So we say mock MVC.get because we're using the HTTP get verb. Now the URL is different from the one that we use for the read many authors endpoint in the fact that it has the author's ID on the end. Just like Java, we can use the plus symbol in order to concatenate, join together two different strings. So we could go author's base URL plus another string, which will be /, and then the ID of the author, which could be anything because it's not going to exist. But this isn't the preferred way of joining a string together in Kotlin. Instead, we should use a string template, and that looks a little bit like this. So we've declared the string using double quotes here, but we can pass in variables to this string by using the $ annotation. We can also use the $brace annotation if we so choose. What we have here is the URL that we want to use for the find one author with an ID of 999, which of course doesn't exist. Our REST API is still dealing with JSON, so we'll still specify those headers, and then we'll expect, well, in this case, we would expect a HTTP 404, but because we like to see that failing test, we'll say is okay, HTTP 200, which should definitely give us a failing test. Now, before we run this, we'll set up the mock K expectations. So we'll say every time our author service get function is called, and we can either specify the particular ID that we care about, or we can just say any. We'll say any in this case, because it doesn't really matter about the particular ID. So anytime author service.get is called, we'll answer with, well, for this case, we'll answer with a null. We simply just want a null to be returned. So if we run this test, we should get a failing test because our API is returning a HTTP 404. We've got an expectation here for HTTP 200. Okay, there's our red test. Let's take a look at it. So first thing to note, there's the string that came from our string template. And there we go. So our expectation was for a 200 in order to get a failing test, and we're getting a 404, which is actually what we expect. So we're going to say is not found. Run this once more, and we should get a passing test. Very good. So that is the test case where a HTTP 404 should be returned. What about when a HTTP 200 is to be returned? Well, let's do a new test, and we'll call this one test that get returns HTTP 200 and author DTO when author found. Actually, to be consistent, we'll just say and author when author found. So this is going to be almost identical to the test that we have up here. But of course, instead of a null being returned, we'll have an author entity returned from that get function call, which we can get with test author entity. And let's give that the ID of 999. So status is not found is going to give us our failing test. But I would also like for this test to assert on the JSON object as well. So I'm going to borrow this from up here and paste it down here. So we use these assertions in our read many authors test, which is why we have this square brackets in 0 in there, because we want the first element in the list. Now, if we were to remove those, this should now work for the JSON object that's going to be returned in our response body. Of course, we will need to change the ID from 1 to 999 because that's the one that we specified here and here. So if we run this, we should get our failing test because we're getting a HTTP 200 returned, and we set up an expectation for a HTTP 404. Okay, there's our red test. Let's see why it's failing. Expected 404 got 200, and we can see the response body that's being returned there, including the ID of 999. And it's of course a JSON object, not an array. So if we now change this to is okay and rerun our test, we have a valid passing test. So now let's move on to our service layer. So if we go down to the author service impl test, we'll write a new test for the case where null is returned. And we'll say test that get returns null when author not present in the database. So again, this is an integration test that uses that H2 in-memory database. So if we don't create an author in the database, there won't be one to return. So we're going to say val result equals under test dot, and then we'll pass in an ID that doesn't exist. So we're expecting this to be null. So we'll say assert that result, and to get our failing test, we'll say is not null, and the test is as simple as that. And this should give us a failing test. Let's run it. Okay, we have a failing test. Let's see why. Expecting actual to not be null, but of course it is null. So we're going to say is null, which is the case that we would expect. So if we're calling .get with an ID of an author that just does not exist in the database, we want a null returned, which is this case right here. So if we run this, we should get a passing test. Looking good. Now for the case when an author does exist in the database. So we'll have a new test, and we'll call this one test that get returns author when the author is present in the database. So it's going to be very similar to our previous test, but of course we're going to create an author in the database now. So we'll call our author repository .save, and we'll pass in an author entity, which we can create with our test functions. And we'll not provide an ID because our database will provide one for us. So we'll say val saved author, and now we have a reference to the author that's saved in the database. So now we'll borrow this here. But rather than the ID of 999, we'll simply use the ID of our saved author. which you can see we've got a red squiggle because the ID is a nullable type. We know the ID is definitely going to be there, and because we're in a test, we're going to use the bang bang annotation. And is null should give us a failing test because we should definitely expect this result to be equal to the saved author here. So if we run this test, we should get a failing test now. Expected null, but we got an author entity back. Perfect. So if we now say is equal to, passing in the saved author. So if we click on play, we should expect this to pass. Looking good. So we now have a test case when the author is not present in the database and when it is present in the database. Before we move on, let's just run all of our tests to make sure we're in a good state. So that wraps it up for our read one author endpoint. Let's now move on to our full update author endpoint. Full update endpoints use the HTTP verb put, and the URL structure is the same as the find one endpoint. We have the ID specified in the URL. When the specified ID matches one in the database, then that author is updated with the information provided in the request body. If the ID doesn't match an author in the database, then you get a HTTP 404 returned and nothing gets updated. Full update endpoints are called full update endpoints because they completely replace whatever is in the database already. As a result of this, a full representation of our author must be provided in the request body. Now I'll let you into a little secret. The save function that's exposed by our author repository already has the ability to create and update. Knowing that, there's a couple of different ways we can approach things now. I'm going to choose to have two separate functions in our author service. One to create an author and another to update an author. Now, if you try and create an author that already exists, we're going to throw an exception. And if you try and update an author that doesn't exist, you will get an exception. So before we implement our update method, we should see to the existing create endpoint and alter that in order to throw and handle exceptions. So let's start in our service layer. So if we go to author service import here, we have our save function. So we're going to rename this by going refactor rename, and we're going to rename base function, and we're going to call this create. So the save function, as I mentioned before, is exposed by the CRUD repository. So we haven't implemented that. That's part of Spring Data JPA. So the way that it works is if we have an ID set on our entity, then it's going to update that entity in the database. So we're going to update our create function to check if author entity has an ID provided. If it does, we're going to throw that exception because we only create new entities without IDs in this function. And the way that we're going to do that is by using require. So the require function is in the Kotlin standard library, and it's an example of a precondition. So if we look here, we've got an expression that evaluates to either true or false. Author entity ID is null. In the case that it evaluates to true, nothing will happen. However, in the case that it evaluates to false, then our require function is going to throw an illegal argument exception. Now there's a whole bunch of functions just like require, such as require not null, which throws an illegal argument exception if it finds null. And there's also the check functions, which throw illegal state exceptions if their preconditions aren't met. So in Java, an illegal argument exception is an example of an unchecked exception. Unchecked exception does not need to be declared as thrown in the method signature. However, if you have a checked exception, then you do need to declare it in the method signature in Java. Here's the thing, in Kotlin, every exception is the equivalent to an unchecked exception in Java. Or put another way, you never need to declare an exception as being thrown in your function signature in Kotlin. So now let's implement a full update function. So we go back to the author service here, we'll declare a new function, and I'm going to call this one full update. Now full update is going to require two arguments. The first one is going to be the ID of the entity that it's looking to update, in this case an author entity. The second argument is going to be the author entity, which is the data that's going to replace whatever's in the database. And we'll have this function return the updated author entity. So if we now go down to the implementation, implement the member, and now we can get to implementing the full update function. So we've decided that our full update function will only update an existing author entity in the database. So we're going to have to check if an author entity already exists. If it doesn't exist, then we're going to consider that an illegal state. So we're going to use that check function that we mentioned earlier, and we're going to call our author repository, and we're going to use the function exists by ID, passing in the ID of the author that we are looking to update. So if we find that the author doesn't exist, exists by ID will evaluate to false, and we will get an illegal state exception thrown. Now we run the risk of the ID argument to our full update function being different from the ID property on the author entity. So just to make sure that they are going to be the same, we will say author entity dot copy, specifying ID is equal to ID. And we'll assign this to a value called normalized author. So if we take a look at our author entity once more, we'll note that ID is a val, it's immutable. So we can't reassign, we can't update the value in our ID property. So what we have to do here to make sure that the ID in our author entity matches the ID that's passed into our full update argument is we need to copy author entity, making sure that the ID property is equal to the ID property passed in here. The copy function is a function we get for free whenever we declare a data class in Kotlin. So we now have our normalized author. We're going to return author repository dot save with the normalized author. So in summary then, we are checking that the author exists in the database using its ID. We're then making sure that the author entity that's passed in has the same ID as the ID value that's passed in. We're then making sure that the author entity's ID matches the one passed into our full update function. And then we're saving the author entity in the database, essentially replacing whatever was there before with that same ID. However, this function isn't complete. It is missing something. Let me ask you this. We do a check here to see if the author exists, and then down here, we do the save. But what happens if at this point here, some other process deletes the author in the database? Well, we find ourselves with an invalid state because this function should only update an author that exists in the database. In order to make sure that never happens, we're going to add an annotation to this function at transactional. So we typically use the at transactional annotation in our service layer when we're making multiple calls to the persistence layer in the same function. Without this function, it's entirely possible that some change can happen in our database between our first call to the persistence layer and our next call to the persistence layer, which of course we want to avoid because that could lead to an invalid state. By adding the at transactional annotation to our function, we make sure that it happens atomically. That's to say, while this function is running, no other changes will take place in the database up until the point this function completes. If there is an exception thrown at any point during this function, then the transaction will roll back, essentially putting the database in the state that it was before this function was run. So now that we have our create function and full update function in our service, let's update our controller. So we go to author's controller up here. So let's deal with our create author endpoint first. So we now know that this create function can return an illegal argument exception if the author that's passed in has an ID. So we'll want to handle that exception if it ever takes place and then return the appropriate status code, which in this case is a HTTP 400 bad request. So handling an exception in Kotlin is very similar to Java. So we're going to use the try catch. So we'll place this within the try block there. And for catch, we'll say EX for exception, and then that will be an illegal argument exception. And in the case that we do have that illegal argument exception, we are going to return a response entity with HTTP status bad request. So that's the create author endpoint handled. Let's implement the full update endpoint. So as we mentioned before, we're going to use the put HTTP verb in this case. Path is going to be the same as our read one author endpoint. We'll call this function full update author, and we're going to declare a path variable of ID, assigning that to the variable which we'll call ID of type long. Now we want to get hold of the author DTO that's being sent in the request body. So we're going to say request body author DTO of type author DTO. And now we want to declare the return type, which is going to be response entity of type author DTO. We want to use a response entity so we can control the HTTP status code of responses in the case that we get an exception. So now for implementing our function, let's open up a try because we know we can potentially get an exception from our service layer. And we'll say author service dot full update, passing in the ID and the author DTO, which will convert to an author entity. And this will be our updated author. And in the case that everything went absolutely fine, we will return a response entity, which will be the updated author, which will convert to an author DTO, and the HTTP status code of OK. However, in the case that we did get that illegal state exception, we should declare that as being caught here. We'll want to handle that. So we want to return a response entity with the HTTP status of bad request. Now here's a fun fact about the try catch. This is actually a lambda, and that means the last line in the lambda is returned by default. So we can actually remove these return keywords and make our code a little bit more concise. Of course, we will need to return the try catch. Let's do the same up here. So that's our create endpoint updated and our update endpoint created. Now let's go ahead and test this in our front end. So I'm not going to restart my application just yet, but I am going to open up the front end in our browser. So we see the full update endpoint working over in our admin panel here. If we choose an author, let's say Margaret here. So in this form is all of Margaret's information. So if we were to update this and submit it, this will hit our full update endpoint for authors. So if we say that Margaret wasn't actually 40 years of age, she was only 39, and then click on update author, we can see we get a 405 down here, but we have a HTTP put being made to authors with the ID of 1, but the 405 of course is because we haven't restarted our application. So if we go back to our backend and restart our application and then head back to our front end, so we've still got that new value in there. So if you now hit the update author button, so there's our full update request and we've got a HTTP 200 OK, so it looks to have been successful. Let's take a look at the payload that's sent. We can see that age 39 is being sent, and in the response, we can see that age 39 is being returned. If we were to go to our list authors page, go down to Margaret here, we can see that age 39 is now Margaret's new age. So it looks like our author full update endpoint is working fine, but let's get to testing it. So let's start by adding a test for our create endpoint for when that exception is thrown. So here we are in our authors controller test class. Let's just scroll up to where the create tests are. Looking good. And let's add a new one here. We'll say at test from test. We'll say test that create author returns HTTP 400 when illegal argument exception is thrown. So we already have a class-wide mock K expectation set up in this before each. So every time create is called in our author service, it will return the first arg. Now we're going to override it in this test. So we're going to say every author service dot create and then any. Now rather than answers, we're going to say throws and we'll create a new illegal argument exception there. Note the parentheses because we're constructing it, creating a new one. So with that exception set up, we can then basically do the same create as we've done before. Now this of course is for the success case is created, which should give us our failing test. So if we go ahead and run this now, we've got our failing test. Let's make sure it's failing for the right reasons. Yes, I expected a 201, but it got a 400. Great, so we can update this to is bad request, rerun it again, and we should get a passing test. Looking good, that's a valid passing test. So let's now do the same in our service layer for that create function. So we'll go to the author service import test here. Let's scroll up to where the create function is tested. Here we are. And let's create a new test here. And we'll call this test that an author with an ID throws an illegal argument exception. So the way that we assert that an exception is thrown is with assert throws. And we'll declare the type as an illegal argument exception. And we'll open up some braces. And now we'll write the code which would cause this exception. In this case, we'll say a variable existing author, and then we'll create an author entity with an ID. And now when we call undertest.create, we would expect an exception to be thrown. However, I want to see a failing test first, so I'm going to say an illegal state exception. Of course, create throws an illegal argument exception. Let's run this to get our failing test. Let's check. Yep, expected an illegal state exception, but it got an illegal argument exception. So if we now change that to be an illegal argument exception and run our test, we should get a valid passing test. Looking good. So let's now write the controller test for our full update, our success case. So let's go to our author's controller test here. Let's scroll down, and then we're going to create a new test, and we'll call this one test that full update author returns HTTP 200 and updated author on successful call. So we need to set up an expectation in mock K for that full update call. So we'll say every author service dot full update, and we'll say with any ID and any author entity. We can be more specific if we so choose. Answers. In this case, with the second argument, we'll simply return the author entity that's passed in, pretending that it's the updated author entity. And now we'll do our mock MVC. So we'll say mock MVC dot put, and the URL is going to be the same as our get one author endpoint. So let's borrow that from there. In fact, if we borrow this as well, because we're still dealing with a JSON REST API here. However, our full update endpoint will have a author DTO in the request body. So we say content equals, and then we'll say test author DTOA, and we'll make sure that the ID matches up against the one that we specified in the URL. Now, if we take a look up here at our get one author endpoint, this assertion makes sure that we get a HTTP 200 response code, and it also makes sure that the JSON object in the response body matches our expectations for an author. So if we copy this and put it here, the tests are actually identical from this point forward. However, we want a failing test. So we're going to say is bad request, expecting this test to fail because it should be a HTTP 200, because we have our expectations set up here for a full update to go successfully. We've put in the correct URL. We provided a author DTO in our request body. And then of course, we're going to go ahead and assert that the response is what we expect it to be. So let's run this test. Okay, we have a failure. Let's see why. So it looks like the expectation for is bad request passed, whereas this one failed. That's not what we're expecting at all. And looking at this, it should be obvious why. The content here, we're passing an object, whereas we should be passing JSON. So if we now call the object mapper, right value is string, passing in that object, let's see what we get if we rerun our test. Okay, failing test, let's see why. Okay, expected a 400, but got a 200. Great, so if we now change that to is okay and rerun the test, we should get a valid passing test. Perfect, so that's now passing. So just like our create endpoint, let's now set up the test case for when that exception is thrown. So we'll create a new test here, and we'll say at test, fun, test that, full update. In fact, we said full update author, let's keep it consistent. Returns HTTP 400 on illegal state exception. Okay, so if we now compare it to the successful case, in fact, we're just going to borrow this for this test too. The expectation is going to be quite different. So rather than answers, we're going to say throws, and we're going to say illegal state exception. Of course, there's going to be no content, so we can remove these assertions. And we'll leave is okay in place because we're not expecting a HTTP 200. This should give us our failing test. Let's run this. Okay, let's see if it's failing for the right reasons. Expected a 200, it got a 400. So it looks like we can change this now to is bad request, and hopefully we should get a valid passing test. Looking good. So we now have a test case for our full update in our controller for both the successful case and the error case when we get an illegal state exception. So let's move on now to our service layer. So we're going to write two test cases here. The first one is going to test that the author is successfully updated, and the second one is going to test that an illegal state exception is thrown when the author does not exist in the database. So we're going to minimize that. So then we'll say test that full update successfully updates the author in the database. So for this test, we'll need an author in the database. So we'll create a test author entity, and then we'll say author repository.save, and then we'll save that test author entity in the database. And we'll assign this to a val, and we'll call this one existing author. As we'll probably need it a few times, we'll create a new val, and we'll call this one existing author ID. And we'll say existing author.id, and this is going to be nullable, so we're going to use bang bang. And now we need to create an author entity which represents the updated author. And we'll call this one updated author. Create a new author entity because this information is going to be different from our test author entity A. We'll say the ID is going to be the existing author's ID because this is going to update that existing author. Now for the name. So this needs to be a different value. So rather than John Doe, we'll go with Don Joe. As for age, we need something different from 30. So let's go with 65. For some description, we'll go some other description. And for the image, we'll go with some other image.jpg. So that's then our updated author. So let's now call under test.fullUpdate, passing in the existing author ID, and then we'll pass in the updated author, so the new information that we'll use to update the existing author in the database. And let's assign that to a val called result. So let's assert that the result is equal to the updated author, because it should have all of the new information on it, and it is using the same ID from the previous one. So it should equal the updated author. And just to be extra sure, what we're going to do is say author repository.find by ID or null, and then we'll pass in the existing author ID there. We'll assign this to a val called retrieved author. First of all, we're going to assert that the retrieved author is not null. And then we're going to assert that the retrieved author is equal to the updated author. And we do this because it could be the case potentially that full update is just returning whatever we give it. We want to make sure when we query the database with a separate query that the information in the database does match the updated author. This one's a little tricky to get a decent failing test for, so I'm just going to say is null down here. And if we run this test, we should expect it to fail. Okay, we've got a failing test. Why is that? Because it's got the author entity back, And you can see this is the information for Don Joe. So the new information, age 65, some other image, some other description, but it's getting a null. So we change that back to what it was. It's not the best example of a failing test for validity, but if we run this, we should now get a passing test. Great stuff. There is our valid passing test. And now we need to deal with the test case when that illegal state exception is thrown. Luckily, this one is a lot simpler. So we'll say @test, and we'll call this one test that, fill update, author, returns, throws, illegal state exception when author does not exist in the database. So for this one, we're going to say assert throws. And of course, we want an illegal state exception, but let's say illegal argument exception to get our failing test. Rather than parentheses, let's use braces for our trailing lambda. Now, it would be good to reuse this data from Don Joe up here. So what I'm going to do is borrow this, and I'm going to go over to our test data util, and I'm going to create a new function. I'm going to call this one test author entity B. Exactly the same logic as above. We'll have an optional long, which will default to null, and it will return Don Joe, and then we'll pass in that ID there. So if we now go back, we can replace that with test author entity B now, passing in the existing author ID. Let's run that to make sure that it passes. Looking good. So if we now go down here, we'll say updated author, test author entity B, and we'll declare another val here, and we'll say existing, in fact, we'll say non-existing author ID, and let's say it's 999. Now here's an interesting thing, because we've just assigned a number to a val here, if we hold down control and take a look at it, it defaults to an int. Now, much like Java, if we want this to be a long rather than an int, we'll place a capital L next to it. Now, if we control and hover over non-existing author ID, we can see it's now long. So we have a non-existing author ID, and we're going to place that in the ID there. Of course, it's to an author that doesn't exist, but it makes it obvious what this test is doing. And now we get to call undertest.fillUpdate, passing in the non-existing author ID and then the updated author information. And if all goes to plan, this should throw an illegal state exception. We're looking for an illegal argument exception. This should give us our failing test. Let's run it and see. Okay, there's our failing test. Let's see why. Expected an illegal argument exception, got an illegal state exception. So yeah, it looks like this is failing for the right reasons. Let's now change this to be an illegal state exception. That's what our check function is throwing in our business logic. So if we run this once more, see it's passing absolutely fine. So before we move on, let's run all of the tests in the project to make sure they're all running fine and in a good state. Looking good. So that's a wrap for our full update author endpoint. Let's now move on to our partial author update endpoint. Our partial author update endpoint is very similar to our full author update endpoint. The URLs are the same. We're still passing that ID in the URL. However, the HTTP verb is different. Rather than put, which is what we use in the case of the full update, we will be using patch. So similarly to the full update endpoint, we provide an ID in the URL. If the author exists, which matches that ID, then we get that author updated and returned with a HTTP status 200. But if we find that the ID in the URL does not match an author in the database, the author doesn't exist, then the response is a HTTP status 404. So let's go over to our IDE and get this implemented. So we're in our authors controller class here, and we're going to declare a new annotation, and this one's going to be patch mapping. The path is going to be the same as what we have for our full update. Now we'll declare a function and we'll call this one partial update author. And now for the arguments. So we are expecting that path variable of ID long. So we'll declare that here. And we are expecting a request body as well. So let's copy this and let's put this here. And the response type is going to be a response entity, so we can control that status code. And then it's going to be an author DTO. Now, the way that a partial update endpoint differs from a full update endpoint is that you don't need to provide the full representation of the author in order for it to update it. For example, if we just want to update the author's name, that's the only attribute that we'll provide in the JSON body in our request. With that in mind, let's take a look at the author DTO. So in the author DTO, the only nullable type is ID. So that means name, age, description, and image all need to be provided because they are non-nullable. This doesn't really fit with the idea of a partial update, because in a partial update, all of these properties would have to be nullable. So we have a choice to make now. Do we go ahead and make all of these properties nullable in author DTO, or do we create a new DTO, a separate DTO, which is similar to author DTO, but with all nullable properties? So in order to model the data as accurately as possible, I'm going to go with the second option. So let's go to our domain here, and I'm going to copy our author DTO, and we're going to call this one author update request. Click OK. Now, if we go into our author update request, it's a complete copy of our author DTO, but I'm going to make every single property here nullable. Now we'll go back to our controller, and rather than author DTO in the request body, we're going to expect an author update request. Now, it's still okay for the response type to be an author DTO because we are going to be responding with the representation that's in the database, and that will have all non-nullable fields because it got as far as being saved in the database. So we can return an author DTO. So let's now move on to our service layer. So let's go down to our author service, and we'll declare a new function now, and we're going to call this one partial update. And that's going to expect an ID type long, and now it's going to expect a representation of our author. However, we can't use author entity because it suffers from the same problem. If we look at author entity, the ID, that's nullable. The name isn't, the age isn't, description isn't, image isn't. So what do we do here? Do we use our author update request in here? So our author update request is intended to be a DTO. So that's to be used in the presentation layer and not in our service or persistence layers. So what do? Well, we need to create another domain object here and then map from our author update request DTO to the new object that we're going to create that has all nullable properties. Again, this might seem quite contrived, and this is where it tends to get a little bit grey. But if we're going completely by the book here, we don't want to blur the lines between our presentation layer and the rest of the application. We do want that separation. So for the sake of an additional class, I feel it's worth it. So before we move forward, let's make it explicit as to the relationship. So I'm going to rename this author update request to be author update request DTO. So there is no confusion in anybody's mind that that is a DTO for the presentation layer. Now we need to create an object that's to be used in our service layer. Now it's not strictly going to be an entity, so I don't feel right putting it in there. So what I'll do instead is I'm going to copy our author update request DTO, bearing in mind that our DTOs are the same as our entities at the moment. And I'm going to copy that into the domain package. And I'm going to call this one author update request. And it's this author update request, not the author update request DTO, that I'm now going to use in the author service. And this will return an author entity, just the representation of the updated author from the database. So with that in mind, let's now go down to the implementation, implement these members, and we'll go with partial update. So much like our full update function, our partial update function can only update an existing author in the database. This is going to have a slightly different approach to full update though. So rather than use author repository exists by ID, we're going to use author repository find by ID or null, passing in the ID. We're then going to assign that to a val called existing author. Now we're going to use the function check not null on existing author. Check not null will throw an illegal state exception if it finds existing author is null. So we will handle that a little bit later. Right, so we now have our author update request object here, and all of the properties in the author update request object are nullable. So we need to handle these because some might be null and some might have values. So we can go through them in a list. Let's now go back to the author update request and let's do a split screen. Let's minimize this. Okay, so we're not going to allow for updating the ID. That needs to remain constant. So we're dealing with author entities here. So the author entity, if we take a look, is using vals. The ID's a val, name's a val, age is a val, everything's a val in here. So how do we update the author entity using an object with all of these nullable properties? There are a few ways of doing this, but the way that I'd recommend that you do it is by using the copy function, which you get for free when you have a data class in Kotlin. So we will say existing author.copy. Now the ID needs to remain the same, so we're not going to specify this here. For name, we're going to say author update.name, which of course is a nullable string. And now we're going to use our Elvis operator. If author update.name is not nullable, use it. Otherwise, we're going to default to the existing author.name. And we're going to repeat this pattern for the remainder. So for age, author update.age, otherwise existing author.age. Description, author update.description, otherwise existing author.description. Image, author update.image, otherwise existing author.image. And we'll assign this to the val of updated author. So we've done name, age, description, and image using the author update in the first case. But if any of those values are null, then we'll fall back to the values of the existing author. So all that's left now is to call the author repository.save for the updated author, and we'll return the author entity. There we go. Now it's okay to miss off ID in this case because copy will basically default to whatever the existing author is if we haven't specified the property within of the arguments here. Now it looks like we're making multiple requests to the database in this function. So just like our full update, we're going to mark this with the transactional annotation. So what that means is if any exceptions are thrown within this function, then the state of the database is going to roll back to as if that function was never called. It's also the case that the multiple requests to the database that we're making, find by ID or null and save, are going to happen atomically. So that's our service layer implemented. Let's go back to our controller now. And it's a bit of a pattern so far. So we're going to say return try, because this could throw an illegal state exception. We'll open up our braces here and we'll say author service dot partial update. We can pass in the ID. However, for our author update, which we'll rename that to be author update request, we'll find that it's not quite the right type. So we need to do another Kotlin extension in order to map from our author update request DTO to our author update request. Fortunately, we only need to do one because we're only ever going one way. So let's go back to our extensions class. Create a new function in here. And this one's going from an author update request DTO. And we'll call this one to author update request. And this will create an author update request. And in fact, the properties are going to be the same as we have up here. There is a difference, however, from these functions. Name, not nullable. Name is nullable. And the same for age, description, and image when we're dealing with this author update request DTO. So we now have this function available to use. Let's go back to our controller. We can now call it. We'll assign this to the val of updated author. And now we can create a new response entity. So we now need to return the author DTO. So we'll say updated author dot to author DTO. And then we'll say the HTTP status of OK 200. Now for the error case. So we'll say catch. And this is going to be an exception, legal state exception. And how are we going to handle this? Well, in the same way that we've handled it before with a badge request, a HTTP 400. And just like that, we have our author partial update endpoint implemented. So before we restart our backend application, let's see what we've been doing so far and go over to the front end and see what it's like when this feature doesn't work. So to use the partial update endpoint, we're going to go into our admin panel. And there's a bit of a hidden feature in here. So we can use the full update endpoint by going to the update author form. If you want to use the partial update endpoint, let's just clear out the network panel. We can click on any of these in our table in order to update it. So for example, if we wanted to update Penelope's description, give that a click. We can update that description there. And then when we click on save, we can see a request is sent. It's a HTTP patch to the author's endpoint with the ID there. And you can see we're getting a HTTP 405 method not allowed because we haven't restarted our backend application yet. So let's go ahead and do that. Okay, that's restarted. So we go back to our front end, click on OK there, clear that down. And now let's click on save once more and send that patch request. Wonderful. So let's take a look. The patch request was sent. We're getting a HTTP 200 OK. Let's look at the payload. It contains the extra bit that we've added there, I'm updated. The response, we can see the ID remains the same, name's the same, age is the same. Description has I'm updated at the end. So if we now scroll down, because it was the last one updated, we can see here Penelope, I'm updated. If we now go to the authors list, find Penelope, we can see we updated Penelope's description. So it looks like our author partial update endpoint is working absolutely fine. Let's now write some tests for it. So we're going to test our author partial update endpoint. And let's start with a negative test case. So that test case when the illegal state exception is thrown. So let's open our author's controller test here and we'll declare a new test. And we'll call this one test that partial update author returns HTTP 400 on illegal state exception. So we'll set up our mock K expectation here. So every author service dot partial update. We don't really mind what the ID is or what the body that's passed in, because every time it's called, we want to throw an illegal state exception. And now for mock MVC. So we'll say mock MVC, we're using the HTTP patch verb. So we're going to go with patch. The URL is going to be the same as the one that we're using for our full update. So we're going to borrow that from up there. And in fact, we'll borrow this as well. because we're still dealing with that JSON REST API. And for our content, rather than a test author DTO, let's make sure that we're passing the right object. So we're going to use an author update request DTO. The ID will be 999. Name, let's go with John Doe. Age, let's go with 30. Again, the content of this object tends not to matter too much because it's always going to throw an illegal state exception, but let's just fill it in so it's complete. Description, some description, and the image, some image. Okay, and the expectations for this one is that the status is going to be HTTP 400. We want that failing test, so we're going to go with is okay. So if we run this test, let's see what we get. Okay, we've got a failing test. Let's see why. Expected 200, actual 400. So it looks like that's failing for the right reasons. We'll say is bad request, rerun our test. And we have a valid passing test. Very good. I think while we're here, let's extract this out into a test function. So we copy that, then we'll go to our test data util, and we're going to say fun test author update DTO A. Again, we'll have the same format that we had before with the nullable ID defaulting to null, and we'll return that author update request DTO, author update request DTO, using the ID that's passed in. For convention, let's just make sure that it's matching what we have here. John Doe, age 30, some description, author image.jpg to make sure that matches. Great. So we now have this to use. Let's go back and we'll pass in the ID of 999. Very good. Let's run that again to make sure it's still passing. Very good. So let's now create a new test. And this will be for the success case. So we're going to say fun, test that, partial update, updates, author. Test that, partial update, returns HTTP 200 and updated author. So first, the mock K expectation. So every time author service dot partial update, and we'll say any ID, and we'll go with any author update request. And we're going to say it answers. Now our partial update may expect an author update request as an argument, but it returns an author entity. Now by convention, we've made it so that our test author entity A matches our test author update request A. So we're going to say test author entity A, and we'll make the ID 999. The request is going to be absolutely the same in this one as it was for our negative test case. So let's borrow that mock MVC request, place that there. There's the ID of 999. We're using patch, looking good. Okay, so we're not expecting a bad request, but this will give us a failing test, so we'll keep it in there for the moment. Now, on a successful request, we are expecting the updated author returned in the response body. So let's borrow the assertions from up above to make sure that the author is returned and its values are what we expect them to be. So I believe, yep, here they are. So we'll borrow this and we'll put that in there. Great. So let's go ahead and run this test, and we should expect a failing test. Yep, there's our failing test. Is it failing for the reasons we think it is, the status code? It is. Great. So if we now change that to be is okay and rerun our test, that goes green and we have a valid passing test. So that's it for our presentation layer. Let's now move on to testing our service layer. So we'll go over to the author service import test here. So there is a few test cases here, and we'll start with the negative test, which is we try and update an author that doesn't exist in the database. So we'll say at test, say fun, test that, partial update, author throws a legal state exception when author does not exist in the database. Now you might notice, but the name of this test function is pretty similar to the one above it. Now the one above it, of course, tests the full update. We're testing the partial update, but we should be able to borrow the implementation of this test method. However, we'll change full update for partial update, and then we'd want to pass in, of course, an author update request. We don't yet have a test function to create one of those for us. So if we go over to our test class here, we'll copy this here, and then rather than a DTO being returned, we'll return the object that's used in our service layer. Of course, for the time being, all the properties are the same, and by convention, we're keeping the values the same. So we'll swap that out here. Again, the actual values, the actual property values on this object make no difference because the object doesn't exist in order for us to update it. So we have a non-existing ID here. We are sending a update request. Let's rename that to be update request. And we're calling our partial update. So we do expect this to throw an illegal state exception, but we're going to change that to be an illegal argument exception because we want to see a failing test. Let's see if we get it. There's our failing test. Let's see if it's failing for the right reason. Yep, illegal argument exception, illegal state exception. So we'll change that to be illegal state exception. Run once more, and we have a valid passing test. Now let's move on to the test case when we pass in all nulls, in which case our partial update function shouldn't update anything at all. So we now go at test, fun, test that. Partial update author does not update author when all values are null. So for this one, we're going to need an existing author in the database. So we've seen that done once already. So we'll borrow it from up here. So we now have a test author entity A saved in the database, and we've saved it to a val here of existing author, so this has an ID on it. So now we'll call our partial update function. So under test.partial update, we'll say existing author.id. This of course is a nullable type, so we'll do bang bang. And now we'll need to pass in an author update request. So we'll create here an author update request. And now we'll need to provide each of the properties and assign it null. Now, wouldn't it be nice if it just defaulted to null? Well, we can make it that way. So let's go over to our author update request and we'll simply say equals null after each of these. Now this will make our testing a lot easier because we'll only then have to provide the properties that we're trying to update. Great, so just like that, this is an author update request of all of the properties automatically defaulting to null. So in which case, it shouldn't update anything at all. So let's assign that to a val called updated author. And we're going to assert that the updated author is equal to the existing author. We want to make sure that it hasn't been updated at all. So we're going to change this to is not equal to in order to get our failing test. So we make sure it's failing for the right reason. Yep, everything looks to be the same to me. So we're going to say is equal to, rerun the test. Looking good, that's passing for all the right reasons. Now we could go ahead and extend this test in order to retrieve from the database, but I'm feeling pretty confident that's working as expected. So we're going to move on. We do have some other test cases we need to deal with here. So the thing with a partial update function is that we can update each of the properties and we can update combinations of the properties. So we really must choose to what degree we test this function. So we're going to write a test to make sure that each of the properties can be updated, but we're not going to go and test different combinations of properties because I feel like there's less value in demonstrating that. And I'm going to show you a way where we can easily create these tests for these different properties. So let's create our first test. This is going to require the most effort and everything after this will be easier. So we'll say at test, fun, test that, partial update author, updates author name. So for this, we're going to need an author in the database. So we'll borrow this. We now have an author in the database. And now we'll need to update the author. So we're going to have the same here, but the author update request, we're going to say name equals, and we'll say new name. And while we're here, let's assign new name to a variable. And we'll just say this is called new name. So in theory, our updated author should have a new name value on there. As creating the other test after this will be easier, we should go the whole hog on this one. So we're also going to retrieve the test. So now we want to assert that the updated author is what we expect it to be. So let's say val expected equals, and what would we expect it to be? Well, we expect it to be the existing author, but if we copy that, the name should be the new name. That's exactly what we'd expect to be returned from partial update. So we say assert that the updated author is equal to expected. And because we're going to reuse a lot of this for our other tests, let's go one step further and retrieve the author from the database and assert on that as well. So we'll say author repository dot find by ID or null. And we'll need to get the existing author's ID. So let's assign this up here where we're using it to a variable. And we'll say author's ID. No, we'll say existing author's ID. And we can place it in here. I'm going to assign this to a val called retrieved author. So we'll assert that the retrieved author is not null because we'd certainly expect that to exist. And now we're going to assert that the retrieved author is equal to the expected here. I'm going to change this last assert to is not equal to because we want to see that failing test. So let's run this and see what we get. Okay, there's our failing test. Let's see if it's failing for the right reasons. So it's expecting this not to be equal to this, and it looks like they're identical. So it looks like our test is failing for the right reasons. So let's change that is not equal to is equal to. Rerun our test, and it looks like we have a valid passing test. So let's go about repurposing this in such a way that we can then reuse this logic in order to easily write our partial update tests. So let's get a bit more room. Let's minimize that. So I'm going to create here a private function. So a function that's only visible within this file. And I'm going to call this one assert that the author partial update is updated. And this function is going to take 3 arguments. The first one is going to be the existing author, and this is going to be an author entity. The second one is going to be the expected author, which again is going to be an author entity. This is going to represent the author after it's updated in the database. And the third one is going to be the author update. So the author update request. And I'm not going to declare a return type for this function. So we're going to borrow this logic from up here. We'll paste it down here. And now we'll go about repurposing it. So we're already using the name here existing author. So let's change that to be saved existing author. And now we can pass in existing author to that save function. And now we'll need to extract the expected author logic from this. So what we'll do is we'll say expected author.copy. And because the ID tends to be different, we'll say ID equals existing author's ID. Now this function should work for all properties, so we don't need new name in there. and we'll pass in instead the author update request. Let's update that to be author update request. Great. So while we're here, let's just put on a few comments. So we'll save an existing author. We'll do that there. We then update the author. And we update the author using the author update request. We then set up the expected author. Because the ID is always going to be different depending on what the sequence in the database gives us, we'll assign it to whatever the expected author is here. And then we do some assertions. We make sure that the updated author is what we expect it to be. We then retrieve the author from the database using the existing author's ID, and we assert that the retrieved author is not null, and the retrieved author is exactly what we expect it to be. So in this way, we can use this private function in order to easily write our tests for our different property updates. So in this case, let's assign our author update request to a variable called author update request. From here on down, let's delete all of this. And then we can use our new function. So we're passing into this the existing author. Well, we don't actually need to say that in the database. That's handled for us. Let's remove that one. And we'll pass in, using the names, I think, the existing author will be this one here. Maybe existing author is a bit of a misnomer because it doesn't yet exist in the database until it's saved by this function, but we'll keep that for the moment. And now we need to pass in the expected author. Perhaps the easiest way to do this is assign our existing author to its variable called existing author, and then we can easily create an expected author by doing existing author dot copy and then using the name of new name. And to keep things organized, let's put that there. So we can then go expected author and the author update request equals the author update request. So if we now rerun this and make sure it still passes, it looks like it passes absolutely fine, but to be on the safe side, let's just change our author update request to do a different name entirely, expecting a failing test. Looking good. Wonderful stuff. So with that done then, let's open up our author entity here and let's place that on a split down. And let's now go back to our tests, expand that. Very good. So we're not going to do ID. We've already done name. Let's now do age. So we're going to take this function here, our test function for name, and then we'll copy it. And we're going to say test that partial update author updates author age. And we'll say there's new age. And the new age originally was 30. We'll say it's now 50. We now need to declare the age on the expected author as 50. The new age, and for the author update request, it'll pass in the age, and to get a failing test, we'll go 55. This will remain the same. So let's see that failing test where the ages don't match. Great, 50, 55. So we now put this to new age. We should expect this to pass. Great, so we've done age. Let's move on to description. Test that partial update author update author description. So test author entity A, it's some description. So we need to use a different one. So we say new description, and we say a new description, existing author. Description equals description. Author update request. Description equals, to get our failing test. So let's run this now. Looking good. Descriptions don't match. So if we now change that to be new description, rerun our test, we should expect a valid passing test. Very good. That's now passing. And then we just have image to do now. Test that partial update author update author image. Let's rename this to be new image. Okay, so the existing author has author image.jpg. We've got new image.jpg, expected author, image, new image. Description now becomes image, new image. Of course, in the update request, we want a failing test. Let's rerun this and see what we get. Great, we have a failing test. Let's make sure it's failing for the right reason. And the images don't match. Very good. So we now change this to be new image, rerun our test. Very good. So we could keep on going and we can do things like testing the ID can't be updated and testing different combinations of all of the different things that can be updated, age, description, image, all of them. But I think we get the gist with what we've done here. So I think there's more value in us wrapping up on our partial update and moving on to the last endpoint for our authors, which is our delete author endpoint. So now for our delete author endpoint. This should be pretty refreshing after the partial update endpoint because it's a lot more straightforward. The author's delete endpoint uses the HTTP delete verb and the author's URL specifying the ID, the same one that we were using for partial update and full update. Regardless of if the ID provided in the URL matches an author that exists or doesn't exist, we're going to return a HTTP 204 no content. The reason being is that the whole purpose of the endpoint is to delete the author. By the end of the call, I do not want the author that matches that ID to exist. Therefore, if the author doesn't exist in the first place, we've just taken a shortcut to that author not existing. So we'll go with that HTTP 204 in all cases. Of course, different developers have different approaches to this one, but we'll take this one in this case. So here we are in our authors controller. So we're going to start with the delete mapping annotation. And the path is going to be the same as what we've been using for our updates. We'll create a function and we'll call this one delete author. Now inside of our parentheses, we're going to want to use this path variable so we can access the ID that's in the URL. That's the only thing we'll need to put in there though. And for our return type, we're going to say response entity. Now we're not actually looking to return a particular object here. We're not looking to return an author DTO. We're just looking to return that HTTP 204. What type do we pass into the response entity here? Well, the type is unit. So in Kotlin, the type of unit is the absence of a type, kind of like void in Java. So we're going to use unit. So we now need to implement our function, and for that we're going to need a new function in our service layer. So let's go over to our author service here, and we're going to declare a new function, and we're simply going to call this one delete, and it takes an ID of type long, and it doesn't return anything, which is the equivalent of returning unit like that. But you can see the IDE grays it out because it's strictly not needed. So we're just going to go with that delete function declaration like that. So let's go down to our implementation, and then we'll implement the members, delete. And now we'll implement our delete function. The author repository already has exactly what we need. So we're going to say author repository delete by ID, passing in the ID. And that's all the implementation we need to do. So let's go back to our controller and we'll call our author service.delete, passing in the ID. And then we're going to return a response entity, HTTP status of no content, which is HTTP 204. And that's our delete author endpoint implemented. So we'll do as we've done before. Before we restart our backend application, let's go to our front end application, see what happens when we try and delete an author without this endpoint in play, and then restart our backend application and see the delete endpoint working. So let's go to our front end application. So for this one, we're going to go to our admin panel. So we're in our admin panel, and we've got these big red delete buttons next to each of our authors. So if we select an author at random here, Olivia Sinclair's at the top. So if we click on delete, we can see that we've got a request made, HTTP delete method to the URL for authors with the ID specified. Of course, we're getting a 405 because we haven't restarted our backend application yet. So let's go ahead and do that. That's our backend application restarted. So let's go back now to our front end application. So what I'm going to do is I'm going to copy Olivia Sinclair's name. Let's do a find in our browser, one of two, Olivia Sinclair, Olivia Sinclair. If we click on the delete button now, you can see here's the delete request made to the author's URL with the ID of 3. We've got a 204 no content. So it looks like it was a success. So if we go up here and then just try doing a search for Olivia Sinclair, we can see that Olivia is no longer in this list. The author has been deleted. And there we have it, our delete author endpoint. Let's test it. So let's now write some tests for our delete author endpoint. So let's start with the controller here. So we'll go to our authors controller test, and we're going to write the test case for when the delete goes successfully. So we're going to go at test fun test that delete author returns HTTP 204 on successful delete. So we set up our mock K expectation first. So author service dot delete, and we'll say any long, so any answers with, well, nothing at all. But it is important that we keep that in there. Now we'll say mock MVC, and we're using the delete method. So we'll go with delete. And now we'll go with the URL. We'll borrow this one from up here because it's exactly the same URL. And in fact, let's borrow this here as well, because we are still using a JSON REST API. So that content type and accept is in there. And now for some expectations. So let's say the status is bad request. Of course, we're expecting a HTTP 204, but if we run this test, let's see if we got a failing test for the right reasons. Okay, there's our failing test. Let's see if it's failing for the right reason. Expected a 400, got a 204. So it looks like it's failing for the right reason. Let's say is no content, rerun that test. And now we have a valid passing test. Very good. Let's move on to our service layer. So we'll go to author service import test. So there's two test cases we should do here. One for when we try and delete an author that does exist in the database, and another when we try and delete an author that doesn't exist in the database. So we'll go with the one where the author does exist to begin with. So we'll go at test, fun, test that delete an existing author in the database. So for this, we'll need an author in the database. So we'll borrow that from up here. And now we'll call underTest.delete, passing in the existing author's ID using bang bang because we're in a test, that's okay. In fact, what we'll do is assign that to a value saying existing author's ID. So that's going to delete the author. So let's make sure the author doesn't exist after that. So we're going to use the author repository for that one. And we'll say exists by ID, passing in the existing author's ID. And what we'll do then is say assert that this value here, which will be true or false, is equal to, in fact, we'll just say is true because we want a failing test. So really we'll say exists by ID. Does this author exist in the database using this ID? It shouldn't do. We're saying is true because we want a failing test. Let's see. Okay, we have a failing test. Let's see why. True, false. Great. So if we change that to is false, of course, the author shouldn't exist in the database after we've deleted it. So let's run this test once more. There we go. We have a valid passing test. So let's now do the test case when the author doesn't exist in the database. We'll copy this to speed things along. Test that delete, deletes a non-existing author in the database. Of course, you can't strictly delete something that doesn't exist. So there's probably a better name for this one, but we know what we mean for the time being. So we don't need to save anything in the database. Instead, we're going to decide on an ID and say non-existing ID. Well, let's say that's 999 and that's a long. So we'll put that L after it. Now we're going to say underTest.delete non-existing ID. And then we're going to say exists by ID that, well, we want the failing test. So we're going to say is true. In summary then, pick an ID, any ID. We then attempt to delete the author with that ID. Of course, that author doesn't exist. We want to make sure that after we do so, the author doesn't exist. So that basically this is the case where we try and delete an author that doesn't exist in the database, but we've decided we still want that to go okay. So we're going to run this test. Okay, so it's failed. Let's take a look. Expected true, actual false. So if we say is false, because of course an author that doesn't exist, even after we delete it, shouldn't exist in the database. So let's run this test, expecting it to pass. Looking good, that's passed absolutely fine. So before we move on, let's make sure that all of the tests in our project run and pass absolutely fine. Okay, we've got some test failures. I wonder why that is. Test that list returns authors when no authors are present in the database. So we have here, test that list returns empty list when no authors are in the database. We're expecting an empty list, but there's authors in the database. How strange. And then over here, we're expecting an author. Oh, but wait, there's more authors in the database. So it looks like we have a case of test pollution. So before we wrap everything up on authors, let's deal with this. So just when we thought we were done with authors, it looks like we have some test pollution. So we should really have these tests passing before we wrap everything up. Luckily, there's an easy way to deal with it in Spring Boot. So if we take a look at our failing tests, we can see that all of the tests in authors controller tests are passing. We only have failing tests in the author service import test. So here we are in the author service import test. Why are we getting failing tests and how do we fix them? Well, it's to do with the @transactional annotation that we've placed in our service layer. So in order to get our test to pass, we need to add the @transactional annotation onto our test class here. And if we rerun these tests, we can see that everything passes absolutely fine. So with everything passing and our authors endpoints built, let's move on to the books endpoints. So we've got a fully functioning REST API for authors, but what about books? Our books create endpoint differs from the authors create endpoint in one very important way. When creating an author, we have the server generate the ID, but in the case of creating a book, we require the caller to specify it, which of course is the book's ISBN. So in the case of creating books, because we're specifying that ID in the URL, we're going to use the HTTP put verb, which is different from the post that we use for authors. So you might be wondering, we used the HTTP put verb for authors when we were doing a full update. And in fact, the URL that we have here looks very similar to the author's full update URL. And that's because we're combining both the full update and the create functionality for books in this single endpoint, which uses the HTTP put verb. So we're going to need a new controller to deal with our books. So let's head over to our IDE here and we'll create a new file in controllers. And we'll call this one books controller. And because we have a REST controller, let's add the REST controller annotation on top, just like we did with authors. Now we've seen a full update endpoint before. So we're going to go put mapping. And in the path here, we'll say v1, and then we'll pass in the ISBN. Let's define a function and call this one create full update. And we'll define a path variable here. And it will be ISBN to match the string here. And we'll call this one ISBN of type string. Of course, this endpoint is going to require more than just the ISBN in the path. We're going to need a representation of our book to either create or do a full update on. So we're going to need to use our book DTO class. Remember, we have that from earlier and it looks a little bit like this. So the ISBN, title, description, image, and we represent the author using the author DTO. So we could just go ahead and use this object as is, but I think we should tweak it first, and it's to do with how we represent our author in our book DTO. Of course, we already have dedicated endpoints for managing our author, so we're not going to make any changes to the author by using the book's endpoints. So do we really need an author DTO? Because in the case of the create and the update, we're simply using this information to assign the book to the author, put in the database which author wrote this book. So what we really need is the author's numeric ID. So we have a few options here. So the first option is we update our book DTO class here to just have the author's ID, which looks a little bit like this. Now this will carry the benefit that we just need to provide the ID in order to assign the book to the author. It'd just be a single field, and that's pretty much as simple as it gets. Now the downside with this one, assuming that the response is consistent with the request here, is you would just get the author ID and the response, which, unless you know all of the author's IDs off by heart, isn't very useful to you. You would then need to do another request to the API to get information for that author. So option number 2 is you leave the book DTO class as is and use the author DTO to represent the author in this class. However, because we only need to provide the author's ID when we create or update a book, we would need to update or duplicate our author DTO class here to make name, age, description, and image nullable, because you're only going to need to provide that ID. And then there's the extra complication, which is, well, the ID is nullable in author DTO. So do we change that as well? Option number 3 is we would create a cut down version of our author, an author summary DTO. And that would have an ID, which is not nullable, so that would always need to be there. And we might provide some bare bones information that we might need, such as the author's name, which is sort of the bare minimum human readable information you would need in order to know which author is which. So we're going to go with option 3, and we're going to use this author summary DTO. So we'll go ahead and create that. So let's go to our DTOs package here, and we'll create a new Kotlin class file, and we'll call this one author summary DTO. This, of course, is going to be a data class, so we can remove these braces. And in our parentheses, we can define the properties that we want for our author summary DTO. So the first one, as mentioned, is going to be the ID, which is going to be a long, and we're going to make that one non-nullable, so it's always there. Then we'll define the author's name, and we'll make this a string, but we'll make this one optional, so you don't have to provide it on the request, but it might be there on the response. And then in order to make this work well with our front end, we're also going to provide the image reference here as well and make that optional. And that will be our author summary DTO. So we'll take this and we'll go back to our book DTO, and instead of an author DTO, we will use our author summary DTO. Well, this is our author summary DTO, so how are we going to use it? Well, we're going to follow this convention to say that a summary is a cut down version of the full representation. So the author summary is a cut down representation of the author, and the book summary would be a cut down version of the book. So it wouldn't have all of the fields provided. So it doesn't feel quite right to take the author summary and then put that onto the book DTO, because the book DTO is supposed to be the full representation. So what I'll do is I'm going to copy the book DTO here, and I'm going to call this one the book summary DTO. And in the book summary DTO, we're going to use our author summary DTO. And that keeps things nice and consistent. In the book summary DTO, we're using the author summary DTO. In the book DTO, we're using the author DTO. So it then stands to reason that we want to use our book summary DTO in our books controller here. So using the request body annotation there, we'll say our book is of type book summary DTO. So we can now get to writing the business logic for our books controller. And for that, we're going to need a books service. So we'll go to our services package here, and we're going to create a new Kotlin class /file. We'll call this one book service, and we'll make this one an interface. So we need to pass in some representation of our book to the create update function here. Now we can't use the book summary DTO because that's a DTO, and that's strictly for the presentation layer. And of course our service is in the service layer here. So we need to create a new representation of our book that we can use here. So the representation that we're about to create is going to be a one-to-one mapping, at least at the moment, to our author summary and book summary DTO. So let's take a look at those. So our author summary DTO, well, we can create an author summary, and we'll do that by copying this class. And because it's not strictly an entity, it won't have that entity annotation on top. It won't be used with Spring Data JPA. I'm going to put it in the domain package here, paste, and I'm going to remove the DTO suffix. So we just have ourselves an author summary. The ID is always going to be provided, and then we have a name and image, which are nullable strings. Now we can do the same for our book summary. So we're going to take a look at our book summary DTO here. We'll copy this class, and in our domain package, we'll paste it, and we'll remove the DTO suffix. Okay, so in our book summary, we're not going to use the author summary DTO. We are going to use the author summary. Again, we don't want any of those DTO, those presentation layer objects, making their way into the objects we're using in our service layer. So like that, we now have our book summary. So that's what we're going to use in our service. And we're going to declare a function, and we're going to call this one create and update. And this is going to take two arguments. The first one is going to be the ISBN type string that defines the book that we either want to create or update. And then it's going to pass in the book representation, which we know to be the book summary of type book summary. So now we can think about the return type. So the create update function does both creating and updating depending on whether or not the book already exists in the database with that provided ISBN. Ideally, we want to include that information in the response so the caller knows whether or not they've created a book or updated it. Now, one way of doing this is we could create a new object which contains the representation of the book that we've created or updated, which would be a book entity. And it would also include the information on whether or not it's been created or updated. Perhaps the simplest way of representing that would be with a Boolean, true for created and false for updated. And that would be a really good option, but I'd miss the opportunity to show you something quite particular about Kotlin, and that's the Kotlin pair. So the Kotlin pair is very similar to the tuple that you may have seen in different programming languages. It allows you to package up two bits of information as one thing. In this case, the book entity, and also the Boolean, which communicates whether or not it's been created or updated. So we would declare a pair like this. So we'd say pair, and then in our corner brackets here, we'll say book entity, because that will be the first piece of information returned. And then we will have a Boolean, which will be a simple true or false to communicate whether or not it's been created or updated. This is a little bit contrived, and actually using an object to represent this response would be much better, but we'll use the Kotlin pair in this case as it allows us to practice with it. So let's go ahead and implement our create update function, and then we can work our way back to using it in our controller. So we're going to need a class that implements our book service. So let's go to our impl package here. We'll go new Kotlin class file. This will be a class, and we'll call it book service impl, and this will be the default implementation of our book service. So we'll declare this as book service, so it implements book service. Okay, and now we've got a red squiggle because we haven't implemented our create update function. So if we click here, we can then implement our members, create update. There we go. And now we can get to implementing our create update function. So the first thing we want to do is make sure that the book summary representation that's passed in here has exactly the same ISBN as is passed in as an argument to this function. So we're going to do that by declaring a new value. We'll call this one normalized book, and we'll simply say book summary.copy, and we'll define the ISBN as the ISBN passed in to the create update function there. Now we can be sure that ISBN is always going to be the same. Now will be a useful time to see whether or not the book with that ISBN exists in the database. So for that, we're going to need some way of interacting with the database. So we're going to need to inject here our book repository. So let's define a primary constructor. We'll say val book repository of type book repository. There we go. We now have that to work with. So we'll say book repository. We'll say it exists by ID, and we'll pass in the ISBN. I want to assign this to a val, and we'll say is exists. So if the book exists, this will be true, and if it doesn't exist, this will be false. This would actually be the inverse for how we intend to use our Boolean, which says true if it's created and false if it's updated. So now that we've checked whether or not the book exists, we should do the same thing for the author here. So for that, we're going to need to use the author repository. So let's put this on a new line, and in our primary constructor, we'll define a val of author repository of type author repository. Then on author repository, we'll call find by ID or null, and then we'll pass in the normalized book dot author dot ID. And we can feel confident to chain these calls because we know that the author is always going to be provided because it's non-nullable, and the same thing for the ID here as well. So this is going to return for us an author or a null. So we'll assign this to a val called author. Now, it doesn't matter whether or not the book already exists in the database, but it does matter if the author exists in the database. So if the author doesn't exist, we're going to want to throw an exception here, because we should only create books in the database which reference an author. So we're going to use the function check not null, passing in the author here. So now we can be certain that the author is not null, or we'll have an illegal state exception to deal with. Now we have enough information to create our book entity and either save or update that in the database. But in order to do that, we need to convert our book summary to a book entity. Fortunately, we already have a convention for doing that. So let's head over to our extensions here, and we'll create ourselves a new function extension on our book summary, and we'll say to book entity. So we're going to define an argument to this function, and that's going to be our author of type author entity. Now we can create ourselves a book entity. So let's open up our book entity, and we'll do a split, and we'll split that down. And then we can go ahead and assign each of these variables. So the first one is going to be the ISBN. So we can go this ISBN, title, this.title, description, this.description, image, this.image, author entity, and that will be the author that we pass in there. So we can now use our to book entity on our book summary. So let's head back to our service. So we'll now say normalize book, and we'll say to book entity, and we'll pass in our author. Now here's something interesting. Our to book entity function declares an author entity, and this is a non-nullable type. So there's no question mark after this. However, you'll notice find by ID or null returns a nullable type. So we take a look at author here. It's got author entity with a question mark after it. That's a nullable type. So how are we able to pass in a nullable type when a non-nullable type is required? So the compiler actually allows us to pass in author, which originally is a nullable type, into a function requiring a non-nullable type because we've used that check not null. And that's an example of Kotlin's smart type checking. So we've got our book entity. What we're going to do with it? Well, let's say book repository, save, and we'll pass in that book entity, and we'll say val book. We already mentioned this once before, but our repositories are capable of both creating and updating. And now we can return our Kotlin pair. So we're going to say return, and the first argument we're going to pass in is our saved book, a book entity. And the second one is going to be true if it was created and false if it wasn't, which is going to be the inverse of our isExist. So we'll pass that in just like so. And now we have our create update function implemented. So before we move on from our service, let's make sure we've got the correct annotations on here. So we'll say at service. And because we're making multiple calls to the database in this function, we'll also put the at transactional annotation on top as well. There we go. So let's now go to our controller where we can call create update. So we'll get a reference to our book service to begin with. So we'll do that with our primary constructor. We'll say val of type book service. And we'll say book service dot create update, and that will take the ISBN and of course our book summary. We currently have here a book summary DTO, so we're going to need to convert one to the other. So let's go over to our extensions here, and we'll say fun. And we're calling this one on the book summary DTO. We'll say to, and we'll create ourselves a book summary. In fact, let's open that up, and we'll do a split down on this class. And now we'll populate the property. So we'll say ISBN equals this.ISBN, this.title, this.description, this.image, and then our author equals this.author. So we have ourselves here an author summary DTO, and of course our book summary requires an author summary. So we'll need to create ourselves a function for that. So say fun author summary DTO dot to author. Drag our author summary down here. So we can say ID equals this.ID, name equals this.name, and image equals this.image. And now in our book summary, we can say this.author to author summary. And we now have our two book summary functions to use. So we can now go in our controller, book.toBook summary. Now this is something interesting that you can do with a Kotlin pair, and it's called a destructured declaration. So because our pair is packaging up two things, so our book entity and then that true or false, we can declare our variables like so. Val, and then we do a set of parentheses, and we would declare the variable names for the first thing in the pair and then the second thing in the pair. So we'll say saved book will be the first one, and the second one will be is created. So that will be true if it was created and false otherwise. And you can see if we hold control and hover over, is created as a Boolean and saved book as our book entity. So what are we going to do with this information? Well, in the case the book is created, we're going to return a HTTP 201, which is the status code for an entity that's created. In the case that it's updated, we're going to return a plain HTTP 200, which means success. So let's create ourselves a new val, and let's call this one response code. And now we can use the isCreated. And we're going to do this in a very Kotlin way. We're going to use ourselves an inline if. So we're going to say if isCreated. We're going to return a HTTP status of created, else we're going to return a HTTP status of OK. And you can see response code is now a HTTP status, and we've used an inline if. So Kotlin doesn't have the concept of a ternary, so the question mark and colon format that you may see in other languages. However, it doesn't need it because you can put an if statement in a single line, and this is an expression. So you can actually then assign this if statement to a variable like we've done just here. So with that done, we'll now go about returning this. So we haven't actually declared a return type on our create full update book. So we're going to say response entity, and the type will be a book summary DTO. So we can now create ourselves a response entity. And now we can pass in our book summary DTO, which we currently don't have because we just have a book entity. So let's go back to our extensions. So I'm going to declare a new function here, and I am going to say book entity dot book summary DTO. We're going to create ourselves a book summary DTO, and let's open that up and do a split down. And we'll say ISBN equals this.ISBN, this.title, description, this.description, image is going to be this.image, and then our author is an author summary DTO. So author entity, we have two author DTO, but we don't have two author summary DTO. So we're going to have to create that function. So let's put that with our authors. There we are. So we'll say fun, author entity, author summary DTO. Author summary, open that up, put a split there, and we'll say ID equals this.ID. Name, this.name, this.image. So we've got a red squiggle, and we've got a red squiggle because our author summary DTO requires an ID that's non-nullable. However, our author entity has a nullable ID. See the question mark there. So we've got a couple of options. The first one is we can do the unsafe way and say, well, this is always coming from the database. I mean, it's going to have an ID. You will use bang bang. And if you ever find that we get a null, then we're going to get an exception. A null pointer exception. However, we should check it's not null just for it to be more readable, and then we can handle the exception that's thrown. Again, this is very unlikely to happen. Now, we can no longer do this function in a single line, so we need to declare this in the traditional way, and we'll say val, and we'll call this one the author ID, this.id, and we'll say check not null, author ID, and then we can use this author ID. However, this will throw an illegal state exception if we do find that author ID is null, so we do need to handle that. So this doesn't feel very pleasant to have to deal with the collision where something's nullable and something's non-nullable. However, here's the thing. This is the case. It's always ever been the case, even when writing Java. But with Kotlin, it's now made explicit, so we have to deal with it. And I'd say that's a good thing. So now we've got this two author summary DTO. We can use that here. And now we can take our two book summary DTO, go back to our controller, and we can return our saved book to book summary DTO. And then we can say response code. And now we've got some illegal state exceptions to deal with because we have one in our create update function and we have another in our two book summary DTO. The one in the create update is more likely to happen than the one in the two book summary DTO, but we should deal with them both nonetheless. So let's wrap this in a try, illegal state exception. And now we can decide what to do with the exception. Now, in the case of the create update illegal state exception, that's being thrown because the author ID that's been provided doesn't exist in the database. So that's a caller error. So that would be a HTTP 400. However, in the case of the two book summary DTO, we're getting an illegal state exception there because the ID doesn't exist in the database. Now, one might argue we can just ignore that case because it's very unlikely to happen, but we should deal with it properly, and we're going to need to create a custom exception in that case. So if we go to our two book summary DTO, go to our two author summary DTO, and where we've used check not null, we're going to throw a new exception. So we're going to need to create an exception. So let's create a new package, and we'll call this one exceptions, and we'll create a new Kotlin class or file, and we're going to name this one invalid author exception. We have found an author in the database without an ID. Almost certainly never going to happen. And now we'll say colon exception and then parentheses, and we can remove these braces, and that is our bare minimum representation of a custom exception in Kotlin. So we're now going to use our invalid author exception over here, and now we're going to use our Elvis operator. So in the case that this.id is null, then we are going to throw an invalid author exception. There we go. So we go back to our controller now. We have two exceptions to deal with. The illegal state exception, and we're also going to deal with, so we add another catch, an invalid author exception. So in the case of the invalid author exception, we are going to return a response entity, and that's going to have a HTTP status of internal server error, because something's gone horribly wrong if we're getting authors from the database and they don't have an ID. However, in the case of the illegal state exception, which is only ever going to be thrown by this create update in the case that the author ID provided in the request doesn't exist in the database, we can happily now return a response entity, bad request. And we format that. Very good. So we now have our create full update endpoint implemented. So let's head over to our front end and see what it's like without it, and then restart our back end and hopefully test it out and see it working. So here we are in our front end. So let's open up our DevTools and go to network here and head over to our admin panel. So this is our list of authors, and we would see a list of books here once we implement that endpoint. If we click on add book, we'll get a form to create ourselves a new book, just like we did with author. This one's a little bit different though, because we have this generate button. If we click on that, it generates for us an ISBN. So we can now put some information into this. So we'll say test book, a test book, select an author. Well, let's have Benjamin Swift. And now we'll select the image. We'll just say test image. This of course doesn't exist. So we're not expecting to see it on the card when we create the book, but it should be good for testing. So let's clear the networks panel there. And if we create book, remember we haven't restarted our backend yet. So let's see what we get. Okay, so we've got a 404 not found, and it's a put to v1 books and then the ISBN there. So let's head over to our backend, restart the application, come back here, and hopefully we'll see it working. So we'll restart the backend. Okay, that's restarted. Go back to our front end. And now I'll click on the create book button once more. Okay, we have ourselves a 201 created. We take a look at the payload. We've got an author ID of 4, test book, test image, ISBN, title. So this is a nested object, and this represents our author summary DTO. And then in the response, we can see that we've got the representation of the book with the ISBN that we've provided, test book, and then we have our author information. And this has the optional name and image provided as well. So we can see Benjamin Swift, which was the author that we specified on the create, and then Benjamin's image there. So it looks like our create update books endpoint is working fine. Let's get to testing it. So let's test our create full update book endpoint. So here we are in our IDE. Let's scroll down to our test directory. First thing we're going to need is a new class in controllers, and we'll create a new Kotlin class and call it books controller test. Now, if we open up authors controller test, and we'll do a split screen. So the approach that we're going to use to test our books controller is going to be largely the same as how we tested our authors controller. So to speed things along, we will borrow the primary constructor declaration there, and we'll also borrow the annotations from the top of our authors controller. Great. We'll also create an object mapper, just like we've done in the authors controller, because we are going to need to send some JSON representations of the objects that we have, and that should be enough for the moment. So let's close that, and we're almost good to go, but we copied this from the authors controller test, and we're on the books controller test, so we don't want an author service here, we want a book service. Great. So now we can start writing our test function. So we'll say @test fun test that create full update book returns HTTP 201 when book is created. The first thing we'll do is declare a val. We'll call this one ISBN, and we'll just put an ISBN value in there. This is one that I borrowed from the front end's generate function. Now let's set up our mock K expectations. So let's import that. Book service dot create update with the ISBN that we have provided here. We could very well use any as well. In fact, we'll use any here. Say that answers. So anytime create update is called with this ISBN defined here, and we don't really care about the book summary that's passed in, then return a pair. So the first thing in the pair is going to be a book entity, and the second thing is going to be a Boolean. We don't yet have some test data functions for a book entity like we have an author entity. So let's go ahead and create one. So let's go to our test data util here. Let's create a new function, and we'll say test book entity A. And now we'll declare some arguments. So the first thing we'll do is declare the ISBN argument of type string. And we'll make this non-nullable, so you have to provide an ISBN to this function. We'll also provide another one, and that will be our author, and that will be of author entity type. So this function just creates a book entity using the information provided, including the ISBN and the author entity. So this will now return a book entity. The ISBN, well, that will be the ISBN passed in. The title, well, let's say test book A. Description, say a test book. Image, well, that can be book image.jpg. And the author entity, well, that will be the author that we've passed into this function. So we now have our test book entity A function to use. So let's head back. So the author, let's get a reference to that. That'll be an author entity. So we can say test author entity A, and then we'll say the book will be test book entity A, we'll pass in that ISBN, and we'll pass in that author. So we now have a book to return. So we'll pass that book in the first argument of the pair. And now we have the Boolean, true if it's created and false if it's updated. So we'll return, in this case, true. Great, so that's our expectation setup. Now for our mock MVC configurations, we'll say mock MVC dot, and we're using the put HTTP verb. And now we'll declare our path, which is v1 books, and then the ISBN. So we'll use a string template, passing in that ISBN there, which is this one from up here. Now trailing lambda. Now we'll need to declare the content type and the accept type. It's going to be application JSON. Let's just copy that from the author's controller. When we come to refactor this, we can always extract this out into its own function there. But for the time being, this should make it obvious what's happening with this. This is a call that expects JSON and sends JSON. We'll also need to specify a request body. So we'll say content equals, and then we'll call our object mapper, and we'll say write value as string. Now the object mapper is going to take a Kotlin object and convert that into a JSON string. So this endpoint requires a book summary DTO. So we need to create one of those. Again, we don't yet have a test data function to create that data for us. So let's go ahead and create one. Fun book summary DTO A. I think this will take an ISBN of string, and I think this will also take an author of type author summary DTO. And this, of course, will return a book summary DTO. The ISBN, well, that will be the ISBN that we've passed in. The title, I think by convention, we'll keep it the same as up here. Image description as well. And now for the author summary DTO, which will just be the author that's passed in there. Of course, we don't yet have a function to generate an author summary DTO. So let's create one of those and let's put it up with the authors. We'll say fun test author summary DTO A, and this will just take the ID parameters like the other author functions and return an author summary DTO. ID, name, and image. So I think we will use the ones from A as a convention, so the entity A, and then the image is author image.jpg. Of course, we have a red squiggle here because in our author summary DTO, we've decided to have a non-nullable ID. So we'll remove that and we'll make it so you have to provide an ID to this function. So like that, we now have access to these two functions we can use in our test. So let's rename the book that we have up here to make it clear that this is the saved book. And now we'll declare a new val and we'll call this one book summary DTO. And it will be a test book summary DTO. The ISBN will be the ISBN that we have there. And then this will take an author summary DTO. So let's create one of those. And let's decide that the ID is going to be 1 for this author. And then we can pass the author summary DTO into this function here. And now we have a book summary DTO request. So we'll pass that into our object mapper write value as string. And we have a errant comma there, so let's remove that. Okay, so we're now sending a JSON representation of our book summary DTO, which is exactly what this create full update endpoint is expecting. And now for the expectations. So we'll say add expect status is going to be, in this case, we're expecting a HTTP 201. We want to see a failing test. So we're going to say is okay, which is HTTP 200. So in summary then, we create ourselves a book summary DTO. We send that put request to this endpoint here, specifying the ISBN. We then set up an expectation for our mock MVC to say when create update is called in our service layer, return a book entity, but more importantly, return true to say that book has been created and not updated. We then do an assert to make sure that it is, in this case, HTTP 200. To get a failing test, it should return HTTP 201. Let's see. Okay, we've got a failing test. Let's see if it's failing for the right reason. So we're expecting a HTTP 200 and we're getting a HTTP 500. So this isn't what we're expecting. We were expecting a failing test, but for reasons of getting a HTTP 201 created, and we're expecting a HTTP 200. But it looks like this is a genuine failing test, but for another reason. So we're getting an internal server error. And if we take a look through the stack trace, there's nothing obvious as to what's causing it. But if we remember from the implementation, let's go to the books controller, we do return an internal server error on an invalid author exception, which is when an author is returned from the database without an ID. I wonder, if we take a look at our expectations here, create update, answers with a saved book, test book entity A with this ISBN and this author, and it's this author which doesn't have an ID. So if we say ID of 1, this was hitting the case that we said would never ever happen. And in fact, it does happen, but it's because we've put some test data into the database there. But if we go ahead and rerun this test now, okay, we've got a failing test. Let's see why. And that's what we were expecting to see. We're getting a 201 created returned. So if we now change our expectation to be is created, rerun the test, we should get a valid passing test. There we go. Again, this is duplication, so we can refactor this later. But as a bonus, we stumbled onto a test case. And that test case is when we don't provide an ID to the author. In fact, let's update the name as well. Test that create full update book returns HTTP 500 when author in the database does not have an ID. Again, the chance of this happening in real life are tiny. However, we have a test for it, and as we stumbled across it, we might as well include it. So we've removed that ID there, and we'll keep that as is created to get a failing test. Let's run this. Failing test, let's see why. Yep, it's returning a 500. We're expecting a 201. So if we say is internal server error, run once more, we should get a valid passing test. Great, okay. So on the note of duplication, the test for the update is pretty much identical to this test here, with the exception of the Boolean that's returned. So rather than true, it's going to be false. So here's what we're going to do. We're going to take this and we'll create a private function, and we'll call this assert that user created updated, and now we'll declare some arguments. So the first one is going to be called is created, and it's going to be a Boolean, and this represents this here. So it'll be true in the case that the book was created, false in the case that it was updated. So that one's pretty straightforward. Now we want to represent this here. So is created is a function. It's an extension function, in fact. So if I control and hover over this, we can see that it's called on status result matcher DSL. It takes no arguments and it returns unit, so nothing. So because we're in Kotlin, we can use higher order functions, so we can pass in functions to functions. So how would we define that as an argument to our function here? So we'll name the argument status code assertion, and then a colon to define the type. And now we'll say status result matcher DSL. Let's go back. Status result matcher DSL. Let's import that. Dot empty parentheses, arrow, unit. So what we've done here is we've declared the status code assertion argument to be an extension function on the status result matcher DSL, a function which takes no arguments and returns unit, so returns nothing. So what we can do now is take the whole body here of our test, we'll paste it into our private function, is created, we'll place that where we've previously defined true, and our status code assertion argument, we'll place that inside status where we've previously defined is created, placing parentheses after it in order to call the function. So let's use this function instead of this body here. So what we'll do is we'll say is created, in this case, it is true. And now trailing lambda is created, and we can remove this. So if we run this, we hopefully should expect for it to still pass. Lovely stuff. And we can now copy this, create a new test function, and we'll say test that create full update book returns HTTP 200 when book is updated. In this case, it's going to be false. Now we're going to leave is created there because I want to see a failing test, but this should be is okay. Let's run this. Lovely stuff. Let's take a look, see if it's failed for the right reason. Yep. Great, so actual 200, expected 201. So it's ran through all of the logic in this test, but using the arguments we provided. So if we change this to be is okay, we should get a valid passing test now. Great stuff. So we've got a test case when the book is created. We've got a test case when the book is updated. And we have a bonus test case for when authors are returned from the database without an ID, and we make sure that a HTTP 500 is returned in that case. Now there is another code path that we need to test for in our controller. And that's when we provide an author ID in the request that doesn't exist in the database. So let's go ahead and write that. @test fun test that create full update book returns HTTP 400. We'll say when author does not exist. Great. So this one is going to be fairly similar to what we have up here. In fact, if we copy this content, it will save us a little bit of time. So first things first, let's change this expectation. So we're not returning anything when we call create update in this case, because the author doesn't exist. We are going to throw an illegal state exception. That is going to mean we don't need save to book. That is going to mean we don't need this author. We do still need a valid author summary and book summary because that's in our request. That's still needed. Now, we've got the expectation here for is internal server error. So I think we should keep that there to see our failing test, because in this case, we should get a HTTP 400. Let's run this and see what we get. Okay, we've got a failing test. Let's see if we're failing for the right reasons here. Expected 500, got a 400. So it is failing for the right reason. So we'll change this to be is bad request. Run this once more and we should get a valid passing test. Great stuff, that's passing absolutely fine. So that is a pretty comprehensive set of tests for our controller so far. Let's move on to testing our service layer. We'll go over to services impl here and we'll create a new class and we'll call this one book service impl test. Like before, let's open up the author service impl test here. Do a split screen. So just like our author service impl test, our book service impl test is going to follow the same pattern. So we're going to need Spring Boot test annotation and transactional because we are using the transactional annotation on our first function in our book service. Now, we're going to need that auto-wired annotation and we are going to need that constructor keyword. However, in the parentheses, we'll declare a private val under test, but the type is going to be our book service impl. We are going to want to create some books in the database and they're going to need authors. So we need both the book repository and we'll also have the author repository as well, I think. Great. So let's go ahead and write our first test in our book service impl test @test. So the first test we'll do is we attempt to create a book, but we provide an author ID that does not exist in the database. So we'll say that test that create update throws illegal state exception when author does not exist. Okay. We're not going to need a great deal of setup for this one because we don't need to create an author in the database. So let's do under test dot create update. We're going to need an ISBN. In fact, we're going to need an ISBN for a lot of our tests. So what we should do is go to our books controller test here, and we'll borrow this ISBN here. We'll go to test data util, and we'll declare a constant, I think, at the top of this file, and we'll call this one book a ISBN. There we go, and we can now use this throughout our tests. We can always come back and refactor those later to use that too. Okay, so create update, and we'll use book a ISBN. And now we need a book summary. So we don't yet have a test data util function to create a book summary, but we do have one to create a book summary DTO. So we should be able to create one fairly quickly. So we'll take the book summary DTO function, copy that, and then rather than return a book summary DTO, we'll instead return a book summary. We are going to require an author summary instead of an author summary DTO, however, and we'll update the name of the function to be test book summary A. Now let's also create a function to give us a test author summary as well. So let's find where we put that. Test author summary DTO. Great. Well, let's create a new function. And rather than an author summary DTO, we simply want an author summary, and we'll update the name of the function as well. Great. So let's go back to our tests and we'll say book summary equals test book summary A, and we'll use the book A ISBN. And then we'll need an author summary. So we'll say author summary equals. Now we can use the test author summary function that we've just created. However, it's typical that you will only provide the ID. So let's try and get this test as close to real life as possible and say ID equals, we'll go with 999. It doesn't really matter too much what it is because it's not going to exist in the database anyway. Say name is null. And image is null also. So finally, name and image is equal null each time. I think that'll get a bit tedious. So let's go to our author summary and do a default on name of null and the same for image as well. And that will allow us to tidy that up. Great. Okay, so we can now pass the author summary into the book summary, and we can now pass the book summary into the create update function. Now there's no point in assigning the result for create update to a variable because we're expecting an exception. So instead what we'll do is say assert throws. Now we'll say illegal argument exception, knowing that we're expecting an illegal state exception because we want that failing test. But that should complete our test. So basically passing in the book summary, which requires an author summary, to create update book using an ISBN here. But because the authors table is empty, this author with this ID clearly is not going to exist. So we should expect an illegal state exception. Let's see what we get. Okay, that's looking good. Let's see if it's failing for the right reason. Yep, okay, it's expected an illegal argument exception and got an illegal state exception. So that's exactly what we expect. So let's change the expectation and run the test once more and getting a valid passing test. Very good. Now we'll write the test for when the book is created successfully. So we'll say at test fun test that create update successfully creates book in the database. Let's set up our database to begin with. We're going to need an author that exists in the database. So we will say test author entity A. We'll not give that an ID because instead we'll use the author repository.save, passing in our test author entity A. That will generate an ID and we can assign that to a val called saved author. Great. So we now have an author saved in the database. So what we'll do is we'll borrow the author summary and the book summary from up here. But rather than the ID of 999, we're going to say saved author dot ID. Again, we have this nullable, non-nullable collision. We're in a test, so we'll use that bang, bang there. In fact, what we'll say is assert that, import that from assert.j. Saved author is not null. There we go. So it's definitely not going to be null. So we have an author summary there. Pass that in. We've got a book summary. So now we'll say under test dot create update, passing in the book ISBN and then our book summary. And we should expect to get a book saved in the database. So we'll say assert that saved book. We'll say is not null in this case, but then we'll say book repository dot find by ID or null. We'll then use the book A ISBN and we'll assign this to a val called recalled book. So we'll assert again that recalled book is not null, and then we'll assert that the recalled book. And now we have a choice to make. We have a book entity returned from the database. So we could go property by property, asserting it's got the right values. Now that would make a good test, but it would make a pretty lackluster lesson. So instead what I'm going to do is say assert that the recalled book, so the book recalled from the database using the ISBN is equal to the saved book. So the one that was returned from the create update function. This one's a little bit tricky to get a decent failure to prove that we've got a valid passing test, but I'm just going to say is null down here for the time being. So if we run this, let's see what we get. Expecting a failing test, of course. Okay, let's see if it's failing for the right reasons. Expected null, but we can see we're getting a book entity returned from the database. ISBN, testbook A, testbook, great. And there's the author entity it's associated with, which is John Doe. So it's looking good. So we'll say is not null, run this once more, and we should get a valid passing test. Oh, okay, let's see why that is. So we're expecting a book entity. Of course, we're trying to assert that a pair equals a book entity. Saved book doesn't really represent a book. It's actually a pair, isn't it? So what we'll do is put parentheses around that and we'll say is created like so. And then we're going to add another assertion to say assert that is created dot is true. Because in this case, the book is created, it's not updated. So if we run this once more, we should expect a passing test. Great. Okay, so that seems like a valid passing test. So we're asserting that the book that's returned equals what we expect it to be, and we saw it printed out. It's got all of the values that we expect it to be. And we're also expecting that the is created value returned by create update, true representing that the book has been created and not updated, is in fact true. So we've now got the create book case done. Let's now write the update book case. Now, I think this may be fairly similar. So let's start with this as a basis. Test that create update successfully creates, well, we'll say updates a book in the database. We've got a saved author in this step. We'll now get a saved book. We'll say saved book equals book repository dot. We'll say save, obviously calling the book repository directly. And now we'll need a test book entity. And the ISBN for this one is going to be the book A ISBN. And then the author entity is going to be our saved author. Great. We're reusing saved book here. So let's rename this to make things easy from saved book to be updated book. Always a danger when you copy and paste. And then we'll uncomment this. So at this point, we have a saved author in the database. So we also have a saved book in the database, and we're asserting that they're both not null. So with a book and author existing in the database, we can make sure that we're doing an update here. So our author summary has the same ID as our author. Great. Our book summary has the same ISBN as the book that exists in the database. Great. So we're calling create update, passing this information in. However, it would be good for the book summary information to be different from what's stored in the database. So we need to go test book summary A, and we'll create a test book summary B. Test book B, another test book, we'll say book image B. The author will be the same and the ISBN will be whatever's passed in, but the values will be different, and that will make for a better test. Okay, so the request to create update will be a book with different information from what we've previously created in the database. In that case then, is created, we expect that to be false because we're doing an update. We're going to keep that as is true because we want to see a failing test. For updated book, we're using the ISBN to recall the book from the database, recalled book here. And we are asserting that recalled book is equal to updated book. We would expect that to be the case. To be extra certain, we're going to make sure that recalled book is not equal to the saved book here, that it's definitely been updated. So we should still get a failing test, but we should expect it to fail here. Let's see. Okay, we have a failing test. Let's see why. Expected true, actual false, because we're getting an update. So if we change this to is false, we should have a valid passing test for this test case. Very good. So in summary then, we have a test case for when the author does not exist in the database. We have a test case for creating a book, making sure that it's created and returns the correct status, which in this case is true. And we have another test case for updating a book, making sure that it returns the correct book. And we have a test case for the update. Again, this one will return false instead of true because it's updating a book and not creating it. So with all of those tests in play, let's now move on to our books read many endpoint. And now for our books read many endpoint. Just like our authors read many endpoint, this will use the HTTP verb get and also the URL path without the ID specified. And the good news is that this one is fairly simple when you compare it to the create full update endpoint. So let's move over to our IDE and we'll start in our books controller class here. So we'll create a new endpoint and we're going to use the get mapping. And the path for this one is going to be v1 books. And we'll do a function and we'll say it's called read many books. This isn't going to need any arguments, and it's going to return a list of book summary DTO. We don't need to use the response entity because we don't need to control the response code in this case. HTTP 200 will be absolutely fine. So we're going to need a function in our service layer for this one. So if we head over to the book service, and we'll define a new function here, simply called list, and this will return a list of book entity. Okay, so if we move down to the book service import, and let's implement that member of list. Now for the basic implementation of this, the author repository gives us exactly what we need. This can then be built on in future to do things like pagination, but for our application for the time being, we can just use book repository dot, and then we can go find all, and that will return a list of book entity. We just need to use the return keyword, of course, and there we go. So with that done, we now have a list function that we can use. So in our controller, we'll say book service dot list. That's going to return us a list of book entities. We'll now call map on that one. And now we can go it to book summary DTO. Return, and there we go. That's all we need to do for our read many books. So before we restart our backend application, let's take a look at our front end application without this endpoint in play. And here we are in our front end, and this is perhaps the most obvious case of our read many books endpoint not working. Also, if we go to the list books page, naturally, we would also see the list of books here. Also, if we go to the admin panel, go to books, we would also see the list of books populated here. So if we go to our backend application and restart it, in theory, we should see some books populated here, right? So let's go ahead and do that. Okay, that's the backend restarted. Okay, I'm not seeing a list of books. Let's open up our DevTools and go to our network panel. Let's refresh this page. Okay, so it looks like we're getting on our read many books endpoint a HTTP 500. So that's not what we're expecting. So let's go to our backend application and see why this is. So if we expand this and take a look at our stack trace here, it looks like we're getting a null pointer exception. And the reason being is the parameter specified as non-null is null. And this right here is a really important lesson to learn when it comes to Kotlin. So if we go to our function here, to author summary DTO, which is in our extensions, So here is where we're throwing our invalid author exception if we find that our author doesn't have an ID, which is a nullable type, but very likely to be there if we've saved it in the database. But that's not what our stack trace is telling us. We're getting a null pointer exception, not an invalid author exception, because a parameter specified as non-null is null. And the reason for this is the author itself, the author entity, is in fact null. So here we can see we have our author entity, which is referenced by our book entity, and it's this that's null. So we've declared it in our class is non-nullable. Otherwise, we would put a question mark after it. Just because we declare something as non-nullable doesn't guarantee it to be non-nullable. In this case, we're using JPA. That's Java. And in Java, any object can be null. Now, the reason we're getting a null author entity in this case is because there's a book in the database with a null author. If you remember earlier, when we were testing out our delete author endpoint, we deleted an author. We didn't delete the books they were associated with. So we have a book in the database with a null author. And this is an important lesson to learn because especially when Kotlin code works with Java code, in Java, any object can be null. In Kotlin, obviously, there's this safety feature where we have nullable types. Just because we declare a property in Kotlin as non-nullable, especially if we're calling Java code, it doesn't guarantee the value is not going to be null. So now we have a decision to make. We could change this author entity to be a nullable author entity. That then means changing a lot of the code in our application to account for the fact this author entity could be null. Or we can deal with it another way, and we can add a constraint in our database to say that books cannot exist in the database without a valid author. And that then means whenever we get a book back from the database, we're guaranteed to get an author. And that's exactly what we're going to do in the next lesson. So let's fix this issue and see our read many books endpoint working. So we're in our IDE here, and the first thing I'm going to do is stop Docker Compose from running. We're going to do that with Control-C. And then to completely delete the environment, we're going to do docker-compose rm, saying yes, and that's going to delete these containers. So that's everything cleaned down, we're starting from fresh. So with that done, let's head over to our database migrations. Because we're still in development, we can change this. And here's what we're going to change. If we take a look here, we have the author ID field. Now this is a big in, and this references the ID field up here on the authors. That's what we've been using it for, except for there's no constraints in place. So at the moment, this author ID could be null, meaning there are books in the database without an author, which is what's causing our current issue. So what I'm going to do now is update this such that author ID in our books table cannot be null. And also I'm going to enforce that it must reference an ID that exists on the authors table. And we can do this like so. Bear in mind the SQL may change ever so slightly if you're using different databases. But for Postgres, we're going to say not null. And that makes it so author ID cannot be null. And then we'll say references, and then we'll give the name of the table, which is authors, open up a set of parentheses, and then we'll say ID. So author ID is not null, and now references author's ID, which is this one right here. So that's step one, but we still do have an issue. If we try and delete an author in the database, it's not going to delete our book. And to prove it, let's try that out. So let's start up a Docker Compose here. Great, okay, and we'll load in some test data in AdMiner now. So here we are logged into AdMiner. We can see we currently don't have any table. So I'm now going to start up the backend application. That's the backend restarted. So let's head over now to AdMiner again. We refresh this. Yep, so we have some tables in place. Let's go to our SQL command and we'll paste in here our import SQL and then we'll go execute. Okay, so if we now go back to our select authors here, select some data, there's our authors in play. And if we select from books as well, and there's our books back. Good stuff. So let's now head over to our front end. So here we are, our front end is loaded back up. And you'll notice that we are seeing some books now. So our read many endpoint is working, but we're not completely out of the woods yet. So we go back to our admin panel. And if we open up our networks panel here, and if we now try and delete an author, we can see that we get a HTTP 500 internal server error. So let's head over to our backend and see why that is. So if we take a look here, we can see the top of a very long stack trace. And this is being caused by us trying to delete an author in the database because we would violate that constraint that we've just added to the database because books cannot exist in the database without an author. And this author that we tried to delete, Margaret, does have books in the database. So how do we solve this issue? Well, it's fairly straightforward, and it just needs some additional Spring Data JPA configuration. So if we minimize this, and let's take a look at our entities. So we're in our book entity over here at the moment, and we can see that we reference the author entity here. We've got a many-to-one relationship, and we've got the cascade of detach. So what that means is if we make any changes to the author when we retrieve our book, they won't be persisted to the database. However, we do want to update our cascades. We want it so that when we delete an author in the database, it also deletes the books. But here isn't where we add that. We'd add that on the other side of the relationship. So we'd add that in the author entity. So if we head over to the author entity, so in our author entity, we can see that we currently don't have any reference to our book entity. So that's the first thing that we'll need to add here. So we'll add a new val and we'll say book entities, and we'll make this a list of book entity. And what we'll also do is I'm going to default this to an empty list, and that way we won't have to go around our code base providing values to this everywhere. It will just default to an empty list. Now in our book entity, we've used the annotation many to one because from the book's perspective, it's a many to one relationship, many books to one author. However, we're in the author entity, and this is the other side of the relationship. So we're now starting to build a bi-directional relationship. So we need to model the other side of that. So rather than a many-to-one annotation, we're going to use the @one-to-many annotation. Now we're going to tell Spring where to look for all of the configuration for this particular relationship, which just so happens to exist over here on the book entity, on top of the property here, author entity. So rather than duplicate it here, we'll simply tell Spring Data JPA where to look for this configuration. And we can do that with mapped by, and then we tell Spring Data JPA the property to look for this configuration on over in our book entity, which of course is called author entity. So let's copy that, go back, and then paste that in. Now here's the bit we've been waiting for. We can also specify the cascades in here. And we're going to say the cascade type for this side of the relationship is going to be remove. So that's to say when an author is deleted in the database, we also want to delete the books associated with that author because we can't have books in the database without an author. And with that, if we restart our application now and head back to our front end, and if we try and delete Margaret once more here, we can see that Margaret has disappeared from the authors list here. We can see that we've got a HTTP 204 no content, so a success on our delete endpoint there, and everything seems to be working okay. So if we go back to our home page, let's see if our read many books endpoint continues to work. Looking good. So it looks like we have fixed that issue. Essentially what's happened here is we've deleted Margaret, and we've also deleted the books that Margaret was associated with, so the books that Margaret had written. And with that, we no longer have that null in the database, and everything continues to work as expected. So with that now working, let's write some tests for our books read many endpoint. So let's now go ahead and write some tests for our books read many endpoint. So here we are in our IDE. So we're in the books controller here, and we can see our read many books that we've just implemented. This one's a fairly straightforward function. So if we now go over to our books controller test, we can test it. So let's create a new test here, and we'll call it test that read many books returns a list of books. And now we'll set up our mock K expectations. So we'll say every time our book service dot list is called, we will answer with a list of, and then we'll need to provide some book entity. So we'll go with test book entity A, and we'll need an ISBN. So let's borrow the ISBN from up here. And we're also going to need an author entity. So we'll say test author entity A. And because it's coming from the database, we'll give it an ID. Let's say 1. Okay. And now for our mock MVC configuration. So we'll borrow this from here. And rather than a put, this of course is going to be using a HTTP GET, and it's using the URL without the ISBN specified in there. Let's import that. Okay, we're still having a content type of JSON and an accept type of JSON because it's a JSON REST API. And let's remove content because that's not needed. And the expectation is currently set for an is bad request. So that will give us a failing test. Let's go ahead and run this. Okay, we've got a failure. Let's see why. Expected 400, and we got a 200. So that's good. So we'll say is okay. And that should give us a passing test, but I don't think it's going to be enough. So if we go over to our authors controller test here, we can see that we're using JSON path in order to assert that the content is what we expect it to be. So I think what we'll do is that again, but over here. And to make things easier, let's open up our test data. Let's split this down, open up our books controller once more. And now we can start asserting what we expect this to be. So it's going to be an array. So we'll put that 0 in there in order to access the first element in that array. It's not going to have an ID, but it is going to have an ISBN. And we can use the ISBN from up here as a part of that. That's what I expect it to be equal to. And now for our title, which we know to be textbook A. And I'll populate the rest here. And now for the author. So what's that going to look like? Rather than image, of course, it's going to be author, and it's going to return an object itself. Now, we are just expecting the author's ID, which we know to be 1 in this case, because that's what we've set up there. And also the author's name. So we're using test author entity A, which of course is John Doe. So we'll copy that. And that's what we'll expect in author name. And of course, we're also having an image in there because that's what we've decided to be returned in our author summary. So we'll also expect author image.jpg. Okay, so let's run this and see what we get. Great. Okay, we've got ourselves a passing test. So I think that's going to be enough for the moment. Let's now move over to our service layer tests. We'll go to book service import test here. Okay, and let's create a new test. We'll call this one test that list returns an empty list when no books in the database. Okay, so the setup for this one's going to be fairly minimal. What we'll do then is we'll say under test dot list, and we'll assign this to a variable called result, and we'll assert that result dot, and we'll say it is not empty in order to get our failing test. Of course, if there's no books in the database, we expect that list to give us no books at all, an empty list. Okay, there's our failing test. Let's just make sure we know why. Expecting actual not to be empty, and it was. Great. Okay, so is empty. Run that once more. Okay, so there's our passing test. Let's now add another test for when there are books in the database. We'll say test fun. Test that list returns books when books in the database. Okay, for this, we're going to need some books in the database, and I believe we've already done that up here. So of course, we need to save an author in the database first, and then we'll need to save a book. So let's copy this here, come down here. Let's now have an author and a book in the database. So we're going to say under test dot list. We'll now assign that to a variable called result, and we'll assert that result, and we'll say has size 2. Of course, we only expect one element to be in this list. We've only saved one book, but that will give us a failing test. And then we'll assert that result dot get the first element, and we'll say it's equal to the saved book that we have here. In fact, rather than get, let's replace that with indexing. There we go. So the first element in that list. Let's run this and get our failing test. Okay, let's see why. Expected size 2, but size was 1. So let's close that 2. Let's set the size to be 1, and let's run this. Looking good, we have that passing test. And that was a pretty quick one, but let's head over to our front end for one moment. So here we are in our front end. Now, if we were to click on one of our authors here, let's say Olivia, we can see that we get Olivia's description, and that's all good. And then on this section of the page, we get books by Olivia Sinclair, but we have an issue. We're currently getting all of the books returned. We can see there's one by Felix there, another one by Max. Olivia's one isn't till the end here. So we only want Olivia's books to be shown on this section. So on the authors page, we only really want the author's books to be displayed by the read many books endpoint. So let's deal with that in the next lesson. So let's make it so that our authors pages only display books by that author. So in our front end here, if we expand our networks panel, we can see when the page loads, it does call the read many books endpoint, but we can see that it also passes a query parameter with the author's ID. So in this lesson, what we're going to do is make it so that our read many books endpoint picks up on that ID and then use it to filter books and only return those books by that author. So here we are in our IDE. Let's make it so we can pick up on this query parameter. So the first thing we're going to do is inside of the parentheses of our read many books function, we'll add the annotation request param. And now we need to provide the name of the query parameter. So over in our front end, in the request here, we can see the query parameter is called author. So that's what we'll pass in. So we'll say author. And now we need to provide the variable, which we'll call author ID of type long, and we'll make that a nullable type. It will sometimes be there, it sometimes won't. Now we have access to the value of this query parameter, so the author ID, if it's been passed in, what do we do with it? Well, we'll want to pass it to our list function. So we'll want to pass our author ID to our list function and have our list function understand it, which at the moment it doesn't. So if we go over to our list function here, we'll add author ID of type nullable long. And now we need to change our implementation in order to handle this. So now we need to use our author ID within of our implementation here. So the way that we're going to do that is say author ID, and then we'll call a safe let, because it's sometimes going to be there, sometimes won't be. And now we want to call our persistence layer, filtering out books so they only match this author ID. But at the moment, a function doesn't exist for us to do that. So we'll need to add one. So let's head over to our book repository. Great, so we'll open up a set of braces here, and now we need to add a new function. And this is one of the magic things about Spring Data JPA. If we follow a very particular naming convention for our functions inside of our JPA repository, then Spring Data JPA is going to come up with the implementation of that function for us, including the SQL. So if we call our function find by author entity ID, and then pass in an ID of type long, and from this function, we'll return a list of book entities. When Spring Data JPA starts up, it will look at this function and go, find by. Okay, so we're going to find book entities by the author entity ID. Well, we know that author entity is a property of our book entity, and on author entity, there is an ID property. So what we'll do then is we'll use the ID that's passed in and use that to filter against the author entity's ID. Very clever stuff. So we now have this function available to use. So let's go back to our service layer. And inside of our let function, we'll call book repository dot find by author entity ID, passing in it, which of course references the author ID as it exists. And we'll say that if the author ID doesn't exist, if it's null, we'll use our Elvis operator here, and we'll default to just returning all of the books. If we return this should be enough for our service layer. So if author ID is provided, pass in to find by author entity ID, only returning books which match that author's ID. And if it's not provided, if it's null, then we'll return all books as we have been doing. And that should be enough to make the application work how we want it to. So if we now restart our application, that seems to have started up fine. So if we now head over to our front end, so on our front end, it looks like our read many books is still working okay there. We can see that books are being returned by multiple different authors. Now, if we click on an author, let's choose Olivia, we can see that only Olivia's book has been returned under the section Books by Olivia Sinclair. Fantastic. So let's go to another author's page, Benjamin Swift. Yes, there's Benjamin Swift's book. And I believe there's an author without a book here. So if we go to authors, I believe it was Penelope. Yes, no books yet from Penelope. So it seems to be working as expected. Let's write a couple of additional tests just to prove it. So let's update our tests for our read many books endpoint to support the new query parameter we've just added. So let's head over to our IDE here. And we're in the books controller test class. And the first thing to notice is that we have a red squiggle underneath the class name here. And if we scroll down, we can see that if we take a look at list, there's no values passed for parameter author ID. So we could go through this class and update every single time list is called. Or what we could do is add a default to null, so to return all books. And I think that's what we'll do in this case. We'll say equals null. And with that done, we can see the squiggle's gone away and all of our tests here will just default to returning all of the books. So let's just run our entire test class just to be sure. Yes, that's working fine. So let's now go down here and add some tests for the query parameter. So the first test that we're going to add here is going to test for when the author ID that's passed in matches no books. So we'll say fun, test that list returns no books when they do not match the author ID. Great. And now we need to set up our mock K expectation. So we'll say every time the book service.list is called with an author ID, and we'll say is any, and then we'll answer with an empty list. And now for our mock MVC setup. So if we take a look up here, we can borrow from here. It's going to be fairly similar. However, we are passing in a query parameter of author and then an author ID, which in this case can be anything, because we are going to get an empty list back. Let's fix that. Okay, and we expect this to be status of is bad request, which of course should give us our failing test. And we're also going to add an assertion to say that The JSON should be an empty array in this case. So if we run this test, we should get a failing test. Okay, and let's see why. Okay, we can see that we got a 200 back and an empty array as a body. Expected 400, got 200, great. So if we change this to be is okay, rerun our test, we should get a passing test because we've already seen that that content matches what we expect it to be. Very good. Let's add another test here. Test that list returns book when matches the author ID. For this one, we'll have it so when the author ID matches, we'll say 1, then we're going to return a list of, we'll say test book entity A. We're going to need an ISBN for this one, borrow from up here. We can always refactor this a little bit later. And this is going to need an author, and we'll give it the ID of 1. Doesn't make a huge amount of difference, but it's nice that it matches, even though it's a mock. With that, now let's do our mock MVC. So it's going to be fairly similar to what we have here. Instead of 999, we're going to be passing in 1 as our ID. We'll say is bad request. And then for our content, so we are expecting the book entity with the author to be returned. So we'll borrow this from here. And everything should match, including the author's ID. That's already set to be 1. Okay, so let's run this test and see what we get. Okay, there's our failing test. Let's see why. Expected 400, got 200, and it looks like the body is what we expect it to be as well. So this should give us our passing test. Let's change that to be is okay and rerun the test. We do have a failing test still. Let's see why. We still have that JSON expectation for the empty array. So let's remove that and rerun once more. There we go. That's much better. So let's move on to our service layer test now. And we'll say at test fun, and then we'll say test that list returns no books when the author ID does not match. Okay, for this one, we are going to create a book in the database, including the author to go along with it. Then we have our saved author and we have our saved book, which of course is associated with that author. Now what we'll do is we'll call under test.list, passing in the author ID. Now, we want to make sure that the author ID is different to the author that exists in the database. Now, this author could have a different ID each time. It really does depend on what the database gives us. It's almost certainly going to be 1. But just to be on the safe side, we'll say saved author.id, and because it's numeric, we can just add 1 to this. ID is, in fact, nullable. So what we'll have to do is do let it plus 1. There we go. So we're passing in an ID. This saved author here is almost certainly going to have an ID that's not null. In fact, we can see that we've asserted for it here. In fact, just to make it a little bit easier, what we'll do is that right there. So we're passing in an author ID that does not exist in the database. So we do expect to get an empty list back. So we'll say val result, and then we'll do our assertion. So assert that result, and we'll say has size 1 because we want to see that failing test, expecting it to be 0. So let's run this test. Okay, there's our failing test. Expect size 1 but got size 0. Very good. So let's change that to be 0. Run once more. Very good. And the inverse of this test is actually fairly similar. So what we'll do then is test that list returns book when the author ID does match. And in this case, what we'll do is rather than saved author plus 1, we're passing in the saved author ID. So we expect that the result should have size 1. And in fact, further to that, we'll assert that result, the first element, is equal to, in this case, it's going to be the saved book. Now we do expect this test to fail because we expect the size to be 1, but let's run this and see what we get. Okay, there's our failing test. Let's see why. Expected size 0, but got size 1, and there's our book entity. So we'll change that to be size 1. And it looks like it matches. Let's see. So let's run this test. Very good. So let's run all the tests in our project just to make sure we're in a good place. So even though the tests we've added all passed, we do have some failures. So we can't wrap up on our read many books endpoint quite yet. So if we take a look at the failures here, we can see they all failed in the author service import test. So I have a theory here. So if we look across these two author entities, they look identical. But of course, we have added this book entities property and it does have an empty list. But I would imagine that this empty list is being seen as different for some reason. There is one way of proving that out. Let's open up a set of braces here and let's use our IDE to generate, and we'll generate an equals and a hash code. Let's click on next. Now we're going to do this so it's explicit. So we're going to create an equals and a hash code and we can see the implementation there. So we're seeing if this will impact our tests. Let's run these. Okay, so we still have our failures. Now what would happen if we were to remove the predicate to match the book entities from this to other? Well, let's run our test and see. It looks like everything passes. So that tells us that it's seeing these two lists of book entities, both empty in this case, as different things. So for the sake of this application, we'll make a design decision that we're going to ignore the book entities that are associated with the author when we do an equals. And I think that should be enough to let us continue on. So with that, I think that will wrap up our read many books endpoint. Let's now move on to our read one book endpoint. So let's implement our books read one endpoint. So this is going to use the URL path where we pass in the ISBN. And when we find a book, we're going to return that book summary with a HTTP 200. And where we don't find a book, so where the ISBN doesn't match a book in the database, we're going to return a HTTP 404 not found. So let's head over to our IDE. And we can see here we have our books controller, and we're going to add a new get mapping. And then we need to specify our path. Now the path we're going to use, as we've just said, is going to have the ISBN in it. So it's going to look a little bit like this. But I noticed that we have a bit of duplication here. So let's remove the path from that get mapping. And let's remove the prefix of it from that one. And then underneath our REST controller annotation, we'll say request mapping path. And then we'll put the path in there, and that now becomes the base path for this entire controller. So the path that we're going to use is actually this one here. So let's borrow it from there, place it there. Now in our function, which we'll call read one book, we're going to need to get a reference to the ISBN that's in this path. So we'll borrow that from up here as well. And in terms of response, it's going to be a response entity, so we can control that HTTP status code of a book summary DTO. Now, we'll want to call our book service, and we'll want to call a get function on it, passing in the ISBN. Of course, that doesn't exist yet, so let's go ahead and add that. So in our book service, we'll say fun get ISBN of type string, and from here, we will return a book entity, and we'll make that a nullable type. So let's go down to the implementation and implement that. So implement members, and we can call straight through to the book repository for this one with find by ID or null, passing in that ISBN. And let's return that. So that's the service layer for our get one book done. Let's go over to our books controller. And now we'll need to deal with this nullable book entity. So we'll do a safe call operator .let, and then we'll say it dot to book summary DTO when it exists. Of course, we need to wrap that in a response entity, HTTP status OK. And in the case it doesn't exist, we'll use our Elvis operator, and we'll return a response entity of HTTP status not found, which is our 404. Just format that. And if we do return, that should be our get one book endpoint implemented. So let's head over to our front end and let's click on a book here. Let's go with Still Bonds by Felix Lee. And we can see we get 404 not found. If we take a look at our networks panel here, we can see that we're calling our get one book endpoint, passing in the ISBN here, but we don't get a book back. So let's go back to our backend now, restart the application. Okay, that's the backend restarted. So let's head over to the front end once more. Okay, so if we try clicking on Still Bonds by Felix Lee once more, great, so we can now see the page populated. The image is Still Bonds, we can see the title, the author there, and the description as well. So it looks like, if we go down here, our get one book endpoint is working fine. There's our HTTP 200 OK, and in our response, yes, we can see all of the data we're expecting for our book summary. So it looks like our get one book endpoint is working fine. Let's write some tests for it. Let's write some tests for our book read one endpoint. So let's start off at the controller tests here. So we are going to write a new test. So we'll go at test and we'll say fun. Test that read one book returns HTTP 404 when no book found. Okay, so we're going to say every time the book service dot get, and we say with any ISBN, any at all, will answer with a null. So the book wasn't found. So now we need to do our mock MVC setup. So for this one, it's very similar to what we've had previously, but this URL uses a ISBN. So let's borrow one of those from up here. We've done this a few times now. That might be a good opportunity to refactor that out later. So we have our ISBN, which I think we'll just place directly into this URL. There we go. Okay, so we're using a HTTP GET, we're using the URL with the ISBN specified, we have the content type and accept type of application JSON. Very good. So now we're going to say and expect a status of is okay. We want a HTTP 404, but let's see that failing test to begin with. Okay, there's our failing test. Let's see why. It got a HTTP 404, it expected a 200. Very good. So we'll say is not found. We run this test. Very good. So that is a valid passing test. Let's now write the test case where a book is found. So a new test, fun, test that. Read one book, returns book and HTTP 200 when book found. So we're in our presentation layer, so we are mocking. So we'll say every book service dot get, and again we'll say any ISBN. We're going to answer with, and this time we want a book. So we're going to answer with a test book entity A, and we'll need an ISBN, of course. In fact, let's change the get rather than any to have that ISBN. And the test book entity is going to need an ISBN, and it's going to need an author as well. So we'll say test author entity. We'll give that an ID of 1. Okay, so we're now getting a book back when we call our get function in our service layer. So what are we expecting? Well, let's set up our mock MVC expectations. And we've just borrowed this entirely from the previous test because the setup is going to be the same. We're calling the URL with ISBN. We're using HTTP GET. Now, we are expecting HTTP 200, but we'll leave is not found in there for our failing test. And what we'll also do is borrow this JSON path from up here, because the book is going to be identical to what we have. The difference being, of course, is that we're not expecting a JSON array, but a JSON object. So we're removing the square brackets and the 0. We're no longer trying to look at the first element in an array. We're just going to look directly into the object. So if we run this test, let's see what we get. Okay, there's a failing test. Let's see why. Expected a 404, it got a 200. That's good. So we changed the expectation of the status to be is okay. Rerun once more. Wonderful stuff. We have a valid passing test. Okay, let's move on to our service layer then. Okay, so in book service import test, we're now going to do the test when the book doesn't exist in the database. So we'll say fun, test that get returns null when book not found in the database. Okay, for this, we don't need to save any books. So that's always good. So we're going to do under test dot get, and then we'll pass in an ISBN. So we'll borrow the ISBN from book a ISBN, which, to be entirely honest with you, would probably be a very good thing for us to use in our controller as well. Again, a great opportunity for us to refactor that later. So we'll say get book a ISBN, and that's everything that's going to be needed in there. We'll assign that to a result, and we'll say assert that result, and we'll say is not null, because we want to see that failing test, because of course we expect it to be null. Great, so it got a null back, so we run that, we should get our pass. Very good, so that's a valid passing test. Let's write another test case for when the book does exist. So we'll say test that get returns book when the book is found in the database. Okay, so we're going to need a book and an author in the database for this one. So we'll borrow that from up there. So we now have a book and an author in the database. So we're going to say under test.get, then we'll need to pass in the ISBN, which we'll use the one from the saved book. And then we'll assign that to a val called result. Okay, and then we'll go assert that result, and we'll say is null. Of course, we expect result to be an actual book because we saved one in the database. Further to that, we'll say assert that result is equal to the saved book. So, expecting a failing test, let's run this. Okay, there's our failure, and we can see we expected a null, we got a book entity back. So we'll now say is not null. In fact, we can just remove that in its entirety and say it's equal to saved book. Great stuff. So let's just run all of the tests in our project to make sure we're in a good place. Very good. So we now have our get one book endpoint implemented and tested. Okay, with that done, let's move on to our book partial update endpoint. So let's implement our book partial update endpoint. This one is going to use the HTTP verb patch and is going to use the URL structure where we specify the ISBN. So let's head over to our IDE. So the first thing I'm going to do here is specify a new patch mapping. And the path for this one is going to specify the ISBN. So let's copy this from there. And we'll say fun partial update book. So we're going to need to get hold of that reference to the ISBN. So let's take that from up here as well. And now we need a representation of what's to update on our book. So if we go over to our book summary DTO here, we have a ISBN, title, description, image, and then the author summary DTO. Now on this endpoint, we're going to say that you can update a title, you can update a description, and you can update the image. But you can't update the author on the partial update endpoint, and you can't update the ISBN. So it's going to be these fields that we'll need to represent in our partial update. Thing is, much like how we did on the author, these need to be nullable, because the thing with a partial update is we could just update the title, or we could just update the description, or we could update a combination of all three of these things. So ideally, we need a new DTO to represent these because we don't want to make these properties nullable on our book summary DTO. So that's where we'll start. So let's go to our domain here, and in DTOs, we're going to create a new Kotlin class file, and we're going to call this one book update request DTO. And we said it's going to be the title, description, and the image. So we'll copy those from our book summary DTO. We'll make our book update request DTO a data class, open up a set of parentheses, and then we'll paste in our title, description, and image. We will, of course, change the types from being a string to a nullable string by putting that question mark after each one. So we now have our book update request DTO. Let's go ahead and use it back in our books controller. So this is going to model the representation of our request body. So we'll use that at request body param, and then we'll say book update request DTO of type book update request DTO. And let's format this a little bit. Now, in terms of what this is going to respond with, we're going to respond with the full book summary DTO. So we'll say response entity book summary DTO. And we'll call our book service here, but of course we don't yet have a function to do our partial updates. Let's go ahead and create one of those. So let's go to our book service, and then we'll define a new function called partial update. And we'll need to specify the ISBN of the book that we're looking to update, and then we'll need to specify the representation of our update. Now we've created a book update request DTO, but we don't yet have an object that we can use in our service layer here. So we're going to have to create a new one of those. Let's take our book update request DTO, we'll copy that, and then we'll paste that into our domain package, just calling it book update request. So we'll then say this takes a book update request and it responds with a full book entity. So the representation of the book as it's been updated. So let's go to our implementation. Let's implement those members, and let's get to implementing our partial update function. So the first thing that we'll do is we'll call our book repository here and just make sure that the book that's been specified by the ISBN actually exists. So we'll say book repository find by ID or null, passing in that ISBN there. And we'll assign that to a val called existing book. And then we'll call the check not null function on our existing book. The check not null function, of course, will throw an illegal state exception if it does find that our existing book is null. So we can be confident at this point that the book does exist in our database. So let's go ahead and look to update it. So just like we did in our author service, we're going to say existing book dot copy, and then we can specify the properties that we'd like to update if they exist in our book update request. So remember our book update request here, we can update the title, description, and image, and each of these properties are nullable. So the first one that we'll do is the title here, and we'll say book update request dot title, and then we'll use our Elvis operator. So in the case that it's null, we're just going to default to whatever the existing book's title was. So there's title. The next one that we're going to do is the description. Description, book update request, description, Elvis operator, existing book dot description. And then finally, of course, it's the image. So we'll say book update request dot image, Elvis operator, existing book dot image. And we'll assign this to a val called updated book. Now, of course, a book entity has other properties on it, the ISBN being one of them. The copy function will just default to whatever is on the existing book. In this case, if we haven't specified the ISBN inside of the arguments of the copy function, it will just be whatever is on the existing book already. So we've got our updated book entity. We just need to go ahead and save it now. So we'll say book repository dot save, passing in our updated book. And this will be what we return from our function. And there we go. That is our partial update function implemented. Let's now go to our controller and use it. So here we are. We'll say book service dot partial update, passing in the ISBN from the path. And then of course, we need to pass in a book update request. We currently only have a book update request DTO. So we'll need to write an extension function to go from one to the other. So let's go down to our extensions, do a new function, and we'll say book update request DTO dot to book update request. And then we'll do an equals and we'll say book update request. And then we can specify the three properties. So title equals this.title, description equals this.description, and then finally image equals this.image. So we can now use the to update request function. So we'll call that back in our controller, remembering to import that. So let's assign that to a val called updated book. So if all goes to plan here, we'll have our updated book, but we do know that the partial update function can throw an illegal state exception. So we're going to wrap this in a try catch block, and we'll catch that illegal state exception. And in the case that we do get an illegal state exception, then we're going to return a response entity, HTTP status bad request. And then back in our try here, we will return a response entity of the updated book to book summary DTO with a HTTP status of 200 OK. There we go. And just like that, we have implemented our book partial update endpoint. So let's now go over to our front end and see what it looks like when this endpoint doesn't work. So here we are in our front end. Let's go to our admin panel here. Let's open up our networks panel as well. Now let's go over to the books tab. And if we were to update the name of the title, for example, Still Bonds, let's update that to be, I don't know, Still Bonds with a Z. And then if we were to click on save, we can see that we've got that patch request sent to V1 Books and then the ISBN with the payload of a new title, just the title specified here. But of course, we have a bad response at HTTP 405 because we haven't restarted our backend yet. So let's go over to our backend and restart that. Okay, that's our backend restarted. Let's go back to our front end. Right, let's update that title once more to have a Z in it. Now, let's click on save and see what we get. Okay, let's look at our networks panel. Great, so we can see that we've got HTTP 200 from our update request. There's our HTTP patch with our URL with the ISBN specified. In our payload, we can see the new title. And if we scroll down, we can see that we've got a new title right there. Now, if we were to go to our books page and take a look for it, we can see, yep, it's updated there. Yep, we can see that new updated title. So it looks like our book partial update is working as expected. So let's write some tests for it. So let's now write some tests for our books partial update endpoint. So we're here over in our books controller test, and we're going to create a new test here. And we're going to say @test fun backticks test that book partial update returns a HTTP 400 on an illegal state exception. So first, let's set up our mock K expectations. So we'll say every time, our book service.partial update is called. And now we're going to specify the arguments to expect. This time around, we're going to say book a ISBN, remembering that was a value that we stored in our test data from a little while ago. So we'll use that here. And then the next thing we're going to expect is a book update request. So let's create a book update request, and we'll say book update request equals book update request. And we'll write this to specify a new title. So we'll say title equals, and then the string, a new title. Now, it'd be really nice to not have to specify all of the arguments each time. So let's go to our book update request and default these all to null. There we go. So we now have our book update request. So when we get this particular book update request with this particular ISBN, what are we going to do? Well, we're going to throw an illegal state exception. Okay, so now we have our mock K expectation set up. Let's now do our mock MVC. So let's copy this from up here because we're still using that JSON REST API. And now we get to specify the URL. So we are using the URL with the ISBN in the path, but this time around, we're going to use book a ISBN in our path. So content type is good, accept is good, but we're also going to want to specify the content. And this is going to be a book update request DTO. So let's create one of those, val book update request DTO. equals book update request DTO. We'll specify a title. Now, arguably, we could just convert our book update request to JSON because it would largely be the same, but let's just make sure that we use a book update request DTO anyway, because that's what we're going to expect inside of our class. I think what we'll do is assign a new title, that's string, to a variable there, and then we can reuse it over here. Again, let's go over to our book update request DTO and default these all to null as well. So now we can use our object mapper. Dot right value is string, and then we can pass in our book update request DTO, and that will send the new title in the body of our request. So when our request goes through, what do we expect to happen? Well, in this case, we'll say status is okay. Of course, we're expecting a HTTP 400, but we're going to say is okay, so a HTTP 200 to get our failing test. So let's run this and see what we get. And we have a failing test, but not for the reason that we think. And this is because we have a mock k no answer found for bookservice.get. Yes, I didn't change the get to a patch, the dangers of copy and pasting. So let's run this again, see what we get. Okay, there's a failing test. Let's see why. Expected a 200, got a 400. So that's great. So we change that to be is bad request, rerun our test. Great, so we have a valid passing test. So let's move on to writing a test for the success case, shall we? So we say fun, test that book partial update returns a HTTP 200 and the book on a successful update. Okay, so this test is going to be really similar to what we have already written. So let's copy that and paste that down here. So we go through this. We have a book update request and we have a book update request DTO. Of course, we're still going to need both of those. Now, every time we call partial update with the book update request, what do we expect to happen? Well, we're not going to throw an exception this time around. We're going to answer with, and it returns a book entity. So we're going to need a book entity as well. So we'll say val book entity, and we'll say test book entity A. We'll make sure this has got the same ISBN. And it's going to need an author, so we'll say test author entity A, and we'll assign the ID of 1 to that. So we're going to answer with this book entity. So that's going to pretend to be that success case where we've updated a book. The data might not completely match up, but it doesn't matter too much for this test. We can deal with that a little better when we go into our service layer. So this has done a successful update, and we've got our book entity back. So what do we expect to happen here? Well, we expect to get HTTP 200, so we'll leave that is bad request in play for the moment to get a failing test. But we're also going to get the book returned. So if we go up here and if we borrow these assertions here and place those underneath our status, we'll need to change that to use book A ISBN. So this otherwise is the test book entity A. So this should assert on the book as we expect it to be returned. So let's run this test and expect it to fail. Okay, there's a failing test. Let's see why. Expected a 400, but got a 200. Great. So we'll say is okay, and let's run this. All right, we have a valid passing test. So that's it for our book controller test. Now let's move on to our service layer test. So here we are in book service impl test, and we'll say at test. And we'll say test that partial update throws an illegal state exception when the book does not exist in the database. So the setup for this one's going to be pretty easy. We don't need to create any books in the database. So we'll just say under test dot partial update. And then we'll need to specify an ISBN. So we can use book A ISBN here. And then we will need a book update request. So let's create one here. Now we could add this to our test data, but as we're only specifying a single property in our book update request, I think it's just as easy to do this. Book update request title, and we'll just say a new title. And now we'll need to make sure that we expect that assertion to be thrown. So we'll say assert throws. And we're expecting an illegal state exception, but we're going to say an illegal argument exception to get a failing tests. And then rather than parentheses, we want some braces, and then we'll put that test inside those braces. Okay. So when partial update is called, there's nothing in the database. So we're trying to update a book that doesn't exist in the database. That's when we'd get an illegal state exception. We're asserting for an illegal argument exception, a different exception, to get our failing test. Let's run this. Okay, there's our failure. Let's see why. Expected an illegal argument exception, got an illegal state exception. So that's exactly what we expect to see. Let's change that to be illegal state exception. Rerun our test. Very good. There's our valid passing test. So let's now move on to when we do an actual update on our book. So let's say at test fun test that partial update updates the title of an existing book. Great. So for this, we're going to need a book in the database. So let's borrow from up here. Of course, a book needs an author. So we'll save both of those and make sure they're saved. So we now have a book in the database. Remembering this is our test book entity A. So the title is test book A. What are we going to do? Well, let's borrow our book update request from up here with a new title. Of course, that's a different title. And let's paste that down here. So we've got an existing author in the database, an existing book with a different title to this, which we'll assign to a variable all its own, which we'll call new title. And we'll assign this to a variable called result. Now for our assertions, so we'll say assert that result title is equal to, and we'll just put something in there that we expect it to not equal for the time being. We can swap out that for new title if we find that we got a failing test. So let's run this and see what we get. Okay, let's take a look. Expected 3 question marks, but was a new title. So it has updated successfully in the database. So let's swap that out to a new title and we should get our passing test. Okay, so that seems to be passing absolutely fine. So let's now do the test for the other 2 properties. Now, this is actually a fairly straightforward test. So what we'll do to get us moving is say test that partial update updates the description of an existing book. Saved author, saved book, and then we'll say we've got ourselves a new description. So the description on test book entity A is a test book. So we'll just say a new description. And then book update request won't be title, of course. We're updating the description this time around. And we'll say partial update, sending our book update request, assert that result.description is equal to, and then we'll do our 3 question marks to get our failing test. Okay, there's our failing test. Expected 3 question marks, but was a new description. So if we now swap that out to be new description, run our test once more. Great, there's a passing test. So let's now copy and paste this. Of course, we can always refactor this out a little bit later, perhaps doing something similar to how we've done in our authors service to use a private function to capture some of the shared logic between these tests. But for the time being, we'll say test at the partial update, updates the image of an existing book, saved author, and then we've got saved book, and then we'll say new image. We'll say a new image. Rather than update the description, we're updating the image this time around, and then we'll do 3 question marks, asserting that the image is equal to 3 question marks. Let's see what we get. There's our failure. Expected 3 question marks, but was a new image. So if we now swap that out, run our test once more, there we go. We have a passing test. So if we run all of the tests in our project to make sure we're in a good place, looking good. So with that, we now have an implemented and tested book partial update endpoint. So let's move on to our book delete endpoint. So let's implement the last endpoint on our books controller. Let's implement our books delete endpoint. So this is going to use the HTTP verb delete, and we're going to use the URL structure where we specify the ISBN in the path. When we call this endpoint, we're going to delete a book and return a HTTP 204, no content. And we're going to do this regardless of whether or not the book existed in the first place. You see, by the end of the call, we don't want a book to exist in the database. If it didn't exist in the first place, well, it can't exist by the end of the call. And if it did exist in the first place, we're going to delete it anyway, and then return that HTTP 204. So let's move over to our IDE. We're going to specify a delete mapping here, and the path is going to be the one where we specify the ISBN. So let's copy this from up here and place it in here. Now we're going to say fun delete book, and this is going to need the ISBN path variable as an argument here, but that's all we're going to need. And in terms of responses, we'll say response entity of type unit. Okay, let's open up some braces. Now we're going to need a function on our book service to delete a book. So let's go over to our book service and let's define a function here called delete, and it takes an ISBN and it doesn't return anything. So we could say unit, but you'll see that the IDE grays that out because it's simply not needed. Let's go to our implementation and let's implement those members. Right, so for the delete, we're simply calling through to the book repository. Book repository.delete by ID, passing in the ISBN. There we go. So back in our controller now, we can say book service.delete, passing in the ISBN, and then we'll say return response entity HTTP status of no content, which is HTTP 204. And it's no content because there's simply nothing to return in the body there. And just like that, we've implemented our books delete endpoint. So let's go over to our front end and see what it looks like before we restart our back end. So here we are in our front end. Let's go to our admin panel. Let's go to the books tab here. Let's clear down our networks panel to start with. And then let's look to click on one of the delete buttons next to the book. So Max's book's at the top here. So let's delete Mundane Dolphins. Okay, we have a HTTP 405. So we can see that we've used the delete HTTP verb here, and we're using the URL structure with the ISBN specified. But of course, we've got that HTTP 405 because we haven't yet restarted our backend. So let's go ahead and do that now. Okay, that's our backend restarted. Let's go back to our front end. Okay, so the particular book that we're looking to delete is called Mundane Dolphins. Remember that name because we're going to go looking for it a little bit later. So let's click on delete now and see what we get. So the call has gone through and we've got a HTTP 204 no content returned. And if we look at our list here, we can no longer see Mundane Dolphins. If we were to go to our bookstore and look through the books, so we can see Frostbound Odyssey, Skybound Rivalry, Whiskers of Destiny, but there isn't Mundane Dolphins in sight. So it looks like that book has been deleted. If we go over to our authors and find Max here, and go down to the section Books by Max Williams, we can see there are no books yet, so that book has been successfully deleted. So it looks like our books delete endpoint is working as expected, but let's wrap up by writing some tests for it. So let's write some tests for our books delete endpoint. So here we are in our books controller test, and we're going to specify a new test here, fun, backticks, and we'll say test that delete book deletes a book successfully. Okay, so let's start with our mock K expectations. So we'll say every time our book service dot delete is called with any ISBN at all, we're going to answer with nothing at all because there isn't anything to be returned from this particular function. So with that done, we can now move on to writing our mock MVC part. So what we'll do is we'll borrow the top half of the function from up there. Now we're not sending any content in this one, and we're not using patch, but we're instead using delete. We are using the URL structure where we specify the ISBN. For the sake of being a little bit more accurate, let's pass in that to our mock K expectation as well. So delete using the URL structure where we specify a book A ISBN, which is that ISBN from our test data. We're using content type and accept type of application JSON because it's a JSON REST API, and we're expecting a is okay. Well, we're actually expecting a HTTP 204, so that's no content. So this should be enough to give us our failing test. Let's see. Okay, there's a failing test. Let's see why. Okay, expected 200, but got HTTP 204. So if we now change this to be is no content and run the test once more, there's our valid passing test, looking good. So let's move on to our service layer now. So here we are in our book service import test, and we're going to do two test cases here. We're going to do one where the book exists in the database and we delete it successfully, and we'll do the second test case where we try and delete a book that doesn't exist in the database, expecting them both to pass. So let's start with the case where the book does exist in the database. So fun, test that delete successfully deletes a book in the database. So for this, we'll need a book in the database. So let's copy that from up here. So we now have an author and a book in the database. Let's look to delete it. So let's do under test dot delete, passing in the ISBN of the book, which is book A ISBN. And now what we'll do is say book repository dot find by ID or null, looking for the book with the book A ISBN as its ID. We'll assign that to a variable called result, and we'll assert that result, and we'll say is not null. Of course, we expect this to be null because once it's deleted, find by ID or null will return null. So let's run this test and see what we get. Okay, there is our failing test. Let's see why. Expecting actual to not be null, and it was. So if we change this to be is null, run this once more, there is our valid passing test. Looking good. So we'll now do our second test case at test fun test that delete successfully delete a book that does not exist in the database. Of course, you can't technically delete something that's not there, but I think that describes the case that we're going for accurately enough. So don't need to create a author or book in the database this time. So we'll just copy this from up here. We'll attempt to delete a book. Book A ISBN. This will not exist in the database. and we're going to say is not null. So before we run this test, you might be wondering, well, find by ideal null will return null at the beginning of the test as well, because the book doesn't exist at the beginning of the test. Well, what we're really looking for in this test is to make sure that we don't get any errant exceptions thrown, because if we do get an exception thrown from this particular delete function, because we're trying to delete something that doesn't exist, that could cause problems for us elsewhere in the application. So let's run this and see what we get. Okay, we have a failing test. Let's see why. Expecting actual to not be null. So if we change it to be is null, run our test once more. There we go. We have a valid passing test, and it looks like an exception is not thrown. Everything seems to be working as expected. So let's run all of the tests in the project to make sure we're in a good place. Great, and everything seems to be passing. So that wraps it up for our books delete endpoint. Congratulations, that wraps it up for our course. If you're ready to unlock even more value, then check out the description below for details on the advanced lessons. If you're looking for another free course here on YouTube, then why not check out the Spring Boot for Beginners course that goes into even more detail on using Spring Boot with Java. I'll see you over there.